meeting is being streamed. So there is PowerPoint as virtual background under advanced options. So when you put share screen under advanced options, there is PowerPoint or PowerPoint as virtual background. Yes.
Yeah, now it is working, no?
Yes,
yeah,
sir. Yes, sir.
Yeah, just a minute.
Yes, sir. Yes, sir. It's come. It is visible, sir.
Yeah.
Yeah.
Now it's working, no?
Yes, sir. Yes, sir. It
Okay,
is visible,
okay.
sir. Okay.
Yeah.
Ma'am, should I start with the introduction?
Yes. Just a minute.
Just a minute.
Okay, ma'am. Yes, it is coming now.
Sir, your slides are visible now. No problem.
So it is visible. It is coming also.
Okay.
No, just a minute. Just a
Sir,
minute.
shall we start?
Shall we start? Oh God, what's this?
What's this?
Oh.
Sir, you may go back to your first slide.
So yes, the first slide. Okay. Yes, this one.
Sherry, you may start.
Yes, ma'am. Yes, ma'am. Good morning to all the. Okay, just a minute. Okay. Good morning to all the dignitaries, Principal Dr. Pradnya Prabhu, HOD of Chemistry, Dr. Madhvi Kate, professors, and all the participants. Myself, Cheryl Mascarenhas, would like to welcome you to the second day of the National Conference on Chemistry for Sustainable Development. It is an honor for me to introduce the speaker for session 4, Dr. Dibakar Goswami, who would be giving a lecture on ionic liquids, green solvents for sustainable future. Dr. Dibakar Goswami received his PhD degree from the Homi Bhabha National Institute, HBNI, Mumbai in 2011. During his doctoral research work, he extensively worked on asymmetric synthesis of bioactive molecules. He has been instrumental in the development of metal-mediated Barbier reactions in green solvents. Currently, he is working as a group leader at the Nuclear Materials Research Group in the Bioorganic Division at Bhabha Atomic Research Center, BARC, where he is associated with the research program for the development of novel ligands for the use in radiopharmaceuticals, as well as developing drug delivery vectors for iron overload diseases. He is a recognized guide at the Homi Bhabha National Institute and has authored more than 50 publications in leading international journals. Dr. Dibakar Goswami, we welcome you.
Sir, you are muted.
Now,
yes, sir, you're on mute.
Now it is okay, no?
Yes, sir.
Okay. So thanks for such a nice introduction, and thanks to the organizers for giving me such an excellent opportunity to give a talk on sustainable things. So the topic of today's talk is this ionic liquids, green solvents for sustainable future.
Can't see your screen.
Yeah. Hello.
No, okay, it's fine.
Yeah. So, so shall I proceed?
Yes, sir.
Okay. So to start with, we should first understand what sustainable future means. So United Nations have defined for 17 distinct goals for sustainable development. And these sustainable goals includes societal, economic, and environmental improvements. Like if you go into this 1 to 17 goals of the sustainable development, you can see that it encompasses goals like this no poverty, zero hunger, good health, including different environmental things like climate action, life under water, life on land, etc. So now, if we put these goals one after another, then the biosphere or the environmental goals forms the base of the pyramid. And so the societal and economical developments are actually grown on the top of it. That is, the environmental things are actually doing the most important thing in providing a sustainable future. So in the environmental things, the goals which I have are improving the life on Earth, improving the life in aquatic life, and also improving the life of all the creatures that actually exist on Earth. So this is in turn gives you a indication that we need to do something for environment to provide a sustainable future for our future generations. So what we can do? As a chemist, we are at the aim of the society where we can directly contribute to the sustainability. And the part of the chemistry which actually gives you the sustainable future is called as green chemistry. So in a nutshell, the sustainability is all about meeting the needs of the present generation without encompassing the need of the future generation, without compromising the need of the future generation. So what we can do as a chemist is to provide a green environment. And to provide a green environment, you or us as a whole, we have to provide a solution to the environmental problems. And the fundamental approach should be to prevent the pollution. And how this pollution comes? It is all from the chemicals. And every pollution, most of the polluting things are chemical in nature. So we have to get rid of those chemicals which creates the pollution, or have to minimize the pollution. So this is actually chemistry's unique contribution to sustainability. And this green chemistry is so important that you will have these publications on green chemistry, and these publication houses actually have very, very high impact factor journals which publishes exclusively green chemistry articles. And in 2020, the January issue of the Science was dedicated to exclusively to these green chemistry articles. So what is green chemistry? Green chemistry is green, of course. Green means environment, so we have to make this environment green. So how do we make this environment green? So we can make this environment green by reducing the waste, reducing the material, reducing the hazard, reducing the risk, reducing the consumption of energy. And of course, if we can do all these things, we can reduce the cost. So why reducing cost is important? That is to give you a better, give you a development in economy. So that is another goal. That is the third goal of this sustainable future. So that is why green chemistry is green chemistry is contributing to everywhere, like in sustainable things. So Anastas actually gave a very good demonstration of green chemistry, very good definition of green chemistry, that green chemistry provides a framework for learning about green things and designing or improving materials, products, processes, and systems. So he actually tabulated 12 principles of green chemistry. So if you go through these 12 principles, you will see that you have to prevent waste, you have to increase the atom economy, you have to use a less hazardous synthesis, you have to design benign chemicals, you have to design benign solvents and auxiliaries. So because in a synthesis, the most important things which we use a lot are chemicals, solvent, auxiliaries. So these are the three things. And of course, we provide energy for the reaction. So we have to design the things such a way that the energy efficiency increases. That is, we have to give a less amount of energy. And more importantly, we have to use renewable feedstocks. Renewable feedstocks means carbohydrates, cellulose that are renewable. So we have to reduce the derivatives. So if we put more number of derivatives in a synthetic stream, the number of steps increases, and so that actually affects the environment. So we have to reduce the derivatives. We have to use catalysis, of course, because catalysis gives you lower amount of chemicals to be used, and so it improves the environmental things. So you have to design for degradation of the chemicals which are waste. Of course, there will be some waste and byproducts, although minimized, it will be there. So you have to design for degradation of that. Real-time analysis for pollution prevention should be there. There are some parameters which actually give you a real-time analysis for pollution prevention, how efficient your synthetic scheme is, and for a personal thing, inherently benign chemistry for accident prevention. Likewise, if you see different synthetic schemes for a particular step, you have different synthetic chemicals that you can use for these reagents. So we have to choose some reagents which give you the benign chemistry, and that does not lead to the accident. So the ionic liquids actually why it I will come it later, but these are some of the point number 5 is actually taken care by this ionic liquids. So what are ionic liquids? If we go through the two distinct things like ionic solid and ionic liquid, we can see that in ionic solid, the crystal lattice is so ordered that it has a high melting point and it is tightly bound. So it has a very high melting point. For example, in sodium chloride, the sodium ion and chloride ion tightly bound, and so this has a high melting point. You cannot get a molten salt out of it unless you heat it to 900 degrees. But if it happens that we can reduce the interaction between the anion and cation and we can make a non-crystalline lattice, so then the interaction between the cation and anion will be less, and so the melting point will come down. So that is the fundamentals of ionic liquid, where you can use a non-crystalline lattice. So as you can see, the positive ions are big and the negative ions are smaller, and so they are less tightly bound, and so the melting point comes down. So cations and anions in ionic liquid are not as tightly packed as in ionic salts, and a combination of an asymmetric cation and a symmetric cation gives you ionic liquid. So as you can see from this picture, the yellow background picture, if you can see that the cation is of asymmetric nature and the anions are symmetric. So there are less interaction between the cation and anion, and so the melting point decreases. So for common cations which we use generally in forming an ionic liquid comprises of everything you can think of, like quaternary ammonium ion, quaternary pyridinium ion, quaternary and then imidazolium ion, and phosphonium ions, sulfonium ions, everything. But the major most important thing is this should be asymmetric. Like that is why the R groups which are attached on the nitrogen atoms or the oxygen or the sulfur atoms are different in nature. So you have to differentiate between R1 and R2 to make it asymmetric, so that this cation is asymmetric, and you can use any anion of your choice, like starting from halide, triflate, you can use BF4, you can use PF6, everything. Only thing is that the nature of the chemical ionic liquid will depend on the nature of the cation and the anion. So, of course, these properties of the ionic liquids will depend directly on the cation and anion part. So, what are the advantageous properties of ionic liquid? The most advantageous properties of an ionic liquid that it is ionic in nature, and so it has a very low vapor pressure, and so it is non-inflammable. Like in organic solvents, which are used generally for synthesis, has a very high vapor pressure, so it is volatile in nature, so it is damaging to environment, and they are flammable. They are molecular solvents and they are flammable. So from ecological consideration and safety point of view, ionic liquid provides you a unique solution to the environmental problem. It has a very low melting point and very high thermal stability. The melting point can vary from -10 to 100 degrees centigrade. So accordingly, by choosing your cation and anion, you can vary the melting point. And it has, since it has a very high thermal stability, it means that you can heat the reaction or at an elevated temperature without decomposing your solvent, which is not possible in many of the organic solvents that we use. Thirdly, since this is ionic, it can dissolve a variety of substrates and reactants, starting from organic substrates to inorganic substrates. For example, if you are doing some reaction with an organic substrate using, say, K2CO3, so in a organic, if you do it in an organic solvent, then the organic reagent will dissolve, but K2CO3 will not dissolve. But in ionic liquid, it can dissolve both of the substrates. So it gives you a facile reaction. And very, very importantly, they have tunable physicochemical properties. Because of your choice of a large number of anions and cations, you can tune the physicochemical properties of a ionic liquid according to your requirement. So likely you can adjust the viscosity, density, acidity, everything. So these are very advantageous as an ionic liquid. So that is why the ionic liquid has been applied to many of the fields that you can think of, starting from separation media. Say if you are using a hydrophobic ionic liquid, you can separate, you can do the separation using water, so that ionic liquid does not dissolve, but your aqueous things comes into, but your inorganic things comes into water. So these has been widely used as a separation media. Electrolytes is very important because these ionic liquids you can design in such a way that it has a very high electrochemical window, and you can use them as an electrolyte. They can be used as a fluids. They can be used as an advanced materials for liquid crystal display, artificial muscles, pharmaceuticals, etc. But what I am intended to show you some examples are about the application in green solvents. So as you can see from the number of publications that has happened from 1990s to 2019, you can see a jump in publication, a sky high number of publications happening after 2020. So these actually gives you the importance of an ionic liquid. So as I have told you that I will give you some discrete examples of ionic liquids being used as green solvents in organic media. And those things have been carried out in our lab. So I'll give you a brief introduction later. So if you see at the history of ionic liquid, like how ionic liquid has evolved from the from 1980s to 2000s, this first generation ionic liquid were mainly aluminum tetrachloride salts. where this imidazolium ammonium tetrachloride salt or chloroaluminate salts, these were the first generation ionic liquids. They are of course hydrophilic and they got dissolved in water. The second generation ionic liquid that came was imidazolium cation with BF4 anion. So they are very air and moisture stable ionic liquids, and they had many applications. So now till nowadays, these combinations are one of the most sought after combinations in ionic liquid. The third generation ionic liquid, which came afterwards, are some task specific ionic liquid. That is, the ionic liquids are designed in such a way that they will perform a specific task. So that is the task specific ionic liquid. So ionic liquids, after many researches and many developments, have been adapted by industries in some of the cases. Like in 1985, where the dimerization was dimerization of alkene, they used this BMIM AlCl4. As I have already shown that this is the first generation ionic liquid, and these were used in nickel catalyzed dimerization of C4 fractions. Likewise, in 1995, a phosphonium ionic liquid was used for the synthesis of 2,5-dihydrofuran in Eastman Chem Company, and this is till now they are using the same method. And the most delicate or most what you can say that advantageous application of an ionic liquid, it is the Bacille process that is being used by BASF in the synthesis of phosphide. So if you can look at the reaction, so this is a reaction where the phosphides POH2 is formed from PCl2. So they are using two moles of alcohols to produce this, and they will get phosphides. But along with that, they will generate chloride ions as a byproduct. So to trap that chloride ion, they used imidazole. So once these chloride ions are getting out of the reaction, they get trapped into imidazole, forming a imidazolium chloride ionic liquid. So as these imidazolium chloride ionic liquids are hydrophilic, they get separated from the reaction medium, and so according to Le Chatelier principle, the reaction is going to the right side. And so by this way, they have increased the reaction yield by something like 30 or 40%, which is a huge margin. And BASF is the pioneer of using this procedure. So as I have already told, I will be talking something about this using ionic liquid as a solvent in organic synthesis. So this is the simplest example. Like in our lab, we were very interested in doing Barbier allylation. So what is Barbier allylation? Barbier allylation is, as you can see, this is an allyl halide reacting with a carbonyl group in presence of a metal, solvent, and activator, giving either the alpha product or the gamma product. So alpha and gamma, of course, are regioisomers. So people were using, till now, people were using different metals like zinc, indium, gallium, bismuth, etc. And as solvents in PHF, mostly. In water also there were some depots, and in some room temperature ionic liquids, there were some depots. And they are using activators like ammonium chloride, chlorides. They were using microwave ultrasonication as metal activators. So why we are at all interested in such a Barbier allylation? The reasons are that these are alternative to aldol reactions. These are operationally very simple, because you can put metal along with the allyl halide and the carbonyl together in a reaction vessel and stir it. So after some hours, like 4 or 5 hours, you can get the products directly. And of course, you have to separate it. You have to work up it. I mean, so you have to separate it in some separation media and then purify it by your column chromatography. Those things are there. But these are operationally very simple. And of course, this includes this in situ organometallation. Like this metal is inserted into the CX bond, and that gives you the active organometallic intermediate, which adds up to the carbonyl group. And these products, these alpha products and gamma products, are very much used in natural product synthesis. So as I have shown you some selected examples, these homoallyl alcohols, the products, are utilized in synthesis of many of the natural products. So we thought that why not to use a room temperature ionic liquid, a designed room temperature ionic liquid for this thing. So what we did is, first we have to see what are the problems in doing it in organic solvents like THF. As I have shown you in this table, that we utilized a simplest aldehyde like benzaldehyde and used allyl bromide to get this homoallylic product in THF solvents using different metals like zinc, indium, gallium, bismuth. But you see that yields are not very high. They are giving only 70 to 75% yield. And more importantly, you have to use metal and the reagent in a very high excess. This is really environmentally damaging, because at the end of the day, you are discarding the metal and excess reagent to the environment. So we have to get rid of this. We have to design something which gives you product using stoichiometric reagents, so that no reagents are left after the reaction. And also you have to get rid of this organic solvents. So what we did is, we synthesized different ionic liquids, starting from BMIM Br, that is butyl methyl imidazolium bromide, that is a hydrophilic ionic liquid. And from this hydrophilic ionic liquid, we produce two different hydrophobic ionic liquids like BMIM BF4 and BMIM PF6. As you can see, that just changing the anion part of that thing by BF4 or PF6, you get different ionic liquids with different properties. So when I use these ionic liquids in using different metals, as you can see, the BMIM Br, which is the hydrophilic ionic liquid, gives the best yield of the products, and the yields were increased almost to 80-85%. And more importantly, what we were looking at, that we could reduce the amount of the reagent to a large extent. Allyl bromides we are using in 3.5 equivalents in THF, whereas here we can reduce it to 1.5 equivalents. And also allyl bromide is somewhat volatile. So that is why during the reaction, some of the allyl bromide gets out of the reaction vessel. And so this much excess is required. Otherwise, we could have done it with stoichiometric amount. And as you can see, for indium and gallium, we could use substoichiometric amount of metal. For indium, it was only 10 mole percent indium was required. And for gallium, it was substoichiometric 0.5 equivalent of metal was used. So at the end of the day, you are using lower amount of metal. And so that is environmentally, you are improving the criteria of a green chemistry. So the advantages that we saw is you can use substoichiometric metal or stoichiometric reagents. And as I have already told, that you need to have some metal activator. Those are chemicals, and if you can get rid of that metal activators, nothing like that. So we could complete the reaction without any activator. We had high yield, easy separation, of course, because when you do it in ionic liquid, you can just put some solvent like ether or something, and so that your products come into the ether layer, you decant the ether layer and you get your product. So very easy separation. And of course, these ionic liquids are reusable. Once you get all the products from your ionic liquid layer to the ether layer, so you of course reuse the ionic liquid at least for the 5-6 times. We have done at least for 5-6 times, and there are no variation in the reaction outcome. So we have started from this India-mediated reaction. So India-mediated reaction were done in several substrates using several allyl halides, And you can see that high yield of the products were obtained using only 10 mole% of indium. That is the most important. So you can have catalytic metal, and of course the reactions can be done without using any activator. So these were also tried in using gamma substituted allyl halides, and also there also we could use catalytic metal to complete the reaction, and of course no activator was needed. So where from this metal activation is coming? No activator. So who is activating the metal? Then here only the role of the ionic liquid comes into picture. So as you can see, the imidazolium ionic liquid, if you can see that this is the spectra, this is the proton and carbon spectra of a pure imidazolium ionic liquid. So when we incubated indium with this ionic liquid, there were upfield shape in the imidazolium core protons and carbons. And that actually told that there were some dipolar interaction between the metal and the imidazolium core, giving rise to such a dipolar species. And when this allyl bromide is added to the mixture, this allyl bromide actually, this indium is inserted into the allyl bromide metal, of course the activated indium, and so you get this allyl indium species, the active organometallic species, and this ionic liquid is restored. So after incubating it indium, we saw a field shift in the NMR spectrum, and when we put allyl bromide, the spectrum of the ionic liquid is restored to its original position. So it is showing that this ionic liquid is not a spectator solvent. It is actually participating in the reaction. It is actually activating the metal. So our next aim was how this indium is getting recycled, because we are using only 10 mole% of the indium and we are completing the reaction. So to get a glimpse of the active organometallic species, we have done this NMR experiments, and the active allyl indium species which we got from the solution are this 1 and 2. That is the allyl indium and the allyl indium dibromide species. So now we have to find out the explanation that how this indium metal was regenerated. So then we have deduced a reaction mechanism where this, after formation of this allyl indium intermediates, they were reacting with the aldehyde to give you the product. Now comes this BMI-MBr factor. So this BMI-MBr is actually getting converted to BMIM-OH, producing INBr, that is IN1. And this, and remember that we are using only 10 mole% of the metal. So only 10 mole% of this BMIM-Br is getting converted to BMIM-OH, and rest of the things are as it is BMIM-Br. So this BMIM-OH is a basic ionic liquid. So this BMIM-OH is producing this carbene. It is known that BMIM-OH produces carbene, and that is a mixture of carbene and water. So this BMIM-Br, when it produces the carbene, this carbene actually reduces the indium species and produces again this active organometallic species, and thus maintains this catalytic cycle. So as it, if we can see the overall reaction, the indium produces the active organometallic species and produces the product. In turn, the BMIM-Br participates in this reaction to give you this BMIM-OH and a small amount of B2 BMIM-Br, and these two species were actually isolated from the reaction mixture and characterized. So if you see the catalytic cycle, this activation of indium and the reduction of the indium to the indium-1 species so that it can maintain the catalytic cycle are actually done by this ionic liquid. So ionic liquid is not only a solvent, but also it takes part in the reaction actively. So this was the first time we could show that that ionic liquids are not a spectator solvent. It is actually participating in the reaction. So coming to the gallium metal mediated Barbier alylation, we have already seen that the gallium metal is required in only 0.5 equivalent, that is in the substoichiometric level. So we have done we have done the reaction with different substrates, and we could see that we could get a very high yield of the product, no metal activator required, and BMI-MBr was the best room temperature ionic liquid among those chosen. This gave higher yield of the product with shorter time, and of course it was complete with substoichiometric amount of gallium. So activating role of BMI-MBr, we did it in the same way, and you could see that this is the same way as was in indium, that the metal is forming a dipolar complex, and so the metal is activated. So this activated metal in turn forms this allyl gallium species, and so metal this ionic liquid is restored, as was in the case of indium. And by using this proton NMR spectroscopy, we could isolate, we could characterize this allyl gallium bromide species, active allyl gallium species, and we found that this is the diallyl gallium bromide species. Now you see that here you have two allyl parts joined with a single gallium. So this will react with 2 moles of aldehyde, and that is why 0.5 mole of gallium is enough to complete the reaction. But here, an unnatural thing happened. And what happened is that during the reaction, we saw that a grayish precipitate is coming out of the solution, although very less, but it was coming up out of the solution. So we isolated this grayish precipitate and characterized it in different techniques like DSC, FTIR, NMR, Raman spectroscopy. And we could found that gallium is actually attached with this imidazolium moiety, forming this particular complex. Sorry. So this particular complex was formed. And how it is formed? So this can only happen when you have a carbene species as an intermediate. So how this carbene species is formed? And this is formed from this ionic liquid in presence of oxygen. And so this oxygen is actually taking part in this reaction and forming the carbene. And so once this carbene is formed, it is forming the grayish intermediate like carbene gallium complex. And this carbene gallium complex is actually catalyzing this reaction from this gallium. So that without adding this carbene gallium complex, the reaction is very slow. So it is formed in situ and the reaction is faster. So what again I am trying to tell is that this carbene from ionic liquid was formed, and these ionic liquid are not an innocent solvent. This is actually participating in the reaction. So this was the first example where a carbene was formed without addition of a base, because we did not use any base to abstract the hydrogen from the imidazole, and then the carbene was formed, and that was actually catalyzing the things. So we use these methods for chiral aldehydes. Likewise, in a mannitol-derived chiral aldehyde, cyclohexylidene glyceraldehyde was subjected to allylation using these methods. And as you can see from indium and gallium, you can see that indium, gallium, and bismuth, and particularly for gallium and bismuth, you can see this C stereoisomer and the B stereoisomer are we have got these stereoisomers exclusively in almost 90 and 80% stereo selectivity. So otherwise it is very difficult to get so high stereo selectivity. So we have utilized this B and C stereoisomers for synthesis of various bioactive materials. So that is the beauty of this ionic liquid, that it provides you very good stereo selectivity also. So now coming to another aspect, that we are using some very novel hydrophilic ionic liquid, and that was giving you this gamma product. As I have already told you that this allylation can give you either alpha product or the gamma product, and gamma product formation we have already seen. But what about the alpha product formation? We have not got any alpha product. It is known that in acidic conditions, in presence of Bronsted or acidic or Lewis acid, you can have this alpha product. So we thought whether we can use any hydrophilic Bronsted acidic ionic liquid for forming this alpha product. So we utilized the same BMIM-Br and incubated with heated it in presence of H2SO4 to exchange the anion to HSO4. So as you can see, this is the cation and this is the anion. So in anion, this is HSO4. So it is becoming a Bronsted acid. So when we did the reaction in Bronsted acid, we got the alpha product and gamma product both, but the alpha product in a very high regioselectivity, like in up to 99% of alpha product. So we got very high regioselectivity and very high yield, of course. And importantly, we could reduce the amount of the ionic liquid to only 20 mole %. And we are not using any other solvent. So we were taking the aldehyde, taking the allyl bromide, and had put 20 mole % of the ionic liquid, and we could get the alpha product in a very high regioselectivity. Since it is solvent free, you can easily take out your product in some organic solvent and purify it accordingly. So how it is happening, we have used this para-ethyl benzaldehyde along with this crotyl bromide or the gamma methyl allyl bromide to see the formation of both alpha and gamma products in NMR spectroscopy. And as you can see, in 3 hours, that is the lower one, this 3 hours, gamma products are more. And when the time increases to 12 hours, the formation of the alpha products were seen, and eventually in 40 hours, all were alpha products and no gamma products were seen. So we could see that this initially the gamma products are formed, and in presence of such a Bronsted acidic ionic liquid, the gamma products are getting converted to the alpha products. How it is happening? That of course the metal activation was likewise, as I have discussed earlier, that is the dipolar interaction giving rise to the activated metal, and it forms the active allyl metal complex, which adds up to the aldehyde to give you the gamma product. Now these gamma product in presence of the Bronsted acidic ionic liquid undergoes rearrangement to give you the alpha product. So here again the ionic liquid, the acidic part of that ionic liquid was actually responsible for conversion of this gamma product to the alpha product. So I will give you another example of a task-specific ionic liquid. So these were all the examples about this using as a solvent. Here I will show you an example of a task-specific ionic liquid. So as you know, we work in DAE, and dissolution of plutonium from the aqueous medium or recovery of plutonium from aqueous medium is extremely important in nuclear industry because of the strategic things. So initially we had thought that how to use an ionic liquid to get the plutonium dissolved in ionic liquid and then get recovered. So using the in silico approach, that is the computational approach, we have seen that plutonium is actually forming a very good complex with betaine. So betaine is a chemical, is a ammonium salt, and which forms a complex with plutonium. So we thought that since we need to extract plutonium from the aqueous solution, we will prepare a hydrophobic room temperature ionic liquid, and of course a betaine base, so that it can chelate the plutonium and give you the plutonium complex in the ionic liquid phase. So we designed a betaine triplet hydrophobic ionic liquid using a betaine hydrochloride and lithium NTF2, so that this is formed, this betaine NTF2 complex. And so we utilize this hydrophobic ionic liquid to extract the plutonium from the aqueous solution. So now that was extracted, definitely using by this plutonium betaine complex. But extraction is not only the thing, we have to recover that plutonium from the ionic liquid. So as I have already told, that ionic liquids has a very high electrochemical window. So here the black line indicates the electrochemical window of the beta in ionic liquid. So in presence of plutonium, we can via electrolysis, we could electrodeposit plutonium in a pure form without any interference from americium and also americium. So that is the alpha spectra. This is the alpha spectra of the stainless steel planchet after electrochemical dissolution of plutonium. So this is a beautiful example of a task-specific ionic liquid, which is very important for the DAE applications. So this is all, but definitely we have to look for some advantages and disadvantages of ionic liquid. As advantages are more, because you have these ionic liquids are highly versatile. They are of course very task specific. You can make it task specific definitely. They are having very wide electrochemical window, so you can use these ionic liquids for variety of applications. They are air and moisture stable, so application wise this is very important, and of course they have wide applications. But there are many disadvantages also. The cost of the ionic liquid is very high, the commercial cost of course. But if you can make the ionic liquid in your lab using a very benign or very cheap commercially available things, then you can reduce the cost of course. But commercial cost is very high. So that is a major disadvantage of this ionic liquid. Also, the toxicity of the ionic liquid, particularly these hydrophilic ionic liquids which are being used, are having very high toxicity both to the aqueous and the human things. Particularly if you use high alkyl chain substituted in your ionic liquid, that will be toxic. So there are reports, and their toxicity we have to take care of. And because of that, the low industry adaptability, as I have shown you, only 3 industrial applications of ionic liquids are there. There are more coming up, but they are not till in the industrial stage. So low industry adaptability is an important thing. So we have to design the scheme in such a way that they are adaptable to industries. Otherwise, these ionic liquids will be a part of your lab, will not go to the society, and so it will not give you the benefits of a sustainable future. So that is why I am putting a question mark for green solvents for sustainable future thing. Because unless we take care of these disadvantages, it cannot be a green solvent for a sustainable future, particularly the toxicity part. So what are the alternates? You can use water, of course. Water is the greenest solvent on earth, and it is in plenty. But actually, many of the synthetic part, you cannot do it in water. As you know, that there are many reagents, there are many products which are moisture sensitive, so you cannot use water as a solvent. Another thing that is coming up very recently, that is deep eutectic solvents. Deep eutectic solvents are something where you put 2 solids mixed together, heat it to some 40-50 degrees centigrade. So they are hydrogen bonded together to form a liquid. So that is a deep eutectic solvent. That is also coming up. And of course, supercritical carbon dioxide is another solvent which is also getting accepted to chemists. But again, ionic liquids are the things which can be tuned. The deep eutectic solvents, water, supercritical carbon dioxide, cannot be tuned to whatever you want. So that is the major advantage of an ionic liquid. So we have to take care of the disadvantages and bank on the advantages of the ionic liquid to make it a very green solvent for sustainable future. Thanks for your attention. Thank you.
Any questions Yes, there is a question, sir. Does
Yeah.
deep eutectic solvent work like ionic solvents?
Yeah, that's a good question. But see, these deep eutectic solvents are something which has recently come up. So people are using these deep eutectic solvents for synthesis and for some other purposes also. A task-specific deep eutectic solvent is something which has not till come up, but someday it will come up by designing a beautiful deep eutectic solvent. But the problem is that deep eutectic solvent, for making deep eutectic solvent, you have to mix two solids which you can derivatize, but at all they have to bond it through hydrogen bonding together to form this. So if you derivatize it in such a way that it cannot make the hydrogen bonding, then that is of no use. So tunability is a major factor in deep eutectic solvents.
So there is another question.
Yeah.
Surface active ionic liquids are good replacement of surfactant. Like, are they a good replacement for surfactant?
Yeah, not at all, because of the toxicity. Because the surfactants are something which you are using in aqueous medium and discarding it in aqueous environment. So because of the aqueous toxicity of ionic liquid, this feature has not been accepted so much by the scientific community. Although you can see that you can put a long chain hydrocarbon and a imidazolium cation kind of thing to make it a surfactant, but that is not at all a good accepted because of the toxicity. And of course the cost.
Any more questions? Okay, so I think there are no more questions.
Okay.
So on behalf of the Department of Chemistry, KJ Sumaya College of Science and Commerce, I would like to present a formal vote of thanks to Dr. Dibakar Goswami for taking his time out of his busy schedule and giving us such an informative lecture on green solvents for sustainable future. So explain to us the principles of green chemistry, which is very important for us as chemists. So also explain how Barber reactions can be possible with stoichiometric ratio of metal and using imidazolium ionic liquid as a solvent, causing less harm to the environment. This lecture will definitely help us as chemists in our future research, as the use of green solvents, that is ionic liquids, is a need of the hour. As the years go by, our research also needs to move towards more greener and environment-friendly methods. Thank you once again, sir, for this wonderful lecture. Thank you.
Good morning, one and all. Welcome to today's event, National Conference of Chemistry for Sustainable Development. I am Suraj Yadav. It's a great pleasure for me to introduce you our today's speaker, Mr. Sopan Ray, who is going to talk about plastic and sustainability. This is a subject in which we should all be deeply interested. Who is going to talk about the plastic and sustainability. This is a subject in which we should all be deeply interested. Sir has received BE in Mechanical Engineering from Assam Engineering College, Guwahati in 1972. He did his postgraduate diploma in management from IIM Bangalore in 1976. So today's speaker, Mr. S.K. Ray, has nearly 45 years experience in petrochemical industry, managing business, strategic planning, business development, corporate affairs, and other related functions. Superannuated from the Reliance Industrial Limited in 2016 as a senior executive vice president. At the present, mentoring a newly formed team on sustainability. He is honorary secretary at Indian Center of Plastic in the Environment. He was worked with the Indian Petrochemicals Corporate Limited from 1976 to 1993, managing business for PE, PP, PVC, ABS, engineering plastic, product development, market development, logistic management, new project. He is the past chairman of the Governing Council of India Institute Packaging and Autonomous Educational Institute in the field of packaging under Ministry of Textile and Commerce, the Government of India. He is also visiting faculty member of Academic Council at Somya Vidya University. So please welcome Mr. Sopan Ray. I request him to start the session. We are excited to hear you, sir. Thank you.
Thank you, Mr. Roderick, for that kind introduction. Maybe a lot of it tells about me that how ill-equipped I am for this particular conference. With my background, nowhere reflecting anything about chemistry, nothing reflecting about polymer chemistry. So this is a challenge that I have, but I must thank Sugandha Madam for inviting me to this event, and it would be a pleasure to share with you some of my thoughts in this space of plastics and how it gets related to the environment and sustainability issues. So good morning to all of you once again, and a belated happy Earth Day. We had Earth Day yesterday celebrated, so belated happy Earth Day to all of you. And I must compliment the Department of Chemistry at our university, Somya Vidya Vihar University, for taking up this laudable initiative of bringing in a lot of very knowledgeable people in this space of understanding the role of chemical as a whole. People outside this industry with limited understanding of chemistry always have a kind of apprehension about the products of chemistry. And Professor Yadav was here yesterday, I believe. He keeps on giving an example of drinking a glass of dihydrogen monoxide and scaring people off if they don't have any background in chemistry. So with this little bit of this thing, I'm really delighted to be here, very happy to be here. At the same time, bit apprehensive because some of you are very strong background in chemistry, which I personally lack. So I'm trying to take one part of the chemistry space, like plastics, and try to relate it with the ongoing deliberation discussions we have in terms of sustainable development. So let me take a moment to share the screen, and if I face any technical glitch, do help me out. Let me try and first try to do that. Yes, here it is. Okay, I don't have any
Sir, you don't have sharing rights?
I have. No, I'm just, yeah, I have sharing rights. I can see that. I was wondering whether I should select that video option. Yeah, I have selected. Then what happens? Can you see
Yes,
the
sir.
screen? It's visible?
Yes, yes, sir. Yes.
Okay,
It's
I
visible.
click on the show mode and then we proceed with this session.
Yes, sir.
Okay,
Perfect, sir.
am I, is the
Yes.
slide visible and I'm audible, right?
Yes, yes.
So, Sugandha madam, thank you for once again for inviting me to this conference. What I am trying to do is trying to relate, as I said, the plastics and how it gets related to our quest for sustainability on this planet. Plastic, as I mentioned about chemicals earlier, is often a not adequately understood product of chemistry. And that is where there is a lot of perception. And we believe that that is going to go away over a period of time, and we'll be able to really derive the benefit that is this new generation of materials are offering to us with limited or negligible impact on the environment. All human activity, whatever we do, all human activity has some environmental impact. It also brings some benefits. It is for us to really address the issue of limiting the impact it has on the environment and maximizing the benefit that we can derive from this new generation materials. So what I have in this presentation is basically broadly three, four areas. I'll try to present a prologue, based my perception, how I find what is sustainability is all about, a very brief manner, and then talk about a little bit of plastics. Most of you here in this audience with a chemistry background would be more knowledgeable on the subject of plastics than what I am. But with my association with this industry for last 40-45 years, I'll try to bring in those learning, experiential learning that I had on plastics to this audience. And then we'll talk about a little more details on sustainability, debate on that, discuss on that, and see how plastic gets related to our quest for sustainability on this planet. And at the end, there may be one or two slides where there will be a bit of an epilogue. So this is the structure of my deliberation session today. And then let's look at the first part of it. Sustainability, there are many definitions. In our business context, we have a sustainability definition which is very different than what we have when we are into the environmental science space. It's very different. So there are, and the differentiation, it is not a hard kind of definition which is there. It's an abstract concept, and if being an abstract concept, it is also vulnerable to multiple interpretation. What I interpret as sustainability from business perspective could be very different than the concept of sustainability from an environmental economist perspective. A social science perspective, they could be very different. So it has got different potential of interpreting in a different way, because it's a concept which is an abstract concept. Something like justice. Justice is an abstract concept. When I'm punishing somebody, the person I'm punishing may not feel that it is justified. I don't think. So these are some of these concepts which are very, very abstract in nature. And being abstract in nature, it is vulnerable to different interpretation, and it is very difficult to get a common interpretation which one can pursue globally. Broadly, what means? It is to sustain, ability to sustain, ability to endure. Very simple dictionary definition of sustainability. But the one which is very prevalent today and widely accepted in the world is the one which was defined by this lady, very powerful lady, Harlem Brundtland, in her report. She was the chairman of that committee, which was from the United Nations, the common future. Most of you, I would presume, you have read this. Some of you, if you haven't, have a look at it. It's a very, very nice, very, very powerful report which she had presented to United Nations as the chairman of the committee. And here she defines It is the meeting the needs of the present generation, our generation, your generation, some of you, without compromising the ability of future generations to meet their needs. So what we consume today, that consumption should not impact the potential possibility of the future generation meeting their needs. So this is broadly the concept that we definition that is widely accepted across the globe. Now, having said that, we also need to look at the context, and the context is more of a theoretical construct that I'm presenting here today. Is basically talking about taking care of the planet, taking care of the people, and also in the process, keeping the economy, the engine of economy going, so that the people's needs are met without compromising the quality on the planet that is resources that is already there. Some of us use this Venn diagram and say that it is the environment which is overarching entity. Within that entity, we have equity between species, human being, insects, other animals, plants, and within that sits the economy. So economy is something that should take care of both equity as well as the environment to thrive. For an economy to thrive, it has to really address the issue of equity. It should also address the issue of environment, because it's the overall environmental context that the living organisms are there, and within that living organism, the human organization of the economy is resting. These are very theoretical things. People would have a better understanding of this. Some of you from environmental science discipline would have a very good grasp on this concept, but this is the context I thought let me just present briefly. Moving on to, it is a three-dimensional system. That's what I'm trying to emphasize. Moving on, this might look very elementary to some of you. Nevertheless, I'm going to take that risk of getting into some of the basic elementary understanding of plastics. Plastics are new generation materials. There is no doubt about it. Plastic is, we are using in India plastic for last 50 to 70 years. The first invention of plastic, okay, let me take the slide. Its first invention of plastic was in 1907, which was a thermosetting plastics, phenol formaldehyde. But you look at the timelines of use of different material over the history of human civilization. Stone was the first one. Okay, we were using as a human being, the first material that we were acquainted with was stone or naturally occurring twigs, leaves, the wood. You know, those are the natural. Everything is there naturally occurring. So that was our material base at that point of time in distant history. But during industrialization and subsequently, we started getting used to copper, gold, bronze as metals, and then iron as metals. From Stone Age, we came to the Iron Age, and then subsequently we moved into a stage which is a bit controversial. I call it a age of synthetics, because we have a lot of synthetic material with us. And mind you, just 1 second, let me try to get that. Okay, mind you, these are sometimes debates crop up that we should use material which is available in nature. The material which is available in nature is wood, stone, leaves. Those are the ones which are available in nature. Rest of the material that we use are made by man. I cannot have copper as it is. Copper is mined, so human being is involved in that. Gold is mined, human being is involved in that. Bronze, all the metal that we see, all the paper that we see, all the glass that we see, they are not natural product. They are made by people, and people made this, or human being made this to improve the properties of the material that they were using in past. Stone was inefficient in hunting. Stone was inefficient in agriculture practices. So we had to had human ingenuity gave us that advantage of getting copper, getting gold, getting bronze, getting iron. So we shifted from a very rudimentary kind of material age to an age which was relatively much more advanced than what the humanity was used to. And eventually today, all of you are all chemists with a chemistry background here, all of you would appreciate that you people created a revolution in terms of synthesizing material to meet human needs. And you, all of you should be proud of it, that we have made this synthetic material which has removed some of the deficiencies of the traditional materials, removed some of the deficiencies of the naturally occurring materials, and got a range of materials with us: synthetic fibers, synthetic rubber, plastics, a construction material, all these things you people with your scientific knowledge have been able to deliver to the humanity, saying that these are the products which are much more efficient in their use, and that is the reason why you're using it so extensively. But our responsibility does not end there. Our responsibility goes beyond and trying to understand that how do I also look at nature? How do I also look at my planet and make the planet a sustainable place to live for me today and for the future generation tomorrow? So plastic is basically a very new generation material. It's a new generation material. So a lot of us, even within this chemistry science space, many of us have inadequate appreciation of plastics. And outside our fraternity, obviously there is humongous amount of ignorance about plastics, and that creates certain problems that we need to address, not only based on science, but also based on social science perspective. We'll deal with that. We'll just deep dive into those when we go to the section where we talk about plastic and sustainability. I just if some of you, not from a polymer science or chemistry background, there are two types of plastic. Thermoplastic. Thermoplastics can be shaped, reshaped. Thermosets cannot be shaped, reshaped. Once it is shaped, cannot be reshaped. And it's a polymer from a monomer that comes up. We join the monomers together and get into polymers, get into this kind of product, and from there we make different articles that we use on a day-to-day basis. This is one point I would like to emphasize, that plastic, as I mentioned earlier, is a family of material like metal. And from metal, from different metals, we make different products. Similarly, from different plastics, we make different products. And as mentioned earlier, in some places, we have the same product made both in a traditional material as well as in this new generation material called plastics. So we have same product with different functionality and affordability. I have used all along this tiffin box in my school days, college days, even working the initial part of my working life. But today, a lot of people use this because number one, it is more affordable compared to this. And the other things that are the properties which make plastic products more desirable, I'll try to list them out. But important thing is that sometimes we confuse, we say ban plastic. It's a very common this thing we will find across many many space that ban plastics. There we try to say that ban certain plastic products which might be problematic for us. But we, in our drill to really move forward, we say, okay, ban plastics, and that creates certain kind of dichotomy in us to understand why am I saying ban plastics, and it has got very negative implication as well. So then we tend to get a kind of perception that the plastic is bad. Whereas we see the plastic has a lot of properties because of which we use them, and some of those properties are extremely critical for our survival, and we will see some of those in some of the future slides. So it is important to differentiate between materials and the product made from those materials, whether it is metal, whether it is glass, whether it is paper, whether it is whatever wood, they are material, family of material. And then we make some wooden chair, we make some steel cutlery, those are the things that we make. So the differentiation is important to keep it in the back of our mind. Now, how do I? Okay, now the reason to use plastics, most of you know this, is just a repetition possibly for you, and could be boring at times. That same thing I'm hearing again and again. First, it was invented because of its insulation properties. It has got good insulation properties, both thermal insulation as well as electrical insulation. That is the first property for which plastic was initially used by human being. Then we also found that it has got very good barrier properties, barrier to oxygen, barrier to water vapor, the two very critical input that actually impacts the that actually affects the product, food product quality. If there is oxygen ingression or it is a moisture ingression into a packet, then the food gets spoiled very soon. So barrier properties was the next thing that we found very useful for plastics. Then we also saw that plastic is very light in weight. This one is a very, very important feature of plastics. It is 1/3 the weight of aluminum and 1/8 the weight of steel. So being very light, it has got huge implication in terms of its impact on the environment. And we will tell in little more details in some of the subsequent slides. I would love to have a case study shared with you, which I very often do. Some of you might have also seen it in past in some of my presentation, but we will go into that and try to understand what are the implications of being something which is very light in weight. So it has got huge implications on that. Then it is durable, destructible. This is the phrase we'll very often hear. It is indestructible, and so it is bad. We want durability. Because of durability, we produce plastics. Because of durability, we use stones. They are not destructible. They stay there. And because of those properties, we use plastic. We can program it to make it biodegradable, but that was not the intention, and that need not be the intention for all the applications. We do not need biodegradable. I don't want my bucket to get rusted in 2 months' time in my bathroom. I do not want my wooden chair to get rot in a couple of, if I keep it outside for a couple of monsoons. We don't want that. So that is the reason we use plastics in those kind of applications. So durability is a desirable property in most of the applications. In some applications, it creates problem, and not it is because of its durability, because of other factors also impacting. And we'll focus a little bit on those factors which are also impacting. But we can make biodegradable plastic. There is no, science is evolving, and we are doing a lot of work in the space of biodegradable plastics. But will that be a solution for all? Will that same size fit everyone? No, it is not. So we'll have to be really selective about it. And then it is also very safe and hygienic, and this is a key property of plastics. It is safe, it is hygienic, and that is the reason we use it for medical applications. We use it for food contact applications, because it is safe and hygienic. So you have a large number of products. All around us, we have plastics. We are using more plastic products than any product made out of alternative materials. Even at home, if you take a tour of the home, you'll find there are more plastic products at home, in your kitchen, in your houseware, in the bathroom, everywhere. And the reasons are very clear because of all these factors. Plus, it is also very affordable. For a poor person, a plastic chair is more affordable than a wooden chair. I see a lot of people sitting in the plastic chair because some of them cannot afford a wooden chair. Some of them cannot afford a steel chair. They find a plastic chair is still affordable. Some people are in such a shape in India, in many other poor countries, they cannot afford a chair itself. But if they can afford a chair, it will be the plastic chair that will be his or her first choice because it is affordable. So you can see all these because of these moisture barrier properties. I have eaten bread from a wax paper wrapped bread packet. Now it's all polyethylene, which is a wrapper used for this. The bucket, as I said, because it does not rust, it is in my bathroom, and it is also very light in weight. So it becomes very convenient for me to handle that product. So it is both light in weight as well as it is more durable. Same is the case with a chair, which is more durable and lightweight. It can be easily handled. An important thing, these are also these become affordable also because of other factor that it is very easy to make this. A wooden chair, I have to make this leg, 4 legs. I have to make this seat, I have to make this backrest, and then nail them together or glue them together. It takes a lot of time to make a chair, whereas this chair can be made in just a few minutes in injection molding machine. Same is the case with the buckets. And that is the reason, as I said, it is the design flexibility that of the plastic material offers, the production efficiency that it offers, that we are able to make large number of products, make it more affordable, so that people who otherwise are handicapped in terms of their resources can also afford some of these products. So if I ban plastic chair, nothing will happen to possibly a person like me. I can always go and buy a wooden chair, absolutely no problem. But a poor man will have difficulties. And same thing happens with many of the plastic products which are used, like a carry bag. A carry bag is used by poor students in the rural areas to carry their books and notebooks, protect it from the vagaries of weather, sun or water. So these are the things that are there, and because of this, we are facing huge amount of challenges in terms of understanding why we're using it. And if we have understood why you're using it, how we manage it is something which is a big challenge, which is being faced because, again, I'm repeating, these are new generation of materials. Understanding of these materials, its protocol of handling is still evolving in the humanity, in the human species as a whole. Some of you would be quite knowledgeable, you know how to do it, but a lot of people are not as knowledgeable about plastics, and they do not know how to use it properly, how to use it more responsibly, so that we, at the end of the day, we keep the sustainability perspective while using these products. I guess I need to move a little faster because otherwise we'll lose a lot of time. So let me go very quickly. All of you know, we have just spoken about it. Plastic products are used in all sectors: agriculture, consumer goods, medical care, Medicare, transportation, industrial, building and construction. Wherever you see all around us, we see plastic products. They're ubiquitous in their presence in the human society. And as I said again, that this is because they bring in certain properties which are desirable for those kind of application. Let me come to this section, because this section, I hope I can take a little longer for this particular section. So let me go in a little bit of details in this. Plastics and sustainability. All of us, we know we have 17 SDGs, Sustainable Development Goals, accepted by the world community. India is a part of it. 1 to 17. My personal view is a tough job. First of all, having 17 goals simultaneously pursuing them is something is a humongous task for global community to achieve. Nevertheless, we are ambitious. We want to achieve some of those goals, and in some areas, progress has been relatively good, but progress had been uneven in many of the other sectors. And excuse me, Prof, I'll call you back in a meeting. So success has been uneven across these 17 areas. And if you look at it closely, chemistry plays a vital role in achieving these all 17 SDGs in some way or other. They are connected. You cannot remove chemistry from here. And definitely you cannot remove plastics from here as well. And I could quickly go through this, and I could find that there are nearly 7 or 8 areas where plastic has a visible, significant impact in achieving those sustainable development goals. And those are all marked here. Zero hunger is one, then good health and well-being is one, clean water, sanitation, then climate change is one, which climate action is one, so there are many areas where plastic becomes essential in achieving these SDGs that we have set ourselves for to achieve during this period, yeah, it's already the time is almost over, I guess, for that. Okay, nevertheless, the point I'm trying to make is that they are essential in all these areas, and I will try to elaborate one or two of those, or two, three of those areas, and then we'll come to the end of this particular presentation. First, food. Okay, we need clean air. First of all, we need air, we need water, we need food. Okay, we need shelter. So as far as clean air is concerned, we need to have less amount of emissions which are pollutant in nature. You call it suspended particles, solid particles, SPMs, floating of 2.5, less than 2.5 micron. They are all microparticles. Emphasizing the point, they are all microparticles. You have pollen in that, naturally coming from flowers. You have soot in that, which is coming out of burning of either natural fire or man-made fire. We have dust in that, which is coming from various sources, construction debris or whatever it is, various sources. So huge amount of these suspended particles are there in the air, and also gases which are there in the air getting emitted because of different reasons, okay, which are harmful. So these pollutants are definitely there. So air is there where we have those pollution coming. We have water. Water is also not always, you have polluted water getting polluted by different pollutants, and then so the air, water, and then land getting polluted by solid waste. When we have addressed the issue of getting clean water, clean air, we also need to have good nutritious food, enough food. Unfortunately, what we hear, one third of the food that is grown is lost. Either it is wasted by me or on my plate itself, or a lot of it gets wasted in the developing countries when it is grown and transported to the consumption location. So we use one third of the food is wasted. That is what the FAO says, Food and Agriculture Organization of UN says. So, and as I said, some of those wastages happen because of its transportation and distribution. So these wastages can be minimized, and if we minimize this waste, or if you can eliminate this waste, then there is no reason for hunger to be there on this planet. But truth is that there is hunger on this planet because of lack of food. Lot of those lack of food is because of out of wastages. Some places the lack of food is because of logistic reasons, war-torn areas and other places. You cannot reach food, so people suffer from hunger. So those are the things. So some of these are man-made kind of tragedies that we have created ourselves. Otherwise, the distribution takes away a lot of product which is wasted. And then, as I said, on the plate itself, we use. So plastic is important at three different areas. One, while growing food, is important to understand. While growing food, I can achieve a kind of efficiency by cutting off, but reducing 50 to 70% of water or nutrient which is required for production of food. It's a huge quantity. So if you are able to reduce that, not everywhere we will be able to do it, but if you are able to do that significantly, there will be less pressure on this planet for water. There will be less pressure on this planet for nutrients, the fertilizer. So we don't need so much of fertilizer. We wouldn't need so much of water to grow food if you are able to adopt modern agricultural practices where a lot of plastic products are used and can be very helpful. Same is the case with distribution. You can see that wastages are reduced by efficient distribution systems. At the retailing point, we reduce wastages by preserving the quality of the product for much a longer period. Shelf life of the fresh food can be increased anywhere between 2.5 to 10 times. In some cases, we have seen examples where the shelf life has been increased fresh food, mind you, I'm talking about fresh food, anywhere between 2.5, so 3 to 10 times it can be increased. And shelf life of processed food, that is very easy to understand. Just after this session, go to the kitchen and see a packet of chips or a packet of snack foods which is there. You will have see the expiry date, which can be anywhere between 3 months to a year. You know, that kind of duration. For that kind of duration, the product can be preserved in its edible form, in its pristine form. So this reduces that wastages which was otherwise would have occurred if we haven't used these plastics for in the food sector. In the food sector, plastic has brought humongous amount of benefit to us, which sometimes we tend to overlook because of other reasons. Again, I'm saying that reason also is valid. I need to get back to that. So it makes significant contribution. It can make, and it is already making significant contribution towards achieving our zero hunger goal, SDG 2. Okay. Same thing happens with the healthcare sector. We have all used different plastic products in our healthcare sector. As a child, children have been administered polio vaccine, which is dispensed with a plastic dispenser. You know, during pandemic, there was while it was a tragic event. In this tragic event, we also learned a lesson that we cannot dispense with the advanced materials which have brought protection to this, and we have been able to, hopefully, I'm confident that we have overcome that pandemic phase thanks to our health workers, thanks to the scientists who have worked hard on getting those vaccines developed, thanks to plastic materials which have been able to support those initiatives of making vaccine, protecting people through masking, gowns, PPEs. Then you have those IV fluid bottles. The other day I walked into for my cataract surgery. I didn't intuitively, but then I said, okay, let me make an attempt to understand what are the plastic products there. So all surrounded by plastic products. You know, you needed them. So this really has driven home the point that plastics are beneficial to human beings, and we need to accept that it has a huge contribution made in different space of human endeavor, but it also has posed certain challenges which we need to understand and address. So COVID-19 pandemic has underscored the criticality of plastic in facing this such crisis. So that relates to our SDG 3 of good health and well-being. So how this gets related, these new generation materials get related to our endeavor to achieve some of these SDGs which are there. Similarly, in the case of building and construction industry, we use a lot of plastic products, PE product, PVC products, water distribution system in the rural and urban area locations use plastic pipes for potable this thing. Wire and cables is a given thing. You have plastic, and that is the reason you have a safe distribution of electricity to the consumer. So that is almost is a given thing. We never notice that, but that is what it is. So you have all these things really contributing to realizing our SDG of 6 and SDG of 11. Just broadly, I thought, let me give you a few examples, and then I'll come to a very critical part of this presentation, which relates to climate action. Climate crisis is a reality. No one can get away with that from this reality. We have to accept the climate crisis is a reality humanity is facing today. We are having unpredictable weather pattern across the globe, whether it is in poor country or it's rich Western countries. Everywhere there is a sense of crisis which is getting developed because of this climate changes. Now, climate change has reached, as I said, in the last COP26 at Glasgow, world leaders debated on this, and they sent a signal that we need to urgently look at solutions. And they also accepted that there is a possibility that we may not be able to reach our target of limiting global warming global temperature by which was agreed in the Paris Agreement, that within 1.5 degrees centigrade. People are already hinting at that possibly it will be 2 degrees centigrade, which is a bit alarming, because in many places a 2-degree increase in temperature could bring catastrophic consequences in the people living there. So I'll not get into all those details, but what I'm trying to emphasize is that this is the greenhouse gases are implicated for this. Main thing is that the greenhouse gas levels have gone up from 280 in pre-industrial areas to about 400 plus currently of carbon dioxide equivalent in our atmosphere. So there had been a huge increase in the greenhouse gas into the atmosphere, and that is implicated. That is perceived to be the reason for your global warming, and that is why we are concerned about this increase of carbon dioxide into the environment. And the main generator of carbon dioxide is a generation of energy, fossil fuel energy. So that drives the global warming. Improving efficiency. So what we need to do is that we need to use less and less energy for the same functionality, for the same purpose. If I use less energy, I would put less demand on energy. So there will be less production of energy from fossil fuel. There won't be any getting away from fossil fuel in near future. That is my assessment. We will have renewable energy in the future. We are pursuing that. Today, it's a small part of the total energy pie, but it is going to grow. But it will not be completely able to remove us away from the fossil fuel. Fossil fuel is going to be there. In some countries, they are trying to bring it down, but overall, on a global basis, is very, very unlikely to happen. And particularly in countries like India, developing countries where we need energy. Our energy needs are inadequately met compared to many of those developed countries. And as a result of which, one of the largest emitter of carbon dioxide happens to be your United States and China, and countries like China. Their emission level is much higher. As a matter of fact, our emission level of carbon dioxide is 1/5 of the global average, if I remember roughly. So, and we need to develop for the benefit of Indian citizens that we need to create more energy, and though more energy, entire thing cannot come from renewables. Even if large part of comes from renewables, I'll be able to convince you that there also you need plastics. Okay, you need plastics there as well. So, and the other thing is happening is that a natural sequestration of carbon dioxide is planned, green cover. We are destroying that very, very rapidly globally. Some places we are trying to reforest it, but it is not in adequate measure. Solar and wind energy needs plastic. I mentioned that just now. Okay, we need plastics to make those plants, parts of those plants, solar energy plant or a wind energy plant. We need plastics over there also. And reforestation and not destroying the natural climate solutions like green cover is critical for CO2 sequestration. So if we need to reduce carbon dioxide emission into the atmosphere, we need to take care of, first of all, improving our energy efficiency in all sphere of our activities. Second, we look at good sequestration solutions for carbon dioxide, which is already there. There are technologies which are available which can capture carbon dioxide, put it into cement and calcinate it to make it calcium carbide, and all those solutions are there, but they are also not a very viable and scalable solution. That is the challenge that we are facing today. So alternatives would either not be viable or not scalable to meet the need of the energy needs of the of human being. This is the path that climate change takes. Okay, population has grown. Okay, when today we are close to 8 billion people on this planet, 7.8, 7.9 billion people. When I was born, it was about 2.5 billion people. So see that the population has grown. I come from a very poor family. We had very little means to live on. So maybe we just had a bucket, steel bucket kind of thing, maybe 1 or 2 cots or something like that, you know. But today, people of this generation, we are using more product and services compared to what was there in past. And it is good because that is how the quality of life improves. What I was used to and what I'm getting today is very different in terms of products and services. And this quality of service life, if we have to achieve, we need materials, we need services, we need products. All these demands makes demand on the nature finally to get those products, get those services, or fossil fuel, whatever. They all come from the planet. They all come from the planet. So more material we use more energy today. That leads to higher greenhouse gas emission. That leads to your global warming. And finally, we have arrived at the climate change challenge that we are facing today. Now, this is a very favorite example or case study that I always love to share this, because this drives home a very important and very, very powerful message to the outside world about plastics. Very powerful message. I grew up drinking milk from a glass bottle. As a kid, I grew up drinking milk in a glass bottle, which used to weigh 650 grams. 650 grams of glass was used for packing 1 liter of milk. Today, our dairies are using 5 grams, just 5 grams of plastic film to pack the same 1 liter of milk. And this substantial reduction in weight has huge implication. Number one, to deliver the same quantity of milk, the truck is making 40% less trips. Because in a truck, earlier it used to be 6 tons of milk, 4 tons of glass. Today it is 9.5 tons of milk and 0.5 tons of plastic film. So 40% less trips are required to be made by the truck to deliver same quantity of milk in a pouch, milk pouch. Translate that into amount of fuel which is used, translate that into amount of emission that is saved. So there is a huge implication of this. And this has been achieved because of 2 factors, mind you. We also have milk packed in PET bottle, which is good. A lot of people want milk in PET bottle because they find that polyethylene film is little flimsy at times, and also it has a greater challenge in terms of collection and recycling and segregation and recycling, whereas a PET bottle is a lot easier. So, and in the environmental context, PET bottle is slightly better than polyethylene film, but that is only because of its recyclability. But in terms of its energy content, in terms of its processing and everything, polyethylene is processed at anywhere between 2 to 10 degrees centigrade. This glass bottle will get processed at 1400 degrees centigrade. So number one, I'm using more energy to produce this packaging material. Number 2, I'm using more energy to deliver this milk to the consumer who needs this milk. And number 3, earlier I used to use huge amount of water and detergent to clean these bottles, besides incurring that return freights, which is there in case of bottles, large environmental footprint in having that return freight achieved. Today it is all eliminated. So these are the benefits that plastic brings, but they remain dormant. People do not look at this in that details and try to understand that why plastic being used the way it is used today. It has got environmental benefits and not environmentally damaging. It's not environmentally damaging. Environmental damage happens not because of this material or the product. It happens because of something else, which you'll also try to address. And as I said, the processing temperature is relatively much higher for all those alternative materials as compared to plastics. One study which was done in US and Europe, and they found that if we move all plastic packaging from to an alternative traditional material which was being used earlier, our material consumption will go up by anywhere between 3 to 6 times, 3.6 to 4.5 times. Our energy consumption would double everywhere, and then also our greenhouse gas emission would also more than double. So conversely, by coming to plastics, we have been able to make these huge savings in materials, huge savings in energy, and huge savings in greenhouse gas emission. And mind you, greenhouse gas emission is the primary cause of this global warming today. So if we are moving to a solution which reduces the greenhouse gas emission, I think that is the right direction to move, and not go back where we increase our greenhouse gas emissions, we increase our energy consumption, and we increase our material footprint on this planet. So with significantly lower density, that is one I just mentioned, and design flexibility, against a solid glass bottle, I have a flexible pouch that has enabled me to bring down the weight from 650 grams to 5 grams. So this kind of transition to a lower material footprint has been made possible with plastics. And then greenhouse gas emission, we talked about conversion and recycling of plastic. Also recycling. If I recycle a glass bottle, I'll be recycling at 1400 degrees centigrade. If I recycle a polyethylene film, I'll be recycling at 220 degrees centigrade. So these are all savings, energy savings that can be achieved through this. And it mitigates pressure on forest resources, thereby preserving the natural CO sink. I don't put pressure on wood, so I'm saving forest. And in the process, I'm able to improve the natural sequestration of carbon dioxide, which is responsible for this climate crisis that we are facing today. So, in effect, it meets very effectively, it meets our SDG goal of 13, climate action goal. This gets missed out very often because of the narrative which we otherwise have, not based on science, but based on perception that the plastic is harmful to the environment. It is not. It is benign to environment, it is helpful to the environment. But these are the challenges that we have. Plus, solid waste pollution. It's not plastic, it's total solid waste pollution. 7.8 billion people are generating solid waste every day. Everyone, all of us, we are generating solid waste every day in different proportion. It is higher in the higher income group countries and higher income households. It is low in lower income countries and lower income households. But all of us, we are generating solid waste, and that solid waste needs to be managed scientifically. It has to be managed scientifically. All solid waste are not biodegradable. A lot of solid waste like glass, it's not biodegradable. Stone is not biodegradable. Some of them are biodegradable in certain conditions, like paper. If it is in a landfill, they found a paper which is newspaper, which was 50 years old, because there was no microorganism there. There was no moisture there, and there was possibly the temperature was very high. So there was no microorganism to biodegrade that newspaper, and the gentleman who dug it up could read the news which is 50 years old. So these are the examples which are there. So we need a certain condition in which products biodegrade on its own. Fortunately, most of our wet waste gets biodegraded on its own, but in the process they also generate methane, which is 80 times more potent than carbon dioxide. So it's not hunky-dory everywhere. By moving from one material to another, it's not going to solve the problem completely. It's not. So that realization, I think we need to have. Plastic waste contributes about 8 to 10% of all solid waste, but eventually it goes to the landfill, and from there it leaks into the environment. That is a challenge we need to face. Plastic pollution, like other solid waste pollution, is a reality and needs urgent action. And those actions are in the area of, partly it is in the area of science domain, but also a large part of it is in the social science domain of creating infrastructure and behavioral changes to handle this new generation of plastics, new generation of materials to which we have just got introduced in past 50 to 70 years. So this is the thought I thought, let me just share with you and move towards a circular economy is the way forward for this. Fortunately, all plastics can be recycled or its energy or material content recovered, including thermosets. Thermosets cannot be mechanically recycled because mechanical recycling is the first preference. That is the easiest way of recycling it. But if it cannot be mechanically recycled, there are also other options of recycling, like pyrolysis or those kind of things. Also, a lot of in thermoset we use a lot of fillers. So this could also substitute some of those fillers. Ground thermosets waste. So there are options available in addressing these waste, But addressing this waste in an economically viable way does not happen, not because technology is lacking. Technology is there. You guys are doing wonderful job in developing science, developing technology. But then some of us are not very conversant with it. So we don't know how to use this product. And that change is an essential, is a necessity to address the issue of climate change that we are facing today. As you can see, we use plastic waste in cement kiln, we make roads, we are in the process of trying it out in blast furnaces. Many countries use it in blast furnaces. So we can recover this energy. These are all condensed, high calorific value material, okay? Your coal is 27 kilocalories per kg, if I remember. And this one would be about 30, 35 kind of thing. You know, so it's much higher in terms of its calorific, in terms of its energy content. We can recover that energy in different ways. And we are doing it, as I said, in the cement kiln, we are doing it. It can be converted into the basic building blocks or the basic feedstock, you know, the oil from which again it can be cracked and get into the monomers and get into the polymers. So all those options are, scientists have done their job pretty well, but unfortunately they have not communicated that to the external world in that effective manner, the way they have been able to develop those scientific solutions to these problems. So as scientists, I think some of us, we have failed our society. It's a very strong word, I'm using it. These are the wonderful products that we make from recycled plastics. Okay, this is a PET water bottle, which goes into making of sport jersey. IPL team has, Indian cricket team has, and many other global sports team have recycled plastics, recycled PET for their jersey, because it's chemistry-wise, it's same. It is polyethylene terephthalate. Whether I use it for bottle, or I use it for film, or I use it for fiber to make those wonderful jersey, depends on me as a chemist. I just change that IV value of that and make one of the products which is most suitable for that particular application. And you get a wonderful product, a beautiful product you get out of this recycled PET. Same thing happens with your milk pouches. Create membrane, membrane for waterproofing membrane, and various other products. I think I'm taking too much of time, so let me move fast and try to keep few minutes, if possible, at the end for any discussion, question and answer session. Okay. As I said, the problem is here. Problem is with me as a consumer. We have petrochemical plants producing those raw materials, sugar crystals. They go to the plastic converters who make film, who make bags, who make bottles, who make different products. Some of them directly come to me as my bucket, or as my mug, or as my other plastic products that housewares that I use at home. Some of them go to the brand owners who pack their product, and that comes to the consumer. And at this stage, even though this product has good value, the waste has good value after its use, it gets into the environment. It does not follow this circular path where it is collected by somebody. Unfortunately, this is one area where the industry is extremely concerned. We are depending on large number of very poor people at the bottom of the pyramid. They're earning their living all right, but many of them are earning their living not in a very decent way, not the way we lead our life, So they get into an aggregator sends it to recycler, and this circular loop is getting completed by this. To the extent it is prevalent today, but a lot of it is leaking into the environment as well, and we need to address this. And here, addressing this leakage into the environment is not a technical solution. It's a behavioral solution. It is a societal solution that we need to have, and that is the point I'm trying to make. Disposal method has decisive impact on recycling cost. Otherwise, all plastic can be recycled. Having said that, let me come to one or two slides on the epilogue of it. Alternatives to plastic, as I said, will create more environmental burden instead of reducing it. Talk about paper, talk about cloth. They all have environmental footprint, which is very often higher than the similar products made from alternative material of plastics. Glass bottle, I have explained in details. Metals, also the same thing. Excuse me. Sir, I'll call back. I'm in a meeting. So And this is what has been one of the studies of United Nations Environment Program. Single-use plastic bag has lowest environmental footprint compared to paper, cotton, or biodegradable plastics. It is a single use which is a problem. If I use that any product multiple times, and that is the path towards sustainability, and I'm coming to that. Sustainability means what? I have to reduce my use of material. I have to reduce my use of other resources, energy resources. And that is the first step towards sustainability that one can think of. I have to reduce my material footprint. I have to reduce my energy footprint. And paradoxically, when I use plastic, my material footprint is much lower compared to 650 grams of glass and 5 grams of plastics. Reducing is the first step. Reducing a product use itself. If I don't need the next t-shirt, I should not buy that next t-shirt. Why should I buy? Because if I buy that, means somebody has to produce that fiber, somebody has to produce that. In the process, there is an environmental footprint which gets created, both in terms of energy, in terms of water, and in terms of materials, energy, and air, also yes, air pollution. Aluminum does not come cheap. Let me put it this way. Aluminum is a very good product in terms of barrier properties. To make 1 ton of aluminum, we need 7 tons of bauxite. And that 7 tons of bauxite translates into huge quantity of red mud, which is a radioactive waste which gets generated. And we have already accumulated nearly 3 billion tons of red mud across the world. Iron does not come without its environmental footprint during mining. And bauxite is mostly mined in places where there is a jungle. So you have to cut down trees and remove that facility of CO2 sequestration, which happens. So all these things I'm trying to emphasize has environmental footprint. But the environmental footprint, when you do an LCA study, life cycle analysis study, in most of the cases, we'll find the plastic products have the least environmental footprint compared to alternatives. After reducing, can I reuse it? We must and we should reuse it as much as possible. We should not throw that bottle of water, PET bottle after drinking water or drinking my Coke. I can always put some water back again and put it for drinking at later. And that is what most of the poor people do. They keep that bottle, use that bottle multiple times, reuse 10, 20, 15, whatever, for a few months. And then at the end, we also have the possibility of recycling it. And recycling becomes efficient, provided I make those behavioral changes in terms of keeping my waste segregated. So with this, let me come to an end. Thank you for your attention. I'm sorry I took much longer than.
Yeah, sir, we have another presentation, sir. Yeah.
Yes. So I sign off with this, and thank you, Madam, once again for inviting me.
It's our pleasure, sir.
My apologies for overshooting the time.
No. Yeah.
If there are any questions, feel free to send me a mail because I don't want to stand between you and the next presentation. Let that start. Do send me a mail if there are any observation, any comments, and any questions that you have. I'll be too happy to answer. Okay, thank you very much.
Sir, wait. We will formally thank you.
I was being mindful of the time,
No, yeah. We have 2 more parallel sessions of these research presentations after this. Hello?
Hello.
Yeah.
Okay. Good morning, one and all. It has been such an honor to be part of this wonderful event. On behalf of the organization KSOMI College, I would like to extend my heartfelt gratitude to our esteemed guest, Mr. Sopan Rai, for this wonderful, informative lecture on plastics and sustainability. It will be definitely helpful in our future work. Sincerely thanks to all of the teachers and students who attend this program. I would like to thank once again to the student speaker, Mr. Sopan Rai, to share their knowledge with us about plastic and sustainability. Thank you, sir. Thank you, all of you. Now, we all will be assembled for the next session where the participant would be doing their presentation. So I request all the participants keep their presentation ready. You will present as per the sequence given in the schedule. No, it's time for short tea break. We request all of you kindly assemble before 12. Yeah.
So we are taking a very short break, right?
Yes.
Yes, yes.
Yes, ma'am.
Yeah. So we'll just take a, I think, 5 minutes break up and
That
then
is at 11:30, yeah? 11, sorry.
the arrangements are made. So welcome all the participants for your presentation, and I think our chairpersons are also here. Savan, sir.
Just give us 2 minutes. Take a 2 minute break. We have to set up the thing. So
Yeah.
we back to do it.
I'm seeing whether the chairpersons are here.
Okay, ma'am. Okay.
Dr. 87, sir, you have to make him co-host, no? Yes, Savan sir is here. You have to make him co-host and also unmute him. He is not able to speak. Savan sir, 87 sir, here.
Yes, ma'am. I made him.
Yeah, and unmute him so that sir can speak, please.
Okay. Okay, ma'am.
And then I think Prasanna sir. Sir, thank you so much, sir. Prasanna sir. Prasanna sir.
Yes, now.
Prasanna sir will be in the another link, I think, na Chitra?
I can't see. He joined. I sent him the link. I should join the other link.
Ma'am, I'll make you this.
Now I'm able to speak.
Yeah, yes, sir. Welcome, sir.
Thank you.
Yeah. So we are actually doing these parallel sessions. So you will be in this link, and Dr. Prasanna Galsasi from Baroda University, he will be the another chairperson for the. So we'll have a separate link for him.
Okay. I have in my session there are 8 papers, right?
Yes, sir. Yes, sir.
But if I go by order of the abstract, it is slightly this. So the first abstract I put last. Okay. So start with the. If this
So
order is.
Vida?
If this order is circulated, I will go by this order.
Yeah. Good evening. Good morning, all of you.
Yes.
And
Only one abstract is that is first abstract is actually the last paper. It should be then. If we go by this order, right?
Prasanna sir, actually there are 2 links for the session. One is for session 5 and one is for session 6. And you will be chairing the session 6. And over there, there will be a separate Zoom link which Chitra ma'am has sent to you.
Prasanna sir.
And Savan sir will be chairing the session 5. So, sir, the first, the presenter is going to be the last presenter now, as per your suggestion. Is it like that? Hello, sir. Savan sir?
No, you want to go by this order, right?
Yeah, so we have a sequence over here, and the sequence is, first one is Mr. Satyajit, then is Ms. Mamta, Ms. Pritam Kumar, Mr. Shelar, Dr. Shelar, Dr. Roshan, Dr. Rathi, Dr. Vikas, and Monica, Dr. Monica. So this is
Let me write down the order.
So it is there.
Yeah.
It's on the screen over there.
I'm seeing from the screen only.
Okay.
Roshan.
Chala.
When do you want to start?
So we start immediately. I just want to confirm that all the participants are having their presentations ready. And if you have any difficulty, please let us know on the chat. Are all the participants present over there? Can you please convey on the chat with your names? Dr. A.S. Vishwanathan, Ms. Mamta Tendulkar, Pritam Kumar Shinde, Roshan Rane, Ratikanta Bera, Vikas Yadav, Monica Khurana. You will remain on this Zoom link for your presentations. And you will have a timing of 10 minutes for the presentation and 2 minutes for the question answers session out of 2 minutes for that. Sugandha ma'am, can we start? Should we start now, Sugandha ma'am?
Sugandha is now, yeah, I think you can start.
Can we start? So,
We are ready.
If you all are ready, then you can
the
start.
participants are there. Yeah.
Just check. All of their names.
Satyajit, are you there? Yeah, he is.
Yes, ma'am, I'm there.
And then Mamta, Ms. Mamta Tendulkar, are you there?
Yes.
Pritam Kumar Shinde, is he there?
Yes, ma'am, I'm there, present here.
Roshan Rane is there?
Yes, ma'am.
Roshan Rane, are you there? Ready with your presentation? Can you please communicate?
Yes, he's there.
Okay.
He's
Then
ready.
Ratikanta Bera, are you there? Ratikanta Bera, your presentation is not with us. You want to present yourself, you said. Are you ready with your presentation? Vikas Yadav, are
He
you
was
there?
there.
Yes, ma'am, I'm there.
And Monica Khurana, we have not received your presentation yet. Are you there?
Yeah, ma'am, Vikas Yadav, I'm there.
Monica Khurana.
Monica Khurana, are you there? Your presentation is not with us. Are you there? Monica Khurana? Okay, so we can start with the participants who are present over here. And to start with, I would like to welcome our esteemed chairperson for the session, Dr. Professor A.D. Sawant. We welcome you, sir, for this session. And this is on behalf of our chemistry department on this national conference. I would now like Ms. Shraddha Yadav to introduce you with her biodata.
Good morning, everyone. Good morning, everyone. Myself, Shraddha Yadav. I'm here to introduce Dr. A.D. Sawant, sir, Professor of Chemistry, Institute of Science, Mumbai. He was a Pro Vice Chancellor, University of Mumbai, and Vice Chancellor, University of Rajasthan. In the field of the research, his contribution was in inorganic solid state, nuclear, and environmental chemistry. He was a His research outreach was applications of new method of separation using nuclear technique for the trace analysis of heavy metals in environmental pollution studies. He monitored all freshwater and coastal water in and around Mumbai city, and also he did first-hand documentation of heavy metals pollution. He did extensive study on lead, cadmium, chromium, and mercury pollution with case study. He guided over 26 students in the PhD degree, and also he has 170 publications in the reputed journals. He also participated in the National Collaborative Program of IAEA. Respected sir, also have the contributed writing research review to Encyclopedia of Analytical Science of Cambridge University. Sir was scientist in charge for the analytical chemistry session for the Convention of the Chemists of Indian Chemical Society for 2 years. Now, I will request respected Chairman Dr. A.D. Sawant, sir, for the opening remark. Thank you, sir.
Thank you. Oh. What is the matter? Kindly link me properly. Can you hear me?
Yes, sir. Yes, sir. We can hear you.
Please, something happened. Can you hear me now? Okay.
Yeah, it's clear now. It's very clear.
Okay, let the screen be there.
So we're waiting for your opening remarks. Yeah.
So suddenly that screen went blank and back to the join करके, like, you know.
Is it okay now? Okay
now
now?
It's okay. I can see no problem. I can see the presentation screen, index of the papers. Doesn't matter. I'll just speak like that. I can't see myself except in this small corner on the top. Okay, no problem. So friends, at the outset, I thank Principal Madam Pradnya Prabhu and Head of the Department, Sugandha. Incidentally, both of them students of the institute, rather my students, and I had a privilege of teaching them. I don't know whether they had a privilege of listening to me in the lecture, but today I'm so happy they had been doing such extremely good work and occupying very important positions and in persuasion of science and teaching and research, you know. This KJ Somaya College of Science and Commerce is a very distinguished institution in the university arena of Mumbai and much dependable for a good quality of education. And rightly, how they have been groomed and advancing to doing science and research teaching, that they organized this international conference on very important subject, and that is conference on chemistry, rather involving chemistry in sustainable development and intercepting academia and industry. And we have been listening to good lectures since yesterday. I could get time to attend a few lectures, very important, of which the most important speaker, one of those, rather the outstanding speaker, was Professor G.D. Yadav. And how mesmerizing lecture that you had from him. And what we have been talking last 2 days is, in fact, culmination of all those problems could be seen from his lecture, you know. A Sustainable Development Goal, the Mission 2030, and we're worried how much we can achieve, and the problems that all the speakers have been talked about, particularly Swapnil Ray said many problems that how are responsible we are in creating problems. So young generation of students, you are doing research, taking degrees, but I would request that don't enter into job without a mission, that you have to do the job for yourself, your family, but you have to do the job for a nation. And please carry that in your mind, that you want to do the job for a nation as well, you know. Because sustainable development, because everybody is keen on development, you know. And in the development, what we have been doing, you know, that exploitation of resources and generating so much difficult things, difficult to handle, difficult to manage, difficult to store, difficult to convert. Some approach of converting them is in a progress, you know. So that while producing something for development across the world, we have spoiled the environment, and so UNDP Sustainable Development Goal is the right approach. Now, just take an overview. You must understand what Professor Yadav said, you know. What he said about the green hydrogen, green nitrogen, green ammonia, carbon, and even carbon monoxide, you know. We have been polluting air and water. So everything is being air and water as a pollutants, you know. But what he said, that you catch that, what you have been watered now, you have to resource it back from that. So from air, you have to draw the hydrogen, from water, you have to draw hydrogen, you have to draw the oxygen, you have to draw the nitrogen, ammonia, nitrogen from atmosphere, you know. carbon monoxide and carbon dioxide. You are emitting out. Now don't look at them as a waste. In fact, they shall be what you are watered into, will become your source of energy. And once you are able to do that, I think there will be sustainable development and sustainable world, So this is very important issue, and he focused on energy. So I'm talking to you in a brief introduction about a minute or two that how important these issues are. We are not able to do compatible developments, I would say that. Rather, we create more nuisance in doing that. And the state of affair, and when talking about the global warming. If I take the meaning of these presentations and the speakers and the talks that you have gone through, it's nothing but remediation, something better that we can have, something better which can produce less waste. What the last lecture was that how you can have plastic management. So everything like that, and many of your presentations are, you have been just put to by your senior mentors that you do everything, do research for the waste management, good applications, Some presentations and the sewage water. The sewage water, say City of Mumbai, has completely spoiled the water bodies in and around and even the groundwater of the City of Mumbai. In India alone, in urbanized areas, we are producing 64,000 MLD of sewage water. Only urban and not industries, only sewage, which is 13 to 14 times of a daily water supply of your big city of Mumbai. So much that if you go by an average of 4.5 or 5,000 MLD of the wastewater generated, water supply to city of Mumbai, 15 times of that across the country is thrown as a sewage water, and you can think how much technology and efforts you require to put into for this. So these are the issues, and speakers have given good ideas and your own research. I'm sure in the future you shall be able to contribute to for sustainable development. So all the lectures you heard from Dr. Reddy, Kanchan Railu, and Dr. Bhange, he was talking about the material which are in nature, plant material, the molecules in nature or biomass can be converted into. There's no time I could have extended on this issue, how important is the linolenic acid playing role into the chemistry and also in health sciences. Nitin Lakshetwar, Ganesh Naik, and Dibankar Goswami, and last month Swapan. Everybody focused on the issues of sustainable development. So you have in mind what problems they talked about it. And so without wasting or taking much of your time, let's go for a presentation. So we have 8 presentations, what I have been lined up to. And as I've been told by organizer that we'll have 10 minutes time for a presentation and maybe involving question or two. So please see that you manage your presentation in time. So with this brief introduction, how important is environmental management for development, which makes together sustainable development, So is Satyajit, Mahapatra ready?
Yes, I am ready.
So you can, the presentation starts now and 10 minutes for you. So please go ahead.
Sure, sir. I hope my slides are visible and
very well visible.
Respected elders, dear friends, the topic for my presentation is plant-based coagulants for the sustainable treatment of domestic wastewater. This is the broad outline of my presentation. United Nations have laid down 17 sustainable development goals. For today's presentation, I am focusing on the 6th one, that is providing clean water and sanitation. Now let us look at some of the statistics. Around 3.6 billion people in the world lack safely manage sanitation services. Also, 2.3 billion people in the world live in water-stressed countries. That is why people started looking for alternate resources, and amongst them, treated wastewater has gained a lot of importance because it is easily available. For today's presentation, I'll be focusing on domestic sewage. Out of the total wastewater generated in India, only 50% is getting treated. Amongst this treated wastewater, only 1/3 is able to meet the permissible limits. My study based on the sewage treatment plant is present in Prasanthi Nilayam, which is near to my university campus. In the sewage treatment plant, sequential batch reactor is used for the treatment of wastewater. But there are certain issues associated with the sewage treatment plant. They are foul odor, loud noise from the blower, and lower treatment efficiency. That is why we started looking for some alternate cost-effective method, where we came across all these different type of treatment methods, starting from stabilization plant to the modern membrane-based method. Now, to strike a balance, we opted for coagulation flocculation mainly for two reasons. That is, it needs low maintenance, and also it saves time and costs. Now, generally, chemical coagulants are used for the treatment of wastewater, but the issue with the chemical coagulant is that it is left behind as residue in the treated water. Now, when the treated water is reused, it can cause health disorder. So the sustainable solution to this is the use of natural coagulant, because there is no such reported adverse health effect when the natural coagulants are used, but the doses of the natural coagulants need to be optimized. My objective for today's presentation is optimize the operating conditions for the treatment of domestic wastewater using a commercially available plant-based coagulant. Coming to materials and methods, I'm using Ecoglin 2300, which contains the extracts of cleaning nut, drumstick, tulsi, and neem. Now, generally, the coagulation flocculation process has 3 steps. That is the addition of the coagulant. Second is mechanical stirring, where we allow the flock to be formed. And finally, the sedimentation, where the flocks are allowed to settle down. For our study of coagulation flocculation, we are using jar test apparatus. And this is the picture of jar test apparatus. Now, I am studying this different variable which affects the coagulation flocculation process. That is the dose of reagent, pH, stirring speed, duration of stirring, and sedimentation time. I'll be presenting the results that for the work that I have done so far. Now, the treatment efficiency here is presented or reported in terms of percentage removal of total suspended solids, and it is calculated using this following equation. Now, here we have studied 5 different doses with a range of pH varying from 3 to 10. You can see here at a lower pH and with higher dose of coagulant, we are getting higher efficiency. Now, let us understand the mechanism a bit. Normally, organic matter in the domestic wastewater are negatively charged. That is why they have a repulsive force amongst themselves, which doesn't allow them to come together. The role of the coagulant is to neutralize the negatively charged suspended particles. For that, the coagulant has to be positively charged. Now, the charge of the coagulant depends on its pI value or the isoelectric point. If the pH of the wastewater is lower than the pI value of the coagulant, then the coagulant will be positively charged. When the pH of the wastewater is higher than the pI value of the coagulant, then the coagulant will be negatively charged. And that is why optimization of the pH range is a must. Now, also the dose of the coagulant also depend on the pH of the wastewater, which decides the charge of the coagulant. Addition of a lower dose will reduce the treatment efficiency because the coagulant cannot completely neutralize the negatively charged suspended particles. Also, with higher dose of coagulant, the amount of positively charged particles will be more. This will again cause the repulsion amongst themselves, which will reduce the treatment efficiency. So that is why pH of the wastewater and dose of the coagulant always goes hand in hand. Next comes the stirring speed. Now, the neutralized suspended particles come together because of the stirring speed. Here there are 2 cases. In one case, I'm using the same stirring speed, In other case, I'm using different combinations of stirring speed. In coagulation flocculation, two types of stirrings are used. One is the fast stirring is followed by the slow stirring. Here, I have kept the slow stirring constant and varied the fast stirring. As you can see, when I'm increasing the rate of fast stirring, the coagulation efficiency is increasing. Fast stirring helps in interaction of the coagulant with the suspended particles. Now, when I'm increasing the rate of fast stirring, the interaction between coagulant and the suspended particle is also increasing. That is why the treatment efficiency also increased. Next comes the slow stirring. In this experiment, I have kept the fast stirring constant and varied the slow stirring. Generally, the slow stirring helps in formation of flock. A very low slow stirring did not allow the neutralized suspended particles to come together, so the flock formation did not occur efficiently. Also, a very high slow stirring was breaking down the flocks. That is why the treatment efficiency reduced. And this is the reason we opted for the optimum speed. In this case, it is 100 RPM. Now, coming to the conclusions of the study, optimal dose of the reagent depends on the pH of the sewage. Both fast and slow stirring are necessary for coagulation flocculation process. Duration of the stirring and sedimentation also have to be incorporated in the study. I am using response surface methodology to study all the variables together using optimum numbers of experiment. Now, best combinations of all these variables needed to be worked out based on three aspects, that is strength of the wastewater, application of treated water, and cost effectiveness of the process. Now, at the end, I'm grateful to Bhagwan Sri Satya Sai Baba, founder chancellor of Sri Satya Sai Institute of Higher Learning, for providing me free education and giving me an opportunity to work on this socially relevant topic. Also, I am grateful to my supervisor, Dr. A.S. Vishwanathan, for his constant support and guidance. I'm thankful to EcoHealth Product Private Limited for providing me all the reagents. Also, I'm thankful to the organizer for giving me this opportunity to present in this conference. Thank you for your patience listening. I'm now open to any questions from the audience or any advice from the experts. Thank you.
Thank you for finishing in right time. Congratulations for that. And you have still left a minute or two for discussion. Any question, please? Any questions? No questions? Then I'll just ask a small thing. How did you determine the concentration, the quantity to be added for?
For the treatment, sir, yes.
Treatment, yeah.
I went from zero.
I'm so happy to see that such a small quantity can do that. So what are the great properties of this material?
So this material has that, means if you see the plant extract that are used in this material, they all have coagulation activity. Now, coming to the quantity, how I decided, till now the experiment is still in progress. We have not come to one particular quantity that we have to add, because the dose is finally we have to decide keeping all the variables together. This is the preliminary experiment that I have done, where I am seeing till what dose I am getting the better efficiency.
Yeah, it's very unique. I would say normally people use combination of these solid materials of these things, you know,
Yes.
cellulose. We have been using extract, you know, so in the form of liquid and a small dosing will really work out well. So it can be used for normal water treatment of things. And if
Yes,
it
sir.
does good sedimentation, it can replace chlorination. Because
Yes, sir. Yes.
adding chlorine for a sedimentation in city water supply leads to the formation of additional problems like trihalomethanes, and they are
Yes.
carcinogenic. So
Yes.
all the treated water municipal corporations were saying is chlorinated, which is bad for health. And also now it has been found that it leads to formation of trihalomethanes, you know. So if such kind of natural product material extract we can use, it will be really the boon to. So I suggest that you should escalate, enhance, and take help of advanced institution and see if you can do it better. Sometimes you can visit ICT, or you can visit ICT in Mumbai, or you can visit IIC Bangalore, and they can guide up and scale up this thing further. Very good. Congratulations.
Sure, sir. Thank you so much, sir.
So
we shall I end my presentation?
Yeah, sure. Thank you very much. We are giving round of applause. Yeah, virtual round of applause. So next is coming to us a young dynamic student group, and of which Mamta is presenting her paper, and that is material analysis. Mamta, are you there?
Yes, sir. I'm there, sir. Am I
Please
audible,
go
sir?
ahead, Mamta. But time, yes, time is 10 minutes. Okay.
Shall I share my screen, sir?
Oh, sure. Screen is yours. Virtual platform is yours. Conference is yours. Go ahead.
Thank you. Is it visible?
Yes, very much.
Okay. Good afternoon, one and all, the dignitaries and the KJ Somaiya College of Science and Commerce. Myself, Mamata Tendulkar, Assistant Professor from KJ Somaiya College of Arts and Commerce, and doing my PhD work under Dr. Sushma Ambadekar, Associate Professor, the Institute of Science, Mumbai. Today's my topic is material analysis of commonly available sanitary napkins with a special reference to the sustainable development. This is my roadmap of the presentation: objective, introduction, methodology, result and analysis, interpretation, and conclusion. Objective of my study is to identify the material used in the sanitary napkins available in the market and to understand the impact of the product on the environmental sustainability. Introduction. Menstruation plays a vital role in health and reproduction system of female life cycle, and menstrual hygiene management have been created of worrisome impact in the sustainable development goals of the almost all developing countries. If 50% population is female, so every month they are undergoing this menstrual cycle, and every month if you consider the 4 days and 8 pads, so that much amount of waste we are generating, and that has to be considered as a major part of solid waste, and it has to be managed properly. Now, achieving affordable sanitation and sustainability goal without considering this menstrual waste management, it wouldn't be possible. So I've chosen this particular topic for my studies. The methodology I followed, I have surveyed from the various women that which brands they are using, how they are using that, choosing the particular brand, and dependent upon the popular brand. I mean, there are so many popular brands available in the market. So that brands, then again the cheaper and the expensive brands, again the organic, biodegradable, all that brands have been considered for the testing. And out of that, 28 different napkins I have chosen. The brand were tested as per the Indian standards, and it has been tested in the Textile Committee Worli. Now, the following tests were conducted for the particular napkins: that the longitudinal section of the fiber, burning test of the fiber, and solubility test in the solvent like xylene, H2SO4, and 60% H2SO4 and 75% H2SO4. Now, in xylene, most of the synthetic fiber, boiled xylene, the most of the synthetic fiber get dissolved. The remaining fiber, if it is rayon or if it is not the synthetic fiber, but it is rayon, cellulitic, viscous rayon, that all get dissolved in 60% of H2SO4, and all the natural fibers or cellulose that get dissolved in the 75% of H2SO4. So this particular test that...
Hello, Mamta ma'am. Hello.
Yes.
Mamta ma'am, can you make it full screen, please?
Ma'am, it is full screen itself.
Slides not moving. Slides are not moving. Yeah.
Oh.
And yeah, and it's not full screen.
1 minute. I have made it full screen itself. Okay. Is it visible, ma'am?
Visible, but the screen is not full. You can put it on the slide screen. Yeah, there. Yes.
Yes. Is it full screen now?
Not yet.
Oh my God. But I could see the full screen itself.
The slideshow is not. Can you reshare it?
Yes, yes, I'll do that. Is it visible, ma'am?
It is visible. It's not in the slideshow.
Oh my God. Ma'am, because from my side, I'm doing the slideshow.
Yeah, where you have the this thing, file, home, insert, design, transitions, and after annotation.
Yes, yes, ma'am. I'm going for slideshow
Yeah.
itself, ma'am.
Yeah, if you can click there.
Still, it is not slideshow.
No, not yet.
It is not readable also.
It is readable.
So, somewhat better, somewhat better.
Now, is it?
Okay, yeah, now it is. Yeah, you can continue.
Go ahead, yeah, go ahead. Go
Okay.
ahead. We'll manage, yes.
Yes. Sorry for inconvenience. The following tests were performed, solubility test solvent in the solvent like xylene H2SO4. Then also observation of the available of the core absorbent material, whether the gel sheet is present or not, because in textile committee in their protocol, they are not analyzing the gel sheet, they are just analyzing the material fiber, basically the fiber available in the okay. So this was my methodology. Then this is the results and analysis. These are the results which I've obtained from the 28 samples. 5 to 6 results which were little more confusing for me also and for the performer also, because we got the this is cellulose present in the core absorbent, which is supposed to be the natural ingredient, but it was not dissolved in H2SO4, not even in the 90% of H2SO4. It was not dissolved. So this yellow mark which I have made, it is specially for the certain substances which were not dissolved in the H2SO4, even after the little higher amount of percentage if you have tried, but they were giving under the microscope, they are giving the cellulose structure, they were giving the burning test as a natural fiber, but their solubility was not there in any of the solvent. So this has to be further, research, and they have to we have to find out the method to find out the actual fiber or the which type of fiber it is. Then out of total sample, we have tested for the top sheet and the core absorbent, because as per the BIS standard, the bottom sheet should be polypropylene itself, because to avoid the leakage. So and it is not a fiber, so it was a non-woven proper sheet, so we couldn't analyze under the longitudinal section and all. So only top sheet and core absorbent has been analyzed. That if we find that is the out of this 28 table, 12 were the polypropylene, 2 were the non-woven synthetic, then there are 4 were the natural cotton, 9 were the cellulose, that is made that is cellulose, that is also a natural thing, which is made from the banana leaf or maybe from the bamboo leaf. So that also napkins have been taken. So that is the cellulose which has been used, but that was not cotton. And one we find out which is the mixed fiber, which has to be also identified further, which fiber was that, but it was partially dissolved in xylene, and then it has got dissolved in the H2SO4. So the composition we have not at all able to find out, but it was the mixed fiber they have used. Same about the core absorbent. There were no mixed fiber we found out, but there was a polypropylene in hardly 2 to 3 samples. Then cellulose was there in the 19 samples, and then non-woven synthetic was there in the 6 samples, and then natural cotton were there in the 6 sample, non-woven there were in the only 1 sample. So synthetic overall 3, and the rest of there were the this is how I have plotted. So cellulose was the highest in the core part, that is the organic one. Then this is polypropylene was the lesser. Then the natural cotton was also used the very less amount. Highly they have used as an absorbent, that is the cellulose, and that is also biodegradable part. Mixed fiber is also used only in the one particular napkin. Now interpretation, the material of the top sheet and core absorbent material and bottom sheet were tested for each of the napkin. Out of 28 napkins, 12 napkins top sheet were made up of natural fibers. 25 napkins absorbent material were made up of natural fibers. That is made up of cotton and cellulose itself. And all 28 napkins bottom was made up of synthetic material, that is 100% polypropylene. Now out of 28 napkins, 16 napkins contain the gel sheet as the absorbent material. Now why it is a little more problematic, the figure I will tell. Menstrual waste which we have generated, just I mentioned before, that in Indian scenario, if we'll see, there are 336 million menstruating women, and 36% of the women are using the this menstrual pads. Now sanitary pads they are using. Now 121 million users of sanitary females overall. And if we consider per cycle 8 pads they are using, then it becomes a 1 million pads per month and 12 billion per pads per year. It's a huge amount of waste. And the waste has been biggest problem because it is not being segregated properly and it is disposed along with the dry waste. Segregation was of this particular waste was not occurring at many of the wards in Mumbai. I have seen only in A ward there was this menstrual waste has been segregated if it is given a red dot, and that it considered as a biomedical waste which they are sending for the incineration. But other wards in Mumbai are hardly, I mean, not even they are going for, because they are saying we are not getting this kind of separate waste as a dry waste. So in ward of Mumbai, I have got this information from A ward itself. Then the conclusion of my research is most commonly used napkins. I have told you the 3 napkins which I found the complete polypropylene material is there, even in the top sheet, in the absorbent sheet as well. That are the most commonly used napkins, the well-known brands. And they also has the gel absorbent sheet with them, and which is not biodegradable material, because that gel material we have kept soaked to see whether it is getting degraded, but still 2 months it is as it is. There is no fungus formation, nothing, and even in the soil it is as it is. So we have to do the further study about it, how it can be managed well. It is important to find some alternative solution to manage this waste effectively, or we have to have the segregation chain or segregation of this particular waste and disposal of this waste focus properly. Some sanitary napkins made up of natural fibers which are insoluble in H2SO4, which has to be studied further to understand the composition and reason behind their insolubility in H2SO4. These are my references. Thank you.
Well, any questions? Well in time again. Mamta, thank you for that. Students, any questions, audience? Well, I'll just try to know why these natural fibers are not soluble in H2SO4. Rather, why did you not use perchloric acid combination? HNO3 perchloric combination, because organic matter dissolution will not alone happen in any single acid. Perchloric acid is required for organic matter oxidation.
Sir, actually, I have performed all this test in the textile committee at Worli, and there they have the protocol to say that is the standard protocol that is H2SO4 75% should get dissolved, then only it is a natural fiber. So I had raised this question about why these fibers are not dissolving. So the experts are saying like let's go and study detail how we can find out whether they are really natural or not.
I can understand the synthetic ones made of the chains, polymers, cross-linked polymers, but the natural fiber not dissolving into acid, and then why? First of all, why you want to dissolve it? If you want to see the biodegradability, why not use the other acid? You know, single acid cellulose will not, carbon will not be destroyed. If you want to really dissolve it completely, natural products, fiber should go under complete biodegradation. And why not? So ask them why not use perchloric acid to destroy organic matter if you want to dissolve it.
Yes, sir. Sure, sir.
Well, if there are no other questions, so we go to the
respected ma'am.
Yes.
Sorry?
There is an one of the participants' question that how you got to know that the gel material is not degradable.
Gel material which I have been used, the gel sheet is separated in the sanitary napkin. I have soaked it and put it in the beaker in a locker to just check whether it's a fungal material is there, and then the remaining gel I have mixed it with the soil to check whether I can find it is getting degraded or not. But I'll tell you what, the gel sheet along with the gel, it is as it is. If we'll put water again, the gel sheet will be gel are swelling as it is, because every day you have to put water to keep the moisture over there. So since 60 days, it is like that. So I'll be observing further.
Okay, ma'am. Thank you. Thank you so much, ma'am.
Sorry, I just want to intervene. How do we expect this gel material to degrade within 60 days? Then nature would have been so wonderful. It takes a lot of time, years for degradation.
Yes, sir. Yes,
you
sir.
Find out if your 2-year study program, you find out degradability of that in a soil, starting from months, and every month you'll find that in seasonal variations also, if it's natural waste guards dumping, So
Yes,
we'll have to go to that conditions and find out that, because it's a very important issue.
Right, sir.
Biodegradation of these sanitary napkins is an important issue worldwide, and is efforts to be have good solutions. So we'll have to have long-term experiment to go on. First of all, you have to find by references by the gel can be degrading or not. Only thing in the form of a napkin, how much time it takes more because of blending. So first find out with references these gels are degradable or not, and if they are, then find out time required for when they are blended with this. And third thing, that you can find out something catalytic process for their fast degradation. That's what your study should be. Okay.
Yes, sir. Thank you, sir.
So go to the next one. So you have the third speaker. Is Pritam Kumar Shinde on high performance nickel hydroxide nanosheets for asymmetric supercapacitors.
Yeah, yes, sir. Can I share my screen?
Yeah, please go ahead. Go ahead. The time is 10 minutes. Okay. So
yes, sir.
12:30 should be.
The slides are visible.
Very good.
Yeah. Good afternoon, all. I am Dr. Pritam Kumar Shinde, a research associate under the supervision of Dr. Dimple Datta ma'am at Chemistry Division, Bioatomic Research Center, Mumbai. And my topic is high performance nickel hydroxide nanosheet for asymmetric supercapacitor. The introduction part, with the rapid development of portable electronics and hybrid electrical vehicles, improvement in the electrochemical energy storage device have attracted considerable attention. To meet this ever increasing demand, lithium-ion batteries, the most widely used electrochemical energy storage device, is unable to fulfill the diversified requirements in the partial situation due to its low power density. On the other hand, the electrolytic capacitors exhibit extremely high power density but are incapable of driving high energy electronic device. That means the supercapacitor have great attentions as a promising next generation power sources to fulfill the gap between electrolytic capacitors and batteries. Because a supercapacitor possesses high energy density than electrolytic capacitors, larger power density than batteries, that is the superior life cycle and ultra fast charge discharge process. Generally, the transition metal oxides and hydroxide are widely used electrodes for the development of efficient supercapacitors. Among us, this nickel hydroxide is gifted with the high theoretical specific capacitance is 2082 farads per gram, and it's obtained allied as the discharged state materials in the electrodes owing to its stability and a strong alkaline electrolytes, which is due to the short diffusion path length of the electrolytes as well as the high reversibility and excellent rate capability when oxidized to nickel oxide or NiOH. Nevertheless, in spite of having high specific capacitance, it is a poor electronic conductor, a factor that limits its ability to reach the theoretical capacitance its own. So far, instance efforts have been made to decrease equivalent series resistance and charge transfer resistance by increasing the conducting nature of the transition metal hydroxide. Therefore, by synthesis and fabricating the synthesis active materials on conductive substrates through various methods. All the above methods employed more than one step to synthesize the desired active materials. Moreover, the control overloading active materials involved in the electrochemical reaction by these method was poor. Therefore, another major pitfalls in the conversion of the nickel foam surface into the nickel oxide, nickel foam surface in the nickel hydroxide. During the hydrothermal method, this increasing the resistance, the nickel foam, which is directly affected to capacitive performance of a pristine material. In order to avoid these pitfalls, we have synthesized the nickel hydroxide by one step hydrothermal synthesis by using hexamethyl tetraamide as a reducing agent in the basic medium for the first time. Moreover, the fabricated nickel hydroxide studies in the electrochemical properties in KOH electrolyte along with the 3 electrode system. This is the morphological evolution. The FESM image, that is the flake-like or a petal-like morphology, and the TEM image is higher performance, which shows the petals are interconnected to each other, and the HRTM shows lattice fringes with the separation of separation distance is 0.271 nanometer, and the structural evolution is the conformation of the nickel hydroxide structures on the nickel foam were confirmed by the XRD by using the XRD pattern by using the JCPDS card number 040850 could be matched with the data with the as shown in the figure, and the chemical composition obtained by using the XPS survey spectrum recommended the occurrence of Ni, that is nickel, and oxygen, which is supports the formation of the nickel hydroxide. In addition, the nickel peaks reflects 862.2 electrode volt and 882.5 electrode volts. The oxygen peak is 531 electrode volts. The BET surface results show the surface area and porosity distribution values were obtained as 47.66 meters per gram and the 7.4 nanometer. That is the 3 electrode system, that is half cell electrode is after the confirmation and structural morphological analysis of a nickel hydroxide electrode demonstrate the battery type electrochemical performance as maximum 654 Faraday per gram specific capacitance with 85% cyclability over 5,000 cycles. That is, the nickel hydroxide electrode is attributed to the good cyclic stability. And these images after analysis 3 electrode system by using the half cell electrode system. The half cell electrochemical study by another material, that is anode material. This work is already published is our previous group and published in the SES Omega journal. The hydrogena flowers, these are the hydrogena flowers based bismuth molybdate is the supercapacitor electrochemical materials demonstrate 485 Farad per gram specific capacitance of with the 82% is retained even after 5,000 cycles, which can be attributed to good cycles stability is active material. After the confirmation of both the electrodes, that is bismuth molybdate and the nickel hydroxide, this is the new material and this is the previous material. But the combination, that is the full cell device, we have made the full cell device, that is as a commercial point of view, we have designed the asymmetric supercapacitor energy storage device assembly with the nickel hydroxide, that is cathode material, and the bismuth molybdate, that is anode material. That is asymmetric supercapacitor device demonstrate excellent electrochemical properties with high energy density, that is the 27 watt per kg, and the power density is 883 watt per kg at about 78 cyclic stability after 5,000 redox cycles. In addition, we presented here demonstrate the lightning of the 3 LED bulbs using our laboratory fabricated asymmetric supercapacitor device. In the conclusion of that above study, the above results indicating that the device is a very promising novel energy storage system for fast and efficient energy storage in the future. This is the acknowledged. This work is supported by the CNED lab and Professor R.S. Mane, which is the Director, Innovation, Incubation and Linkage of SRTM University Nanded. And I'm wishing to acknowledge Dr. Dimple Datta ma'am, which is the Scientific Officer G, that is Chemistry Division, Bhabha Atomic Research Center, Mumbai, for their continuous support and encouragement. These are the references. Thank you.
Thank you for finishing in time. Any questions, please? Students must pay attention and think something different, and why this experiment has been done, the suitability, probability, the problems, the materials. You must start thinking about when the student, your friend is presenting a paper. Well, any question?
Yes, sir. This is my question. I had a question. So, sir, how did you fabricate the NiOH? As in your presentation, I was able to see that you fabricated it using a hydrothermal synthesis. So, and you had used a Ni foam. So, I mean, did you get nanoparticles and you coated it on the Ni foam material, or how did you?
Good question. Yes.
That is the pristine nickel foam, where synthesized by hydrothermal synthesis by using hexamethyl tetramine, that is the HMT material as a reducing material. Under the reaction is going on 120 degrees Celsius at 4 hours.
How are you able to hold nickel hydroxide together? It has a tendency touching anything moisture, collide, formations.
Yes, sir.
Any binder you are using? Yeah.
No. I am not any user binder. Only nickel pristine foam and a reducing agent, that is a HMT, hexamethyl tetramine, as a reducing agent. They pour
able to hold nickel hydroxide well, right?
Yeah, yes, sir, sure.
No withering takes place because your other one is like bismuth molybdate. It's a very stable compound oxide.
Yeah.
This is not that stable one.
How
do you manage that?
No. This is not managed.
Not encounter any problem. Yeah. Then these two materials, you want the capacity difference, specific capacitance differences over between the electrodes, cathode and anode is close to about 200. You prefer this difference, or it is can you not try the matching materials both sides?
No, sir. I am using this both material.
Because one has retention 85, the rest has 82%. That difference is too small compared to the specific
comparatively, but the bismuth molybdate is 485. That means near about the 500, and the another one that is the nickel hydroxide material is 600, near about 650. That means 150 degrees. 150 Faraday gram per. That is the specific capacitance is difference.
Okay. So that is what it is. So
yeah, that is working. No issue, sir.
Good work. Yeah. So if there is no other question, we go to the next speaker. Thank you for a nice presentation. Good work. Please carry on for.
Yeah. Thank you, sir. Thank you.
Roshan and your group. Next presentation by Roshan. Rani. Is that correct? Pritam, you can withdraw your presentation.
Hello, sir. I guess now there is a presentation by Shelar, sir. SP Shelar.
Okay. What is the title?
Hello, sir. Can you listen to me?
Yeah.
Can I share my slides?
You can, please.
Thank you, sir. Good morning to all of you. Let me start this presentation on a thanking note to KJ Somaiya College and Organizing Committee for giving me this opportunity to present our research work in this forum. The title of my presentation.
Share your screen.
Yeah, I have already shared, sir.
I can't see. Anybody else? Everybody can see the screen?
No, sir. I think we can't see your screen.
You are not shared. Just look, check it.
Sandeep, sir, can you please reshare?
Just a minute. Is it?
Yeah, now we can see.
Is it in a slide?
Sandeep, you are presenting, Sandeep Shelar? Yeah.
Yes.
Okay.
Yeah. So the title of my presentation is dendrotide peptide mediated targeted delivery of gold nanoparticles to somatostatin 2 receptor expressing cancer cells. Somatostatin receptors are G protein coupled channels which regulate cell growth through secretion of various hormones and growth factors. There are 5 subtypes of somatostatin receptors named SSTR1, 2, 3, 4, and 5. Among them, SSTR2 is highly expressed on cancer cells, mainly in neuroendocrine tumors. Whereas somatostatin is an endogenous peptide ligand for somatostatin receptors, and octreotide and lanreotide are their synthetic analogs with longer half-lives and better stability. Notably, the lanreotide has high affinity towards SSTR2 receptor and hence are commonly used in the diagnosis and treatment of neuroendocrine tumors. Nevertheless, lanreotide has high potential for targeted drug delivery, but has not explored for this application. The gold nanoparticles have wide nanotechnological and biomedical application because of their physical and chemical properties and possibilities for various surface functionalization. They are promising anti-cancer nanomaterials, not only because of their high biocompatibility, but also because of their inherent therapeutic activities such as photothermal activity and radiosensitization. With this background information, the objective of this study was set to develop a lanreotide-mediated targeted drug delivery of gold nanoparticles to SSTR2 expressing cancer cells for enhancing their radiosensitization in cancer cells. Initially, the gold nanoparticles were prepared by citrate reduction method, where the appearance of ruby red color and the absorption peak at 522 nanometer confirms the formation of nano-sized colloidal gold nanoparticles, which is also evident from the TEM imaging. The hydrodynamic diameter and the zeta potential of these nanoparticles were found to be around 31 nanometer and negative 41 millivolt respectively. Such negative charges on gold nanoparticles are highly conducive for electrostatic binding with positively charged molecules such as lanreotide peptide. To study this binding behavior, gold nanoparticles were mixed with increasing amounts of lanreotide peptide, where they appear to show a dose-dependent change in the surface plasmon resonance of gold nanoparticle from ruby red to violet blue color, which indicates the binding between gold nanoparticle and lanreotide peptide. In the presence of 1 microgram per ml of lanreotide, a subtle change in their absorption maxima, hydrodynamic particle size, and surface charge was observed. On the other hand, about 10 microgram per ml of lanreotide, there was drastic change in their optical properties as well as hydrodynamic particle size and surface charge was observed. That would lead to aggregation of gold nanoparticles. Hence, knowing the fact that the size and surface charge on the nanoparticles play a critical role in their binding behavior and colloidal stability, a pH-dependent binding study was performed under fixed concentration of gold nanoparticle and lanreotide peptide. At pH 7 and less, strong binding between gold nanoparticles and lanreotide peptide was found to disturb the kinetic stability, leading to aggregation and sedimentation. Whereas in between pH 7.5 and 8.5, a subtle change in the absorption maxima and hydrodynamic particle size indicates the optimal binding between gold nanoparticle and lanreotide peptide. However, beyond pH 8.5, there was no change in the absorption maxima, possibly because of no interaction between gold nanoparticle and lanreotide peptide. So this pH-dependent binding was attributed to pH-dependent changes in the surface charge on the lanreotide peptide. The isoelectric point of lanreotide peptide is 10.5, and above this pH, the negatively charged lanreotide peptide is not conducive for binding with negatively charged gold nanoparticle. Whereas below isoelectric point, depending on the intensity of the positive charges on lanreotide peptide, they would interact with gold nanoparticle differently. Further, the gold nanoparticles coated with lanreotide peptide at pH 7.5 was found to be stable for up to 1 minute, as compared to colloidally unstable lanreotide coated gold nanoparticle formed at pH 6.5. After successful binding study, the specific targeting and cellular uptake of gold nanoparticles coated with lanreotide peptide in SSTR2 expressing cancer cells was studied by confocal microscopy and flow cytometry. For this study, the gold nanoparticles were further functionalized with thioflavin T, a fluorescent dye for their detection in confocal microscope and flow cytometry. Besides, the AR42J cells expressing high SSTR2 receptors and MCEP7 cells expressing low SSTR2 receptors were used to compare the cellular uptake of gold nanoparticles. Both confocal microscopy and flow cytometric analysis has displayed a significantly higher cellular uptake of gold nanoparticle coated with lanreotide peptide in the AR42J cells as compared to their uptake in MCEP7 cells. Further, the cellular uptake and targeting results were confirmed by the receptor pre-blocking experiment. In this study, cells were pre-treated with free lanreotide peptide before the treatment of lanreotide functionalized gold nanoparticles. Interestingly, significant decrease in their cellular uptake was observed in AR42J cells pre-treated with free lanreotide peptide. This result confirms the ability of lanreotide peptide in selective targeting of gold nanoparticles to SSTR2 expressing cancer cells. Moving further, the effect of lanreotide mediated targeted delivery of gold nanoparticles on radiosensitization of SSTR2 cancer cells was evaluated. In this study, the cells were treated with gold nanoparticles and LP functionalized gold nanoparticles for about 5 hours and then subjected to gamma radiation. As observed from this cell viability assay, a dose-dependent radiosensitization was observed in both the cell lines. However, AR42J cells treated with lanreotide functionalized gold nanoparticle has caused significantly higher radiosensitization. So this result are further supported by the colony formations. As observed from the relative number of colony formation, the LP functionalized gold nanoparticle has caused around 2 to 3-fold increase in radiosensitization of SSTR2 positive cells as compared to insignificant radiosensitization of SSTR2 low SSTR2 expressing MCEP7 cells. These results have further demonstrated lanreotide peptide mediated specific targeting of gold nanoparticles to SSTR2 expressing cancer cells. So in summary, we have developed a lanreotide peptide coated gold nanoparticle system for their targeted delivery in SSTR2 expressing cancer cells, as well as we have demonstrated their ability to enhance the radiosensitization under gamma radiation. So these are the few people I would like to acknowledge for their help and support during this research work, especially Dr. Hassan sir for his continuous help and support. So this is the end of my presentation with this beautiful quote. Thank you for your attention.
Thank you for presentation in time. Audience, any questions on the very important work? No quest for any questions? Come on, students. What do you mean enhance radio sensitization?
So
are you using any first of all, are you using any radioisotope here, gold 197?
No, we are not using any isotope here.
Okay.
We are using.
So what is the why?
Yeah. Because we are using gold nanoparticles, and because of their high G properties, they under the exposure of radiation like gamma radiation, so they will release the energy, and as well as they will
very high cross section it has, 100%.
They also cause production of active oxygen phases, and that lead to the apoptosis of cells, leading to
So you mean they become radio sensitized without getting activated, right?
Yeah, because if
they don't become radioactive, but they become sensitive, right?
we are not getting any radiation out of that. We are giving radiation to kill the cells.
I know. We are not activating to make it 196 to 197.
Because the problem in cancer therapy is that the normal cells and cancer cells, they behave similar. So how we can distinguish them from the normal cell is that
under the influence of gamma radiation, the bone nanoparticle become more sensitive and more reactive, right?
Yes, right, sir.
That's in short. Very interesting, very interesting. Yeah. So, well, that was my just small query. Any other question? Okay, if there are no other questions, we go to the next presentation. Thank you very much, Shala.
Thank you, sir.
Good presentation. So next one, who is that? Rati or Vikas? Some number change. Who is ready now? Rati Bera? Yeah, I have noted on my paper. Anyway, who is ready to present next paper? Okay, Rati. That is your presentation. Go ahead,
Need to be removed. Oh, yes.
You can share your screen.
Okay, sir. It is visible, sir?
It is visible.
Okay. Good afternoon to all of you. Myself, Dr. Ratikant Bera, from Department of Chemistry, Indian Military Academy, Dehradun. My paper title is Iron 3 Selective Membrane Potentiometric Sensor. In this work, we have developed ion selective electrode for iron. But what is an ion selective electrode? Generally, ion selective electrodes are they transfer the analytical information obtained by converting the recognition process into a potential signal, which is proportional to their concentration. These ion selective electrodes are gaining their importance due to their cost effective. They don't require any pre-treatment of sample. They are reliable. They can detect the analyte in real time and real space. And also they don't get affected from the color and turbidity. They're having the better lifetime and operational pH range. So why we have choose for iron to develop iron selective electrode? Because iron is considered as important metal for extensive range of cellular processes. It is said that life is not possible without this metal ion, with few exceptions in bacterial world. Many protein and enzymes contain iron either for their structural properties or for part of catalyst site. Even though iron plays a crucial role, it becomes lethal when the normal permissible range exceeds. Iron deficiency causes several diseases. One is the important one is the anemia, which is well-known disease in India. About 70 to 80% Indian infant population is suffering from this disease. Excessive consumption of iron also causes severe toxicity that leads to the irritation of stomach, vomiting, heartburn, and circulatory collapse. Therefore, quantification of this metal ion is very, very important. Among all other quantification process like fluorescence technique, UV visible spectroscopy, atomic absorption spectroscopy, ion selective electrodes are gaining importance. As I said before, they don't require any pre-treatment of the sample and having very low detection limit as well as good lifetime. We have selected an ionophore. This ionophore is a tripodal one, which is C6-135 tries 2-hydroxybenzyl imino aminomethyl cyclohexane, which is to be abbreviated as THAC, THAC. This is the structure, because why we have taken this ionophore to develop the ion selective electrode, because this ionophore, we have studied the complexation with various metal, but its log beta value or stability constant with iron is very high than any other metal ions. It is around 24. So this ionophore coordinate to the metal ion through 3 amine nitrogens and 3 phenolic oxygen to give a uncharged N3O3 type hexa-coordinated complex. This complex behavior of this ionophore with several trivalent metal ion studied suggests that it having the higher affinity towards iron 3. So this apparatus we have used as a Thermo-Orion 720A plus pH meter to record the EMF of the EMF. The cell potential was measured by varying the concentration of metal ion from 10 to the power minus 8 molar to 10 to the power minus 1 molar metal ion solution we have taken. The pH adjustment, if it is there, then we have carried out it with dilute HCl and NaOH addition. Membrane and electrode preparation we have carried out through the various steps. A number of membrane we have prepared by mixing ionophore, PVC, plasticizers in various proportion, which table is given after this slide. Various amount of ionophore, this ionophore which I have shown, PVC, plasticizers, and anion excluder also were mixed thoroughly in 10 ml of THF. The resulting homogeneous mixture was transferred into a glass dish of 30 millimeter diameter. THF was allowed to evaporate at room temperature. After 24 hours, transparent membrane were obtained, and this membrane were glued to a cutted for 1.2 cm diameter and were mounted on the ground end of a Pyrex tube with araldite, and solution of iron 3 or metal nitrate solution are used as a conditioning. The optimization parameter, if you look at this, the EMF of the electrode prepared by the method which I have said earlier, their EMF was recorded by varying the different composition of the ionophore, PVC, plasticizers, and their responses were recorded, EMF responses were recorded. And it is found that electrode with the composition of electrode number 3 with electrode number 3 with the composition of 4% of ionophore, 33% of PVC, and 63% of orthonitrophenyl optyl ether as plasticizers gives a good response. His linear response is 10 to the power minus 5 molar of iron solution to 10 to the power minus 1 molar iron solution, with a detection limit of 7 into 10 to the power minus 6 molar, and its response time was also very good, that is around 15 seconds. So this is the response of ion selective electrode. We have studied also, it is also required to understand the pH influence as well as the effect of internal solution and reproducibility. Internal solution of 10 to the various internal solution were prepared and tested, but a 10 to the power minus 3 molar concentration of iron nitrate solution was suitable for the optimized electrode assembly. The reproducibility was also studied by the help of 5 membrane with the same composition were prepared, and their data were obtained, and the average data was matched with the data already I have told. The pH, influence of pH on the EMF response of the electrode were tested from pH 1 to 9, pH 9, using 2 different solutions, that is 1 into 10 to the power minus 2 and 1 into 10 to the power minus 3 molar of iron 3 solutions. And it is observed that pH remain unaffected and almost constant from pH 3 to pH 6.5. Outside this range, there is a steady change was recorded. This change may be due to less availability of iron 3 ion at the higher pH, where iron can form hydroxide complexes, to a greater extent. However, at lower pH, the ligand is unable, the ionophore is unable to coordinate from the phenolic OH group. And again, H plus ion acidic medium, H plus ion concentration are interfering with the EMF record. Selectivity coefficient of an ion selective electrode is an important parameter to get the selectivity. So in this method, we have chosen a match fixed interference method and match solution method. Okay, in order to match potential method, in order to know the selectivity coefficient. So here are the selectivity coefficient of the two ligands. This last one, THSE, the present ligands, and already reported one. We have data given for comparison. The present ion selective electrode or the proposed ion selective electrode is sorry. The selectivity coefficients are in the order of 10 to the power minus 2 for various ion, and it's clearly said that the present sensor exhibit high selectivity towards iron 3 over various interfering cations. The potentiometric selectivity coefficient values are in the order of 10 to the power minus 2 for different divalent as well as trivalent. Here the selectivity coefficient for 14 metal ions are given, and potentiometric titration was carried out. The projected ion selective electrode was performed well in the laboratory environment and was also implemented as an indicator electrode in potentiometric titration for Fe3 iron solution against EDTA solution. A sigmoidal curve is obtained, which shows that that the neat titration curve provide a sharp endpoint, which gives that there is a good selectivity as well as the good selectivity in presence of EDT iron complex also for the present ion selective electrode. So from the above studied, we may conclude that this ligand or ionophore THSE, which can be used as a ionophore for fabrication of a PVC based membrane electrode for the specific quantification of iron 3 ion. The best formulation of the anticipated electrode was prepared by taking 3 gram of 3%, 4% of THSE, 33% of PVC, and ortho nitrophenyl octyl ether 63% weight by weight method. The electrode demonstrated a linear response to a wide range of concentration with an unsteady slope and firm response time. And this electrode also able to tolerate up to 20% of non-aqueous medium content, and the electrode performed well in the pH range of 3 to 6.5. So the lifetime of the THC is 4 month, and these are the references. Thank you very much.
Yes, is open for discussion. Ratikanta, thank you for finishing in time. Presentation is open for discussion, please. Meanwhile, I'll try to ask you. I don't see any interference studies of manganese, which is normally associated with iron ferrosulfuric manganese. Is it interfering?
Sir, with manganese. Magnesium is there? No, sir. No.
No, Mn.
No, sir. It is not interfering, as we have taken the +2 state nickel, copper. From that, we conclude that it will not interfering. We have studied also the potentiometric and spectrophotometric study for complex study.
I didn't see that in your list of interfering ions.
Yes, sir. Totally, we have taken 14 metal ions, and
so iron is not interfering. Okay.
Yes, sir.
So this list is of interfering elements.
Yes, sir.
Okay.
Thank you, sir.
Thank you very much. So we go for the next presentation. Vikas Yadav. Vikas will be presenting. Yeah.
Excuse me, sir. I think Roshan is.
Roshan is waiting for. Okay. Roshan Rane, you can start. Roshan, you are presenting.
Sir, you can speak.
Yes, sir. Yes.
Okay. Start your presentation. Augmenting electrochemical performance of graphite recovered from spent lithium-ion batteries.
Yes, sir. So,
good, well visible.
Good afternoon, everyone. My name is Roshan Praveen Rane. I'm pursuing PhD under the guidance of Dr. V.R. Patil. And my today's presentation topic is augmenting electrochemical performance of graphite, which is recovered from spent lithium-ion battery for the sustainable circular development. So before going to topic, we'll discuss some basic concept. That is, what is battery? Battery is energy storage device, which is useful in laptops, electronic vehicles, mobile phones, and then our smart watches. Nowadays, lithium-ion batteries are popular due to the Tesla car or Tata Nexon car, then Honda electronic vehicles. But why we use electronic batteries? That is lithium-ion batteries. Because lithium-ion batteries have several advantages like high specific energy, cell voltage, strong capacity retention, and negligible self-discharge. Now we see the different parts of lithium battery. Battery have cathode, anode, separator, and electrolyte. Cathode is a positive electrode which is made up of different type of metal oxide like lithium cobalt oxide, lithium manganese oxide, lithium iron oxide, and different mixed metal oxide like lithium, nickel, cobalt, manganese oxide. The anode is made up of carbon material like graphite, graphene oxide, and different carbon composite. The separator is made up of polymer, and electrolyte is LiPF6, lithium hexafluoride phosphate. On the right side of the, you can see the material composition which is present in battery. That is, anode is 22%, cathode 31%, the copper which is charge collector 17%, aluminum which is also charge collector used as a cathode which is 8%, then electrolyte solution 15% and 3% separator part. Now we see the growth of lithium-ion battery. From the graph, we can clearly see that in 2009, approximately 134,000 tons of battery were produced. This number will increase in 2019, that is more than 1.2 millions of tons of battery were produced. And it is expected that this number will reach around more than 12.7 million tons. Means the battery production number is increasing by tenfold up to 2030. So the large number of batteries is going to be create and huge amount of waste also. And this waste disposal is the major issue nowadays. So I did local survey in Mumbai where I found that the local shopkeeper, the mobile repair shopkeeper simply throwing the lithium-ion battery, or the common man simply throwing the lithium-ion battery in dustbin or dumping in ground or simply burning it. So this is because there is no awareness of proper dismantling process. So and it is producing several environmental damages. So what is the solution for this? The main solution is recycling of spent lithium-ion batteries. But there are several challenges in recycling lithium-ion battery. The business of recycling is unprofited due to there are several chemistries which is cobalt-free chemistry. Means no metals are present in cathode material. So if metal are not there, then what can we recycle? Then second, the main part which is anode part is used in battery, that is graphite. Graphite is used in battery as an anode material. According to ITRI-IEK research, around 100,000 tons of anode material which having graphite included in it manufactured in 2020. But there is a problem. There is also one problem with graphite. For the production of graphite, for the production of 1 kg of synthetic graphite, it requires 1.2 kg coal and 1 kilowatt energy. Means a lot of energy is consumed as well as lot of coal is required. The second problem is mining. Due to the graphite mining, it produces environmental pollution. Then it's emit hazardous gases. Then different types of acids are used for the leaching purpose. So these are the some environmental damages which is due to the graphite production. So because of this, the manufacturing plant or the manufacturing operation throughout the world are facing legislative challenges. I will give you an example that in China, almost 3% graphite production plants are banned. And in India also, in Bangalore, High Court given decision to ban 2 graphite plants. So, but graphite is the essential material in the lithium battery. There is but why we are using graphite instead of recycled graphite? As we discussed in previous slide, we have lots of lithium-ion battery waste, which having lots of graphite in it. So spent graphite in it. So we can use this spent graphite by recycling it instead of virgin graphite. But there are some problem in recycling industries, like due to cobalt-free cathode chemistry, the business is unprofitable. Then specifically about graphite, graphite is cheap in cost. So and it is time consuming, and it is time consuming. Techniques are required for the recovery of graphite, and the recovered graphite also show lower specific capacity, that is less than 300 milliampere per gram. So for that, to overcome this problem, we started working on one scheme, that is augmenting electrochemical performance of graphite obtained from spent lithium-ion battery for the sustainable circular development. Means we simply recovered graphite from spent lithium battery, convert into reduced graphene oxide, then dope with phosphorus and form its nanocomposite with B8TiO3. And we have successfully used this B8TiO3 PDOF RGO nanocomposite as an anode material in lithium-ion battery, which is giving specific capacity more than 750 milliampere per gram. The virgin graphite or the recovered graphite is given specific capacity less than 300 milliampere per gram, and our developed material giving specific capacity 3 times greater than virgin material. So this is the first step of our scheme, that is recycling of graphite from battery. So various LIBs which having cathode anode material were sliced, broken and sieved to produce powder which having unpurified graphite. Then this graphite is leached with 5 molar sulfuric acid with H2O2. Then we obtain residue and filtrate which having purified graphite. But as we discussed, graphite is showing less specific capacitance. So we dope it with phosphorus and further form nanocomposite with B8TiO3. So first we convert graphite into graphene oxide by simply using Hammer's method, well-known Hammer's method. Then we, in recycling process, we have added triphenylphosphine, which is the source for the phosphate doping. And further we have added B8TiO3 nanoparticle, which is synthesized by hydrothermal technique to form nanocomposite of B8TiO3 PDOF RGO, which we have successfully used as a anode material. These are the characterization for said material. We did XRD, then Raman, then BET study. Here we got required peaks for the B8TiO3 and PRGO in our synthesized material. So it's showing that our material is properly synthesized. Next, on then we did BET study. On BET study, we get to know that BET surface area is increased. The result is
Hello, Roshan. You are muted.
Okay, sorry. Here we see the surface area 23, total pore volume 0.07, and average pore dimension 4.13, which is increased in B8TiO3 PDOF RGO. So because of this increased surface area, pore volume and pore dimension, the electrochemical performance is also increased. this is the SEM, TEM, and HRTM study. In figure A, we can see the spherical structure of BeTu3 nanoparticle. In figure B, we can see the sheets of reduced graphene oxide, and in figure C, we can see the BeTu3 material is adhere on the sheets of phosphate of reduced graphene oxide. The images D, E, and F are the TEM image, and images G, H, I. In the image G, we can see the particle size of BeTu3 nanoparticle is 0.28 nanoparticle. Figure A shows diffraction pattern which matches to standard diffraction pattern, and it confirms that the formation of PDOF-RGO, and figure I is the mixture of, means the formation of nanoparticle is confirmed in the image I. Then we did elemental analysis where we found that beryllium, oxygen, carbon, titanium, and phosphorus is present in the BeTu3 PDOF-RGO nanocomposite which we have synthesized. Then further, this synthesized nanocomposite is used as an anode material for the fabrication of coin cell. For the fabrication of coin cell, we have taken our nano material with carbon black and polyvinyl fluoride, which is binder. This were mixed in the ratio of 80-10-10 by using solvent N-methylene pyrrolidone. Then this slurry were applied on the copper current collector, dry for overnight at 80 degrees Celsius under the vacuum, then roll placed and cut into 10 mm disc. Then here we use LiPF6 lithium hexafluoride phosphate as a electrolyte solution with 1:1 ratio of diethyl carbonate as well as ethylene carbonate. Then here we use separator, that is polypropylene film Silgard 2400. After the electrochemical study, we got this electrochemical performance that the charging and discharging capacity of our nanocomposite were found to be 740 milliampere per gram and 824 milliampere per gram. Means recycled graphite is showing a specific capacity less than 300 milliampere per gram, and our nanocomposite means we recycle graphite and dope with phosphorus, form nanocomposite with BeTu3. During the recycling process, this showing 740, 824 means threefold specific capacity is increase of our said nanocomposite. Then up to 100 cycles, the material demonstrates specific capacity up to of 428 milliampere hour per gram at 0.1 ampere per gram current. Means it is showing excellent stability of our nanocomposite. And even at high current density, that is 2 ampere per gram, the reversible capacity was obtained was 355 milliampere per gram. Then we study RS, means resistance. RS and RCT values were found 2.01 and 23.11. As we see that graphite, graphene, N-doped graphene, B-doped graphene have have resistance value higher than our nanocomposite. Means our nanocomposite showing high electrochemical performance as compared to other nanocomposite. So conclusion, this work offers cost-effective and viable method for recycling of graphite. So we have recovered graphite and convert into high-performance LiB material by simply doping with phosphorus atom, which is more electronegative, and form nanocomposite by using BeTu3 nanomaterial. Then we have successfully used this BeTu3 PDOF-RGO nanomaterial as in lithium-ion battery coin cell for the synthesis of new LiB. Then it's showing excellent electrochemical performance like 824 milliampere per gram initial discharge capacity, which retains up to 428 milliampere per gram after 100 cycle. And furthermore, at high current density, it is showing 355 milliampere per gram current density. So it also adheres the principle of green chemistry, like reuse, then reduce, reuse, and value addition. Means here we are reducing the use of virgin graphite, which creating pollution during the synthesis of virgin graphite. We are using the waste graphite, which is available in discarded batteries, and we are value adding the recycling process. So recycling process may be profitable because of these resources. So these are the references which I have used. I want to thank my guide, Dr. V.R. Patil sir, Mumbai University, Kalina campus, Dr. Sunil Peshne, my co-guide, and I want to thank Somaiya College for giving me a chance to present my work. Thank you so much.
Thank you very much for presenting paper in time, Roshan. Are there any questions? Unfortunately, I have some problem with my video, so I'm not probably visible. I got the message, but something is wrong. So, good, at least I'm audible?
Yes, sir. Yes, sir.
Good. So, any other questions? One should ask him why more valuable you are not after bismuth lithium, but you are under the graphite, the low cost material. What are your intentions? Intentions are good, but you must tell people. You are after graphite recovery, right?
Yes, sir. Yes, sir.
Rather than lithium. People are dying for lithium. You are after graphite. Why?
All other metals we are recovering all other metals, but nobody give attention on graphite because of.
So you want to pay attention.
Yeah.
What is the percentage like? To go by percentage of graphite content?
Percentage of, sorry, sir?
Graphite percentage in batteries.
22% graphite, sir.
Okay. Otherwise, where does it go? If you don't recover, where does it go?
It goes in nature, sir.
As a waste, say solid battery waste, right?
Yeah, sir, battery waste.
Yes. So good. So if there are no questions, we thank Roshan for a wonderful presentation.
Thank you, sir.
Thank you very
Thank you,
much.
sir.
Thank you. Thank you. The next one we have.
So Vikas.
Vikas or Monica?
Vikas.
Okay, Vikas. Now share your screen. So let me see if I am visible. There are so many questions in chat box. Somebody can handle them at the end of the last paper. The chat box seems to be full. Vikas, go for your presentation.
Sir, am I audible?
Yes, yes.
Okay. Yes. Is my screen is visible?
Not yet. Now we can see. What about others? Are you able to see the screen?
Yes.
Yeah. Good afternoon, sir. And good afternoon, everyone. Myself, Dr. Vijay Kumar Yal Chavan, Research Guide at Ram Narayan Ruya Autonomous College, Matunga. Today, myself and my student both are present. Mr. Vikas Yadav are going to present a paper which will touch a very serious issue of entire world, that is destruction of natural resources because of industrial effluent, which is carelessly thrown into a natural water body and thrown openly into an environment. The topic of our today's presentation is highly efficient nanomagnetic catalyst for degradation of industrial dye effluent. As far as our work is concerned, it is by considering all the industrial zones nearby Mumbai, we decided to carry out this work. And as we all are aware of this, my content of our presentation is there on the screen. It contains introduction, material and method, result and discussion, conclusion and future scope, acknowledgement and references. Different different industries play an important role in development of all the countries by producing different products which are helpful to human being as well as other living beings. But at the same time, it also brings several problems to an environment because of the discharge of industrial effluent into water bodies. Industrial effluents from different industries like textile industry, paint industry, pharmaceutical industry, dye industries are hazardous to aquatic life as well as flora and fauna. And as it is a global issue, it has become a global issue because and therefore people are struggling to resolve this issue by doing some research over it. Industrial waste is directly discharged into water bodies through water bodies through food chain. It may reach again to different plants, animals, or maybe reach to human being. So there it shows its consequences. Methylene blue is one of the most used dye by different industries. It is organic dye which is used in different industries like textile industry, pharmaceutical industry, dye industry, paint industry, etc. The effluent of this kind of industry contains this organic dye which have adverse effect over the aquatic life, to the plants, to the animals, to the human beings, etc. So now I request my student Vikas Yadav to proceed with the remaining presentation.
Okay. Good afternoon to everyone. Myself Vikas Yadav, and I am pursuing my PhD under the guidance of Dr. Vijay Kumar L. Chauhan from Ram Narayan Ruya Autonomous College. Till now, my sir had already explained what are the major effect of these directly discharged effluent of different industries. So our main focus is on methylene blue. Why that methylene blue is important to know to everyone. Okay. Now, what happened when methylene blue is discharged directly in the environment? What happens is that it will reduce oxygen demand to more than 90%. Whereas if you talk about some other industrial waste, that will reduce oxygen demand to around 60% or more than 60%. So now it is very clear that if you have methylene blue in your effluent, that will going to remove 90% or more than 90% of the oxygen from that water. So again, that will become a very destructive thing for aquatic life as well as for a marine life. Okay, this methylene blue is also used to treat some of the diseases, but the same time higher concentration of these diseases in a human being may produce nausea, abdominals, precordial pain, dizziness, headache, profuse sweating, mental confusion, and high doses may lead to one of the serious issue called as a methemoglobin. What happens in a methemoglobin is that hemoglobin iron oxide get converted from Fe2 plus to Fe3 plus. When it get converted from Fe2 plus to Fe3 plus, it will release its oxygen. There are no chances of oxygen to bind in a porphyrin ring. So that leads to a very serious issue of breathing to a humankind. And next is this methylene blue is highly soluble in a water and very stable because it contains a azo group, which is very good chromophoric unit. It give a very intense color in a minute quantity. Normal methods like flocculation, sedimentation, adsorptions are not that much efficient to remove 100% of these dyes. Our studies showing almost degradation to 100%. These are the pie chart of a different industrial effluent of dyes. So if you look carefully on a pie chart, it is very clear that 54% of if dye effluent coming out from a textile industries, then 21% coming out from a dyeing industries, 10% from a paper industries, 8% from a tannery and paint industries, 7%, around 7% coming out from a dye manufacturing industries. So it's a big number. Material and methods. All the chemicals were brought out from Sigma Aldrich and a local vendors. For a study, we had used the Shimadzu UV 1800 spectrophotometer. Methods. 6 into 10 raised to minus 6 molar solution of methylene blue was prepared. Then 10 ml of that methylene blue solution was mixed with a 4 mg of sodium borohydride. This solution 2 ml was taken directly in a cuvette, and a different volume of 1000 ppm solution of catalyst was added, and this degradation was monitored by using UV visible spectrophotometer. Right side you are seeing the catalyst which was prepared and characterized by different techniques. It was loaded on a magnetically active nanoparticles, which gives a very good result for degradation as well as for removal from a reaction mixtures. Result and discussions. Left hand side you are seeing a structure of active methylene blue, which shows a very intense blue color when it was subjected to a catalyst in a presence of sodium borohydride in a solvent like a water, again a green solvent. At room temperature it will give its leucoform, which is colorless. The graph, the pictures clearly show that the blue color get totally disappeared in a reduced form of methylene blue. Okay. These are the plausible mechanism by which this dye get reduced. First, the catalyst absorb that hydrogen which is given by a sodium borohydride by leaving a by adsorbing on a surface of palladium. Then that hydrogen get transferred from that surface to a methylene blue, and that methylene blue get reduced and form a leucoform of methylene blue, which show colorless, and same time will get our catalyst back. So it is a very important route by recovering our catalyst back. Or these UV spectra was recorded by mixing a 10 ml of methylene blue of 6 into 10 raised to minus 5 molar with the sodium borohydride. It is very clear that after a 150 minute also there are very less absorbance, there are very less degradation was seen by this UV spectra. The initial was 1.8, and after 2.5 hours still it is showing a 1.5% absorbance. So now from this it is very clear that that dye is not that much degraded by using a sodium borohydride. Next is a different concentration of our 1000 ppm solution of catalyst was added to these mixtures. It was found that when 20 microliter of 1000 ppm solution of catalyst was added, it get totally reduced within a 3.3 minutes. So again that picture showing you the blue to colorless solutions, which indicate total degradation of methylene blue. Right side you are seeing a UV spectra which was recorded for a 440 microliter 1000 ppm of catalyst. It is showing that within a 15 seconds the whole methylene blue solution get degraded and gives a colorless solutions. The same procedure was repeated with 60 microliter of 1000 ppm catalyst, and it was shows that the degradation time was around 9 seconds. For a 80 microliter catalyst, it was shown around 4 seconds. So now it is very clear from these graphs. This is the summary of all the graph which was shown to you. Methylene blue was taken around 2 ml of 6 into 10 raised to minus 6 molar. Then sodium borohydride around, it's wrongly written over here by mistakenly, it is 4 mg, not 0.8 mg for a 10 ml, but for a 2 ml it is 0.8 mg. Okay, so next is 1000 ppm catalyst solution was added. When no catalyst was added, it was found that time degradation for the methylene blue is too high. We had checked for a 150 minutes, but when we kept for 2-3 days, the solution was still blue in color. So very less degradation was occurred in a presence of only a sodium borohydride. But when we expose this solution in the presence of catalyst, when 2 microliter was catalyst was used, it's shown that it takes for a degradation around 3.3 seconds. When 4 microliter was added, it's shown 15 seconds. When 6 microliter was added, it's shown a 9 second. From 8 microliter, it show a 4 second. So from this study, it is very clear that when we increase our catalyst solution, the time for a degradation is also reduced. So that 8 microliter is very good for degradation of this dye of 1000 ppm of solution of catalyst. Now, what the conclusion and the future scope? Why our catalyst is so important? It give a very good simplicity in operation, because most of the reactions involve a plenty of workup, post workup, which is very tedious and time consuming. Our catalysts are magnetically active. The right side pictures clearly show that when the solution was dispersed, catalyst solution, it show a brown in color. But when we expose that solution to an external magnetic field, all the catalysts get stuck to the wall of vials, and your solution will become now colorless. So it is very clear that you can remove we can remove our catalyst by just applying an external magnet, which will decrease the time consumption of post workup, and that process also become very easy. Same time, we had checked that catalyst, the leaching of catalyst by just stirring the solution of catalyst in a water, and after removing a catalyst, we use that solution for a degradation of dye. It was shown that that solution is not showing any good degradation. That means it is clear that the leaching of dye in a water is not occurring. So that is the importance of our catalyst. We are also planning to do this to use this catalyst for some other pollutant dye like rhodamine, which is now considered as a carcinogenic and which have a very adverse effect on humankind as well as and other part of our flora and fauna. We are also working on some catalytical activity of this catalyst in a different carbon-carbon coupling reactions like Suzuki coupling, Songasira, and Mizoram Hack reactions. With that, we are finished with our presentation. I would like to thank my mentor, Dr. Vijay Kumar L. Chavan, for his valuable support throughout my research. I'd also want to express my gratitude to Professor Vivek Polshettiwar and his team of Tata Institute of Fundamental Research for helping me with my research and allowing me to use his facilities. At the end, I would like to thank my family members and my colleagues for their kind support and keeping me motivated during all these studies. Thank you. These are my references which I used throughout my experiments. Thank you. Sorry.
Are there any questions? Because have you used some real samples?
No, sir. I had prepared a methylene blue from that concentration which I had mentioned around 6 into 10 raised to -5. I had also checked with different concentration also, but yeah, I had checked on I had go through on the papers in which they had used these dyes of different industrial effluent, but these dyes have more than, if that dye have more than 10 ppm solution in a moment, so it causes many effect to aquatic
So
life as
take
well as
a round around Mumbai and you find how the dyes industries are polluting your right from Mithi to Ulhas rivers, and many more right up to Kalyan, Bhiwandi, Amarnath. So doing laboratory work is very good, but then always you should try some real samples, and
okay, sir.
see
In
that
future,
how
I'll
it works. You can find interferences and all that. Okay.
Okay, sir. Okay, sir. Definitely, sir. I'll do
Always
that.
in such analysis, one student must do real samples. All those who have given presentation must do analysis of real samples wherever your method is applied to, applicable. Okay, so we go for the last presentation. Monica Khurana, you are there?
Yes, sir.
Okay, so you can start your presentation. She'll be talking on green synthesis of gold nanoparticles from the plant extracts, and she's coming from Haryana. Good, all of you from distant places having taken interest in this conference. Good, so Monica, go ahead.
Yes, sir. So are you able to see my screen, sir? Hello?
Yes, it's visible.
You can enlarge is better, is visible, yes.
Am I audible also?
Yes.
You are audible, but can you enlarge the screen?
Yes, sir.
Right? Yeah, okay. Yes, this
All
better.
right. Very good afternoon to everyone present here. So today I'm going to present on the topic green synthesis of gold nanoparticles using plant extract. Actually, my work, I would like to brief you that it's on the lipid membranes, and then I wrote a project of gold nanoparticle interactions with lipid membranes. So when I did that project, so I was procuring the gold nanoparticles from the commercial suppliers like Sigma and Aldrich. But then later on, I realized that by getting the gold nanoparticles, which are prepared through chemical synthesis and not environment friendly and very expensive also, so why not I prepare myself? And then I came on this topic for the preparation of gold nanoparticles through green synthesis. So these are the just preliminary study which I am presenting, because this just I started the green synthesis process. Otherwise, I was procuring and then doing the experiments. So before doing this, I would like to describe the nanoparticles having the dimensions in the range of 1 to 100 nanometers. So any particles having dimension in the range of 1 to 100 nanometers are called nanoparticles. So green chemistry, basically the particles will be prepared through green synthesis. So green chemistry is the actually area of chemistry where the processes are used which does not produce harmful chemicals into the environment. So nowadays, the nanoparticles through green synthesis has become very common. So synthesis of nanoparticles, which are prepared by the biological routes like from plants, fungi, microorganism, etc., are very much in common. And because it has, and one can control the size, shape, and it has a lot of applications. So now synthesis of these nanoparticles, there are actually nanoparticles are prepared by top-down and bottom-up approach, and these are very common. Those who are doing research on nanoparticles, they are very much aware of these two techniques. So top-down approach is that you prepare the nanoparticles from the bulk material and then you scale down to smaller nanoparticles to the particles of nanometer scales. And then these are the techniques which are used to prepare top-down approach from bulk material to the nanoparticles, like sputtering, chemical etching, thermal laser ablation, mechanical ball milling, explosion process. These are some of the commonly used techniques. And second is the bottom-up approach. In top-down, there's a lot of energy gets involved. So bottom-up approach is much more preferable than top-down approach, because in the top-down approach, the surface defects are there when you prepare the nanoparticles. So the surface is not smooth. There has been found some defects on the surface. So bottom-up approach is much more, preferable by the scientists. So in bottom-up approach, you start from the atoms or molecules or clusters, and then you prepare the nanoparticles. So from 1 nanometer to, for example, 50, 100 nanometers, we go like this. We are scaling up in the bottom-up approach. So there are certain techniques like atomic molecular condensation, vapor deposition, sol gel process, spray pyrolysis. These are mentioned here. So next is so green synthesis. of the nanoparticles has been done. So what are the principles of actually green chemistry? So nowadays, nanoparticles which are prepared through green synthesis have a lot of benefits. Like first, it prevents the waste. There is no waste. Some of the waste like plants, like even nanoparticles are prepared from fruit peels, which are considered as a waste. So we can prevent waste through green chemistry, by synthesis through green chemistry, and waste can also be prevented by making the less side products. Actually, the byproducts or side products are not formed through green synthesis, and maximum atom economy. Like whatever reactants are present, atoms are present in the reactants are converted into the products. If there are no byproducts formed, then all the atoms present in the reactants are converted into the products. So there is less wastage and it gives you the maximum yield of atomic economy. So it produces less hazardous chemical synthesis. So the chemicals which are used or produced by this method are very less hazardous or non-toxic in nature. Safer chemicals and products are used and safer chemical and products are produced. So safer solvents and reaction conditions. So harmful chemicals like benzene, chloroform, these harmful chemicals which are not safe for humans are not used in green synthesis. So mainly like aqueous solutions and the solvents which are not harmful, they are used. So there is increase in energy efficiency through this process, and the use of renewable feedstocks are mainly used in green synthesis. The products which can be reused, or if any byproducts are formed, that should be reusable in some other reaction materials so that there is no wastage. So in green chemistry, we avoid chemical derivatives like protecting groups, which are used in chemical synthesis greatly, but it's not used in green chemistry. And the use of catalyst is there, which will increase the rate of the reaction and will definitely increase the efficiency of the reaction. Then there's a design chemical and products to degrade after use. If any waste is produced, that should be degradable so that it does not harm the environment. So analyze in real time, so we can prevent pollution through this by analyzing and then minimize the potential for accident. When we are not using any harmful chemicals, so it minimizes the potential of accidents also. So basically, by using green synthesis, green chemistry, we are reducing the waste materials and there is less risk, and it's cost effective, and it is environment friendly. So now how to prepare the nanoparticles by plant extracts. So first, it's actually an easy method. First, the plants are collected, plant leaves are collected and it is dried, and then it is boiled, it is dried, it's washed with distilled water, and then it is dried and then boiled. And then after boiling it, then it is filtered through the Whatman filter paper. And then you add the respective salt solution to this plant extract. Then the color of the solution changes and the preparation of nanoparticles will be there, and you can separate the nanoparticles. This is how the synthesis of nanoparticle is done through green route. Now, why I'm interested to prepare green gold nanoparticles. So gold nanoparticles has actually a lot of potential applications. Actually, gold nanoparticles are like inert material. So it's not reactive, it's biocompatible, and it is used in drug delivery. It is used as sensors in bioimaging, as imaging markers, in dyes, and it is used as catalyst in many organic reactions. It has antimicrobial properties, and it's used as imaging targets, like to detect the tumors, and as biosensor. It has multiple applications. So the gold nanoparticles are prepared from the hibiscus plants, which is like biologically safe and environment friendly and cost friendly. So it is prepared from actually plant extract. It is a reducing agent. So it contains a lot of organic chemicals like phytochemicals like flavonoids, tannins, and polyphenols. So there are many alkaloids. So these are the chemicals which are present in the plant extract, and it acts as a reducing agent, and it reduces the metal ions into the metal particles. So gold oxide is used to prepare the gold nanoparticles, and plant extract acts as a reducing agent, which will reduce the gold ions into gold atoms. So then the gold nanoparticles are prepared, which can be characterized by UV visible spectroscopy. This is the first basic technique to characterize the nanoparticles. And the preparation of gold nanoparticles is like the surface plasmon band in the UV visible spectroscopy comes at 522 nanometers, which is like clearly in agreement with the literature value. So on the right hand side, this is the transmission electron microscopy, actually to see the size and the morphology or the shape of the nanoparticles prepared. So it's a circular in shape, and actually the size and shape can vary. One can do a lot of research on the size and shape of the nanoparticles. It can vary by varying the pH and the concentration of the plant extract. One can work on that if one is working only with the nanoparticles. So different sizes and shapes can be prepared by varying the pH and the temperature and the concentration of the plant extract. Now, actually the inspiration for preparing the green nanoparticles, it's easily available, it's eco-friendly and cost-effective. And if you prepare nanoparticles from Sigma Aldrich, even 25 milliliter of solution costs around 10,000 rupees. So very expensive. Here it is very cost-effective, and it acts as a good reducing agents. And different sizes and shapes can be prepared using the plant extracts. So future work is like, I would like to characterize more of these nanoparticles which are prepared through green synthesis, through different techniques, and obviously would like to prepare different sizes of nanoparticles to see their interactions with the lipid membranes, and that has potential applications in drug delivery and imaging targets. So gold nanoparticles also act as imaging targets. Thank you so much. Any query?
Thank you, Monica, for presentation in time, short and sweet presentation. Let us see if there are any questions from the audience. Any questions? Yeah, you have shown the ways for making nanoparticles for large number of applications. I don't know what size confirmations after preparation, which instruments you use for.
So mainly you get around 15 to 30 nanometer size by using this technique, but we can definitely prepare the desired size and the desired shapes also by varying the pH, temperature, and the concentration of the plant extract. So I need to explore all this.
Which instrument you didn't use any instruments for that scanning, size measurements?
So it will be done. These are just the preliminary studies.
Okay.
For size, actually, yes, TEM is used for size, and DLS, dynamic light scattering technique.
You yourself can use it for on some specific applications of so many you have suggested, and try to use somewhere applications and can tell people I prepared this by this method and it works for this material.
Yes, sir.
Application. Yeah.
Yes, sir. Thank you, sir. Actually, due to the lack of facilities at my host institute, I need to go to other institutes. So that's why this work is little
That
pending.
is the whole problem in our country.
Right,
no
absolutely.
No facilities.
Right.
No funds,
Yeah. And it's challenging
So-
actually to work at other institutes. People are sometimes not so cooperative because in research, you need to go again and again and repeat the experiments.
That's everywhere here in our country. No cooperative
I hope it will
collaborative.
get better with time, these things.
Yeah, maybe your generations can work for it. We are tired. And retired, yes. Okay, good presentation. Thank you.
Thank you so much, sir. Thank
No other question. We thank all the speakers. The thing I like most, everybody finished in time, and everybody has some work which is very important. With the theme of the conference this college has organized, international meeting. We have, I don't know whether you heard the other speakers, the best speakers you could get yesterday and today, and it has a given a good canvas of the problems, while development, the one part people forget the development, and the development brings the problem, and so we want sustainable development. So it's a good combination of industry, academia, and given a good platform for you all to think that what work you have done, you also look into what others have said, and whether you can intercollaborate this or picking into the applications. And so that's how you can go for applied work. See, I started with inorganic chemistry, salts and spectra and everything. Then I did my separation science with the neutron activation analysis, solvent extraction. And all that was applied to environmental science. And today people say I'm environmental chemist, So this is how all areas that when you blend together, you really try to make an approach to a problem of varied nature. And then all boundaries of science gets lost, and then you are into the problem. Not saying this organic pollutant, inorganic pollutant, heavy metals and gases pollutions and air pollutions, all that kind of, when you have interrelations and collaborative work or interdisciplinary work through your own work approach, So jump into those areas and try to get those materials, work it out, So basically all sciences will merge here, because nature will not, and the industries will not tell you this is this problem, that problem, that problem. Ultimately, you say air pollution, that everything, organic or inorganic, or it's biological waste, then it is the river bodies as the main concern, main problem. Is everything together, because we think basically rivers in Indian Peninsula as they are carriers of industrial and city waste, and they have forgotten that what characters of the rivers that they have lost. Ambient air also has lost its characteristics, and stinks and contaminations you are not able to. So there are many challenges, and collectively, if you look at these all presentations, each one has shown that there is a challenge, and you just heard before your presentations the plastic waste, municipal solid waste, industrial effluents. Now, when you see the problem, it is a monster, But then you'll have to go for inventory of the problem, From where it comes, who are the polluter, who does it, what are the materials they make. So the whole inventory will make you understand anything that comes to river or estuaries or goes to the atmosphere, air. From the inventory, we'll know who are the culprits. Rather, if you leave aside culprit, don't be after them, but then at least what is in a public domain that you shall be able to understand, So it's very important. So your method, when you say it is selective, okay, it has good capacity. The selective method, no interference. So you say, yeah, let there be anything. The host of the materials, complex material, but my method is selective. I can apply it, and that is how you have. That's why I always insist that you should go for real samples, So with this, we are really enlightened with your presentation, the young generation. I'm sure that science is heading for something to achieve the sustainable goals, and sustainable development goals, that is everybody's challenge. It's individuals, organized, and governments and the industries. I'm sure. I'm sorry I could not be visible because some problems with the video. From my side, it is open, but I can see there is something like a pin on the video there. So anyway, you heard me. That is good enough, and thank you for your patience. So I hand over to the organizers, Principal and Dr. Sugandha, and with this. This parallel session presentations we conclude. Thank you very much.
Thank you so much, sir, for your valuable remarks. Sir, I would like to take permission. There are some questions on the chat box for the Monica ma'am. So I would like to ask.
Okay.
So someone have asked in which solvent the nanoparticles are dissolved. For the
So Mamta, your question, please answer them. Sorry, I concluded before that. I was telling you there are many questions you could see in chat box. If you're interested, when time permits, we can go for the discussion.
So actually these nanoparticles are colloidal suspensions, and if these are hydrophilic nanoparticles, then hydrophilic nanoparticles will be soluble in water and alcohol.
Thank you, ma'am. Thank you, sir. Sir, on behalf of KJ Somaiya College, I would like to give the formal vote of thanks to you and also all the participants who have participated in the presentation. It will be the beneficial for us in the work. I'm grateful to the organizing team, all the teachers, HOD, and the principal of KJ Somaiya College. Finally, I would like to thank all the participants. Thank you so much. The panel discussion will start at 2 o'clock.
Well, you can start the panel discussion if the session is concluded.
I welcome Mr. Nitesh Mehta, Dr. Sangeeta Srivastav, Mr. Mahesh Chandra for the panel discussion, and our moderator, Dr. P.A. Hassan. Welcome, sir. So we are waiting for Dr. Menon to join. Dr. Kharkar.
Good afternoon.
Yeah, good afternoon.
I'm on. Are you able to hear me?
Oh, Dr. Menon, you're here?
I'm here, I'm there.
We didn't see you in the participant list. Fine. Welcome, sir. And Dr. Kharkar also. We'll wait for Dr. Kharkar.
Sure.
Is there? Oh, Professor Kharkar, are you also there?
No.
Name.
I think I am not visible. Dr. Hassan, it seems to be joining. Yeah.
Hello.
Dr. Hassan, you are joining.
Yeah.
Good.
Hello. Yeah, I am here.
Okay.
Welcome, sir. So Dr. Hassan is the moderator for this panel discussion, and we have Dr. Sangeeta also from Godavari Biorefineries Limited, Dr. Mahesh Chandra from Bayer India, Dr. Ashok Menon from SABI, and Mr. Nitesh Mehta, Eureka. So I hand over the session to Dr. Hassan now, who is the moderator for this panel discussion. Welcome, one and all.
Yeah. Good afternoon, madam, and all panelists, respected panelists. Am I audible to all of you?
Yes, you are audible.
Yeah, thank you very much. Indeed, it is. I'm very happy to act as moderator for this session when we have these esteemed participants like many of them from academia as well as from industry, who has been doing a great job in terms of attaining our sustainable development goals as dictated by the United Nations initiative. So as you all know, we have had a wonderful session dealing with the various aspects of this initiative in the area of sustainable development in the country. So let us begin the discussion with our panelists. Let us hear from the panelists their opinions as well as their views about sustainable development in the country. I would like to start with our esteemed guest, Sri Professor Mahesh Chandak, Dr. Mahesh Chandak, who is the head of HSC South Asia and HSC Business Partner for Crop Science Division, Asia Pacific Sustainability, Safety, Health and Environment, and HSC Bayer. So as you all know, the perspective about the industry in India is something like, okay, we do make a lot of initiatives or new products or innovations to meet or increase the quality of life of the human beings. At the same time, we also need to take appropriate precautions in the same so that it does not or it will cause only minimum damage to the environment, and the solutions what we derive should be sustainable for the future generations to come. So I would like to hear from Dr. Mahesh. So in the industry at an organization level, how much do you see the sustainability initiatives being driven at various levels in the industry, and what initiative have been taken in the industry where you are actually serving or we are actually involved in to meet the sustainable development goals as dictated by the United Nations? So Dr. Mahesh, can you please elaborate on this?
Thank you, Professor Hassan. Hope everybody can hear me well. And before I begin, I would just like to have a quick check. So for this first round of question, how many minutes can I get to answer this one?
Yeah, you can take about 4 to 5 minutes.
Perfect. I don't want to, I want to give time to all the other esteemed panelists. Just wanted to reconfirm that. Okay, so I will stick to that one. So first of all, thanks Professor Sugandha and Sumaya College for this opportunity. When I heard that we are going to talk of chemistry or and also sustainability, I was very enthused about it, first of all, because that was my driving force to enter this field several years ago. So I did my chemical engineering in 1992 from IIT Bombay. I worked in NOSIL at that time, a petrochemical complex, for 2 years. And that was a time, India was opening up as an economy. And somewhere I felt, as a chemical engineer, how can I contribute? And I felt that there might be some scope for chemical engineer specifically to support air, because that time we did not know the word sustainability. I felt as a chemical engineer, I can help in air emissions control, wastewater treatment, water conservation. And with that naive thought, I went to US for my master's to University of Cincinnati, and then came back, and I have been in consulting world since then. I think the field has come a long way. And in this 25 years, I think the first 5 to 10 years, I did not see much movement of, in the field of sustainability. Yes, some laws were formed, but the implementation was poor. The industry was clearly divided between multinationals who were doing what had to be done, and Indian companies who really were struggling to just do the compliance. But since then, I think Indian industry has come a long way. India is now one of the big suppliers to the global world in many sectors, whether it is pharmaceuticals, agrochemicals, and Indian chemical sector has really grown in size, has really grown in complexity. And in the coming to the field of sustainability, I have seen them go from pure compliance focus to now a commitment focus, right? The management of progressive Indian chemical companies have a commitment to be sustainable. Because they are the important part of the supply chain of various sectors, and because of that, and the supply chain, contributing 70 to 80% of the greenhouse gas emission. This sector is naturally, there is a lot of scrutiny from the customers. There is a lot of scrutiny from the investors also, in terms of how green, the manufacturing is. And I'm happy to share, as I speak, there are several important deals happening in our sector where private equity firms, large global private equity firms, are acquiring, Indian chemical manufacturers, because they see the value, and they also see that these companies are going to, meet the sustainability norms or net zero norms that are being committed to by not just companies but also countries. So the industry has come a long way. Every chemical company eventually is part of a value chain and supplies to a big brand, and these big brands are ensuring, and along with this supply chain, are ensuring that the whole entire end-to-end process is such that it is reducing the GHG emissions and also creating a sustainability impact. That is what I feel about the industry. And I just want to maybe share one slide, which will kind of, I don't know if I can share. I will give it a try. Otherwise, the organizer can give me the access. I hope you can see. Yeah, thanks, Nitesh, for the heads up. So this is just, one slide I would like to show from our sustainability report of 2021, which lays our vision and also purpose. So our vision is health for all, hunger for none, because we are in pharmaceuticals, we are in crop science, we are aligning with several of the SDGs. And when it comes to our sustainability commitment, on the right, you can see some of our climate goals, decarbonization goals. So we want to achieve climate neutrality. We want to reduce emissions in the supply chain, which is scope 3. We want to be net zero by 2050, including scope 1, 2, and 3. And also in the seeds that we produce, like rice, for example, we want to achieve 30% reduction in the main geographies that we operate. And this is a big task because this involves hundreds and thousands of smallholder farmers, in Asia Pacific and other parts of the world, which is not easy. You can see the other commitments also on the bottom right for our other divisions. And on the left, you can see the impact. So we need to support smallholder farmers in terms of 100 million smallholder farmers in low and medium income countries to ensure food security, and also access to health and so on. Now, all of this, I think, has a role for a chemical engineer or chemistry to make it happen, to make it, to enable the technology and so on. So I'm very enthused about this, and this is not just my company. I think many companies are having very similar robust commitments. And what we see, at least my perspective in the last couple of years, this commitment that is there in the mind is now showing in actions. It is happening in the plants, it is happening in the supply chain, and there are many, many examples. I'm sure my fellow panelists will also elaborate on that. With that, I will stop and hand it over to you, Professor. So, thank you.
Thank you very much, Dr. Mahesh, for highlighting the initiatives in your company with respect to meeting the sustainability goals. Now, let me come back with our another expert in the area from an academy, Professor P.S. Karkar. Professor Prashant Karkar is in the university, the Institute of Chemical Technology. He's a professor in medicinal chemistry and has been working with various industries, as consultancy, as consultant, as well as he is a registered patent agent, and he has a lot of association with the management in the schools like pharmacy and technology management in NMIMS. And he has a diverse expertise in the area of medicinal chemistry. And I would like to know from Professor Karkar that, do you know, having an interaction with ICT, we all know that actually this is the hub for transforming the academic knowledge into various innovations and technologies. And I don't find actually a better person to talk about the academia industry interaction. So I would like to know, what do you think the industry academia partnership can accelerate in moving towards the sustainable development goals to identify, to meet our objectives? Where do you see the interaction that is happening right now from various academy and industry association, as well as what are the bottlenecks you face in achieving these goals? Professor Karkar, please.
Thank you so much, Dr. Hassan, for kind introduction and introducing me as well. And of course, I have a lot to say. I have seen best of both the worlds. I spent almost half of my professional career so far has been with various drug discovery companies, Indian companies, as well as multinational companies, foreign multinationals. So it has been a great experience so far, and it's almost like 9 to 10 years that I have been associated in the academia, almost 10 years actually. And then right now also I'm associated with various companies for the drug discovery, and one of the major ones is Godavari Biorefineries Limited. It's almost 9 years I'm associated with them. So so far, like I said, I've seen best of both the worlds. And when I come from the drug discovery world, and that to the medicinal chemistry part, there is a lot to say. And of course, Dr. Hassan mentioned about ICT, and ICT being the hub of various chemical technologies which have been introduced. And of course, a lot of other who's who from ICT, like Professor Yadav, Professor Bhange, they have already spoken, or they will be speaking in this conference. So I will not really talk about from the chemistry part of it. I'll focus on the medicinal chemistry part of it. I have a small presentation. I hope I'll be able to finish in like next 5 to 7 minutes. I'll just share the presentation. Is it visible?
Yes, yes, please.
Yes.
Okay, perfect. So, okay. So the title is Sustainability and Drug Discovery, My Efforts as a Medicinal Chemist.
Not in a PPT mode in case you want.
Okay.
It's visible. We can. Oh, yeah, it's better.
Yeah. Please let me know if the slides are changing, because many times we face that problem. Is it changing?
Yes, it is changing.
Okay, perfect. So acknowledgements to organizers of the conference and the invitation. Now, coming to pharmaceuticals and the ecosystem, pharmaceuticals being very, very important chemicals. When I say chemicals, I'm talking about the small molecule drugs. Of course, the biologics are also chemicals, but since majority of the drugs which we use today are small molecule drugs, whose molecular weight is like less than 1,000 Daltons or so. So my focus is on those synthetic drugs. Of course, there are many others from the natural or semi-synthetic origin, but I'm going to talk about small molecule drugs. So these chemicals, like we all know the good side of the chemicals, bad side of the chemicals, and we cannot really imagine a world free of chemicals. Otherwise, we'll have to go to the Stone Age to imagine that. But coming to pharmaceuticals, the pharmaceuticals now as such, when it comes to sustainability, pharmaceutical industry just waking up, and I'm just going to explain that in next few slides. So when it comes to pharmaceuticals, the pharmaceuticals ultimately after their use is over, the human use or even the veterinary use. So ultimately these pharmaceuticals, they end up in the ecosystem, that is in the soil as well as the water bodies, where they go on kind of damaging the aquatic animals, and then all the other parts of the ecosystem, not just the drugs which unchanged drugs, their metabolites, their degradation products, eventually they end up in the ecosystem, and the damage is done. And like I said, the pharmaceutical industry just waking up. There have been consistent efforts as far as the damage done by the pharmaceuticals. Now, I'm not even talking about the manufacturing side, although that contributes a lot. And when a new drug is discovered, there are very few companies who would have this environmental impact of the drug which is being synthesized, including the synthetic route. There are very few companies which will have this thing in mind. Otherwise, traditionally, if you look at drugs, there are many drugs which are really damaging to the environment. And after they end up in the environment, they do cause a lot of damage, including feminization of fish. The vultures, they have disappeared, and then the aquatic animals, after all, they get affected, and then it comes back to us, that is the humans. Now, I would want to show you this very interesting news cutting. It's very new, less than a month old, which appeared in an issue of Sunday, 27th March 2022, in one of the magazines. So it says drug debacle, diclofenac was not the last threat for India's vultures. So I'm sure those who are aware, a large proportion of vultures, large population of vultures, they disappeared, and finally it was blamed to one of the drugs, diclofenac, which is actually an NSAID, non-steroidal anti-inflammatory drug, which is used in humans, but then it is also used by quacks for veterinary purpose. And then when the animals who have been treated with diclofenac, they die, and then their carcasses are left in the open. And when these vultures eat, within few hours, these vultures die. And then there is also, there are many reasons of vulture disappearance, and DDT, which is a very powerful insecticide, which has been banned in most of the parts of the world, but then in India, we still use it. So that is another reason why these vultures have disappeared. So with this, the diclofenac was banned back in 2006. But then finally, we also concluded that three drugs, aceclofenac, pitoprofen, and nimesulide, they were introduced as alternative to diclofenac back in 2006. And these are the three drugs responsible for disappearance of vultures. The major reason being, the use of these three drugs in the veterinary practice. In fact, nimesulide is a drug which is banned in most of the parts of the world, but in India, we still use it. So again, I don't want to touch that part of ethics and others, but then ultimately it is the pharmaceuticals which are used in human practice, and they are causing a real problem. They're causing a real problem to the ecosystem, and the ecosystem is getting disturbed. So coming to the next part, now I just want to highlight, there are two or three slides more. I just want to highlight, like I said, pharmaceutical industry was never so very worried about the ecosystem and the environment. Now, I'm not talking about the API industry, or once the drug becomes generic and then it is synthesized by many companies. I'm talking about the drugs which are like new drugs which are synthesized by the company which invents it. And then eventually when the drug comes to the market, hardly there is any company who would give this very thought behind the environmental damage done by the API. Right, so that's why this question, is it really serious? Although the picture is changing, and there have been many conscious efforts by which the damaging effects of the drugs and their intermediates are being, a thorough thought is being given, and then right in the drug discovery phase, the selection is being done by taking into consideration the environmental impact of many of these drugs. I don't know, something happened, but
yeah.
I'll finish in next 2 minutes.
Perfect, no problem. I thought
okay.
I think
perfect. So it came out somehow. Okay, so when it comes to pharmaceuticals and small molecule drugs, everything revolves around the drug structure. So it is this drug structure which is responsible for the pharmacological activity. It is the same structure which is also responsible for, I'll just speak, otherwise this is okay. It is the same drug structure which is responsible for the toxicity in humans as well as to the when it goes in the environment. So ecological toxicity is also in a way responsible. I mean, the drug structure is responsible for that. And then when it comes to, like I said, the current medicine cost, like every drug requires around $4 billion for its development. And this cost does not include the environmental burden of discovery, development, and commercialization. Nobody gives a thorough thought. But again, like I said, people have, these companies are coming to their senses. So ultimately, this environmental cost is inevitably passed on the shoulders of the future generation if we do not include sustainability concepts in the early drug discovery phase. And this is exactly what I would want to point out. Right from the drug discovery phase, unless we give a thorough thought as to what drugs, what structures to make, and what is the environmental impact going to be, we are not, we are really making it difficult for the future generation. In fact, the European Commission believes that the environmental concerns should become part of medical training and professional development program, right? When the students are being trained as medicinal chemists, students are being trained as toxicologists and all those things. So that is the main thing. So that's where this so-called concept of benign by design is coming into picture. Although this is most of what I'm going to talk about in this particular slide is basically related to green chemistry principles, 12 principles of green chemistry. So the first one is benign by design, wherein you come up with drug structures or structures of molecules which ultimately will become drug, that they will be environmentally benign, meaning they'll be degraded to innocuous products eventually in the when they are exposed to the environment. The emphasis and other important thing is now the emphasis is being given on preventive medicines rather than treatment options. So if there is no disease, if you have got preventive medicine, basically then you don't really have to worry too much about the treatment. And most of what we have available, most of the drugs, they are actually for treatment and not for the prevention. Very few drugs are for the prevention. And then of course, if you look at, there is another concept of lean discovery, meaning if you look at drug discovery, traditionally it takes around 10 to 12 years to discover a new drug. So we have to come up with optimum use of resources just so the drug is discovered very fast, and in record time, because ultimately the environmental cost will be reduced in a way. Now coming to academic sustainability, this is known all over the world that the real research happens in the academic labs. Now there should be efforts, and of course the government is also promoting in India the academic research should be ultimately culminated into some interesting, it should be commercialized. And this is exactly what the motto is. People are doing quality academic research. Now it is the sarcastic remark that it is academic research. The scenario has changed, or in a way it is changing. So the industry is looking forward to academia for quality inputs from the research so that it can be taken to the next level. And that also includes newer ways of doing chemical reactions. For example, solventless reaction, mechanochemistry, then ultrasonic wave assisted chemistry or photo assisted chemistry, and many different alternative versions are coming compared to what the conventional solution or solvent based chemistry. Then there have been also use of various predictive tools. So in typical drug discovery, before we synthesize the drug, we usually use this computational tools. So instead, if I have 1,000 choices to make, I probably use these predictive tools and make only maybe 10 or 15, and my success rate of course will still be very high, because if I make say 100 molecules out of these 1,000 molecules, I will get maybe 2 molecules. But with the help of computational tools, if I make only 10 molecules, the time and cost, and of course the environmental impact, because I won't spend time and money to really make those additional 85 molecules. So that way my environmental impact or sustainability concept also can be practiced. And of course the cost advantage, so whatever cost goes on for discovering the medicines, that is ultimately passed on to the consumer, and that's exactly the main thing. So if you are likely to come out with the cheaper drugs, then meaning drugs discovered fast, then of course they're likely to be cheaper. So as far as my part is concerned, I have been focusing on natural products and phytochemicals as far as the starting point for the drug discovery. And because these are natural products and coming from the natural origin, so the nature knows how to degrade them. And this is exactly what the motto of my research is. So I'm doing a typical medicinal chemistry research where most of my focus is on the natural products and phytochemicals. So benign by design is what I'm practicing. Then wherever possible, I'm trying to avoid environmentally hazardous groups designed in the molecular structure, say something like nitro group, because these groups are likely to be hazardous to the environment, and they are likely to also hazardous to the human health. So overall, just to summarize, what I would say is there have been many tools, like there have been utility or use of many tools like artificial intelligence, machine learning, and these various computational tools to make drug design and discovery more efficient. And of course, it directly translates to the so-called environmental impact, meaning you are trying to make less molecules and coming up with cost-effective medicines and in record time. And this is exactly what I would say. The pharmaceutical industry has largely been ignorant on the sustainability aspects of and the environmental damage aspects, but then things are changing. Of course, they will have to change eventually. And as an academician, it is my duty and responsibility to train the future generation to think in that sense, which is need of the hour. And with this, I'll just stop.
Okay, thank you, Professor Prashant, for bringing your views and also highlighting the initiatives especially in academic institutes, especially in pharmaceutical chemistry, how we can contribute towards the sustainable development goals. Now, I will come back to each of the panelists later if time permits. So let me go back with one of our luminary in the industry, Dr. Ashok Menon, who is the Director of Sustainability Strategy at Asia Pacific region for the SABIC Technology Center. And he is currently playing a critical role in SABIC's carbon neutrality strategy, climate roadmap, etc. And he's a leader and the thought leader in this area of sustainable development goals. So having his expertise in the chemical industry, which is playing a crucial role in developing innovative products with a view to have this sustainability, this thing. So I would like to hear from Dr. Menon about what challenges do you see in driving sustainability initiatives across all levels in the entire organization, because you are leading at a higher lead position in an organization where sustainability is very crucial, especially in plastics and polymer industry. So I would like to hear from you, what are the challenges you face in driving the sustainability across all ladders, as well as how do you connect this information with the society? That is very important. Actually, we need to actually make the society aware. So this is what we are doing to make these changes. So I would like to hear from Dr. Menon about these aspects. Dr. Menon, please.
Sure. Thank you. Thank you very much. Am I audible?
Yes, yes.
Okay, great. Again, thanks a lot, Dr. Hasan, for this kind introduction as well as the kind question. But before that, I would like to thank the management of KJ Somaiya College, especially Dr. Sugandha and the entire organizing committee for inviting us. I would also like to compliment for the wonderful sessions that this entire team has put together, especially coinciding with the Earth Day, which was celebrated yesterday. And then it's a great gesture to kind of share this knowledge with the rest of the audience around the importance of the Earth Day, the importance of various aspects like climate, which is a pressing issue today. So coming back to SABIC, for those who don't know, SABIC is a globally diversified chemical companies. We make polymers, we make chemicals, we make metals, we make agri-nutrients as such, and our footprint is spread across the globe. Our headquarters is in Saudi Arabia, and in India we have a very strong research and development center and a few manufacturing setups as well as such. So from the sustainability point of view, right from the beginning, how do we establish our priorities when it comes to sustainability is something that each of the companies actually start with. So for example, there is a process called, I'd like to introduce two processes, like a process called materiality, which actually helps us to identify from our key stakeholders, both internal stakeholders as well as external stakeholders, what's important to us. And that's what actually builds down to our primary priorities. For example, based upon this exercise, SABIC has identified around 6 key priorities that we need to work on from sustainability, which is definitely similar to many other companies. But we talk about resource efficiency, climate change and energy, environmental health and safety, innovation and sustainability solutions, circular economy, and also governance and integrity as such. And these 6 strategies, typically what we do is get converted into our pillars for sustainability, which we could call it as the climate change, circular economy, safer chemistry, and also ESG disclosures primary as such. And these are all founded on sustainability development goals as such. So for the students who are not aware, the sustainable development goals were set up as global goals by United Nations in 2015, primarily to kind of look at ending poverty, protecting the planet, and ensuring that by 2020, all the people enjoy peace and prosperity. And these 17 SDGs, what we call as 169 targets and 232 indicators. And just for additional knowledge, I think India has taken a lead here by working with United Nations to kind of set up a matrix to calculate the SDG score for each of the states in India. And each of the states every year are ranked based upon our SDG scores and looked at it. For students who are interested, it could be, you can take it as a quiz to kind of go back and look at which states are doing well and which are not. As such, but this, I thought, an important information to kind of start with. Now, coming back to the challenges coming from a plastic industry as such, we all know that plastic is a miracle material. But having said that, the biggest challenge we say is the pollution created by plastics as such. And as a responsible chemical industry, how do we kind of look at addressing these, not just from the industry point of view, but also from the society point of view as such. So for this reason, what SABIC has onboarded is a program, what we call as a True Circle program. And this True Circle program is primarily looking at how are we going to look at incorporating design for circularity in our products when we kind of make a product as such. How can we kind of drive more initiatives like mechanical recycling, chemical recycling, or even addressing the climate of looking at bio-based feedstock. So as you all know, when we make chemicals, the heart of our industry is the chemical cracker, which takes in either gas or naphtha, converts it into the primary building blocks. From there, you make chemicals, polymers, and commodity and specialty materials, which goes into applications ranging from aviation, healthcare, and even commodity applications, packaging as such. And many of this, at the end of the life, you actually get incinerated or they leak into the environment. So the program that we have looked at is how do we look at collecting, partnering with other groups, of course, and collecting this mixed plastic waste and either using them, converting them into incorporating mechanical recycling concepts and getting it back into the value chain for the converters to reuse it, or take mixed plastic waste, pyrolyze them into pyrolysis oil. The composition of this pyrolysis oil would be pretty similar to the feedstock that goes into the cracker, and we incorporate it back into the cracker to make a virgin material. Similarly, there are quite a few waste generated, let's say, by paper and pulp industry, or let's say used cooking, using used cooking oil as such. How do we convert those into a feedstock that can go again back into our crackers to make polymers, or rather what we call as renewable polymers, because these are coming from materials which have sequestrated carbon dioxide into it. And when you start developing making products from these, you are able to kind of reduce the carbon footprint significantly in order to get these products. So these are some of the solutions that we are kind of looking at to address the major challenges. And again, with the regulation is a huge challenge, which is day by day increasing. And if you look at many of the ESG disclosures, like even if you have looked at COP26, which was concluded in December last year, they are coming up with an international sustainability standard board, which is looking at new frameworks for organizations to come up with their disclosures. And it's not just about disclosure, but the initiative that you are taking in order to read this disclosure. For example, what are we doing for recycling? The examples that I gave within our True Circle portfolio actually drive this. SABIC has also announced carbon neutrality. We have said that by 2050, we will become carbon neutral as such. And again, we have also set interim targets of 20% reduction by 2030. And now to onboard these, to reach carbon neutrality, we need to look at programs which are kind of out of the box to really meet this requirement. So, for example, resource efficiency is something which is a very low-hanging fruit, which we are always looking at. But how do we kind of onboard renewable energy? As I said, cracker is the heart of our chemical processing. And if I am able to make my cracker electrical, as such, I'm able to reduce 90% of my emissions straight away. And that's something which we are doing in collaboration with BASF and Linde to kind of electrify our cracker, and so that we can run it on renewable energy. The other important attribute that we have also onboarded is in order to prevent carbon dioxide from polluting the environment, can I capture this carbon dioxide and convert them into useful products? We already have established a plant which is converting this carbon dioxide, converting them into methanol, urea for fertilizers. And there are many other programs that is in place in order to kind of ensure this carbon dioxide emissions can be minimized or made it into useful. We are also looking at hydrogen economy, looking at how hydrogen can be used as an energy to kind of make this. But these are all challenges. The technology is in its infancy, and we are working closely with different partners to see how we can onboard this and reach our 2030 and 2050 targets of becoming carbon neutral. The third bigger challenge is when it comes to what we call as scope 3 emissions. Mainly everything what we talked about right now is scope 1, scope 2, what we emit or what we emit because of the electricity consumed, but there is emission that happens because of the upstream, where we are getting products from, getting raw materials from external parties, or the products that I'm introducing into the market that would be causing emissions, and this would come into outside our boundary scope 3. How do we kind of ensure even the scope 3 emissions are controlled by ensuring that our products' carbon footprints are reduced tremendously as such in a systematic fashion. And these also developing products which can not just reduce the emissions in our industry, but also reducing emissions in other industry. Polymers, for example, are known for lightweighting, and automotive industry, especially electrical vehicles, which is becoming mandatory going forward, would benefit a lot from these materials as well. So how do we kind of bring that into execution? So these are some of the attributes that we are looking at, the challenges and the solutions that we are bringing. And it's a journey where we are collaborating with a lot of value chain partners to kind of help us achieve our goals, as well as help meet the SDG goals as such. Thanks a lot.
Okay. Thank you, Dr. Menon, for an exciting overview of actually your initiatives in your company's initiatives towards meeting this goal, and the chain in which through your organizational structure is working for attaining the sustainability. I think I will get back to you later. So let us have our next, I will say, the thought leader or a key person in this discussion forum, Mr. Nitesh Mehta. So I must say that actually he has a diverse expertise. I consider him as actually a joint this thing between industry as well as an academia. And Nidesh is a co-founder and director of the Green Chemistry Foundation in Mumbai. And as the name suggests, you can't find a person better than him to discuss about the sustainability in this discussion forum. And Nidesh he has a diverse expertise in the area of process development, scale up and technology implementation. He did his masters from IIT Bombay. And I will not go into the detail. He is also a co-founder and director of NURECA Green Synthetic Technologies. He is in the advisory board of International Sustainable Chemistry Collaborative Center and many more. I think I have many questions to ask to you, sir, because I find you have a lion's share to speak in this forum. So let me just give you a couple of thoughts. What role do you see in academia can play to contribute to these goals, and what industry can do to take partnership and collaborate with academia? And since you are also in the advisory council of various international forums, I would like to hear from you, where do we stand in India in terms of the international standard, that is the, let us say, the SDG index or whatever. So can you comment about our initiative in India and what way we can actually improve? Our objective is to, by 2030, we should actually make a demonstrable output or a footprint in international level. So can you please give your comments about how we can achieve these objectives? Nidesh, please.
Thank you, Dr. Hassan. Can you hear me well?
Yep, right.
Okay, great. So thank you once again to the entire Somaiya team. It's been, more than, I think about 10 to 15 years that I've been seeing all kinds of initiatives on various fronts by Somaiya as a group, whether it is on the industry front or at the academia front. So thank you to the entire team, right from top management to Dr. Sugandha, who took actually the initiative to put this program together. Before I come to the question, just a quick, I'll just share a few slides to give an introduction of what exactly is the kind of work that we are doing, so you are able to relate to and the kind of opportunities that we see for chemists and chemical engineers. Can you see the slides well? Okay, great, thank you. So just to quickly introduce, so while, as you see, green and sustainable chemistry overall contributes to a whole bunch of SDG goals, directly or indirectly. So I could clearly see about 9 to 10 out of these 17 SDGs where sustainable and green chemistry makes or can make some or the other kind of impact. Our expressions to contributing to SDGs is on two fronts. One is a for-profit organization that we have called NURECA, where a team of about 80 of us, 30 chemists and chemical engineers are together, trying to bridge this gap between academia and industry and trying to see if some of the potential green and sustainable chemistry technologies that academia has created, if it can be kind of taken to the marketplace and implemented in the industry. So as of right now, there in NURECA, we have a couple of focuses. One is on safer and greener unit processes. So as a chemical industry, being a chemical manufacturing hub for the world, Indian chemical industry uses a whole bunch of unit processes which are still being done in a conventional manner, and green chemistry alternatives do not exist for that. So we're trying to see if in collaboration with academia, some of these unit processes can be done in a more greener and sustainable manner, more safer manner, and getting those processes to the marketplace. Two, we have a lot of focus on one of our technologies called Recycle at Source, where we try and work on various kinds of acidic and alkaline effluent streams that come from various chemical processes and how they can be reused back into the same processes. And that's the reason calling it recycle at source. So you don't need to take it to the wastewater treatment plants and increase the load on the environment. But if there is some way it could be recycled back, both on one side you reduce the load on the environment, and on the other side you reduce the freshwater consumption in those processes. Another area that we have are some collaborative projects with some other entrepreneurs is around recovery of various kinds of chemicals, both salts as well as organics, that are present in various kinds of waste streams. So this is a very recent initiative, last 2 years, that we've got into. So again, trying to make an attempt that some of these salts or organics, if it's a byproduct, if there is some way that it could be brought back into the value chain rather than letting it out there into the environment in the form of a COD or high TDS. So that's the focus. So these are some of the areas in NURECA that we are working on. The second expression that we have is a non-profit organization called Green Chemistry Foundation, where we are trying to get all stakeholders, be it academia, be it government bodies, regulatory bodies like Pollution Control Board, Department of Chemicals and Petrochemicals, students, sustainability experts across the globe, trying to get everyone together on one platform and organizing various kinds of events, conferences, exhibitions, so that a lot of environmental solution providers who are sitting with some kind of innovations could be connected to the industry, and such environmental solutions can get implemented in the industry at a much more faster pace, as at an accelerated pace. So that's the initiative at Green Chemistry Foundation. What I wanted to quickly point out was, that we see a lot of opportunities for chemists, chemical engineers, and this includes both industry as well as academia. That each industry sector has its own sets of environmental issues. And you would see some academic or research institutes or some sets of professors focused on a certain industry sectors and trying to solve all the various kinds of problems associated with that. The second big opportunity is there are a lot of these high volume products and high E-factor products. What I mean by high E-factor products means a set of products which generate huge quantity of effluent per kg of the product. So there are a lot of such, like if you look at dye stuff intermediates, you will see H-acid as a very large volume product, and it generates also 30-40 liters of waste per kg of the product that comes out. Similarly, in pharma, you would see a whole bunch of products which are like multi-ton or hundreds of tons per month kind of volumes, and they have huge environmental challenges. So each of those products is an opportunity for a chemist, chemical engineer to come out with some kind of solutions and solve those environmental challenges. There are a lot of chemistries like sulfonations, nitrations, halogenations, diazotizations, which are still being done with conventional processes which are inherently quite polluting. And each of these chemistries is actually an opportunity for academicians to develop greener alternative technologies or some kind of a catalyst, which would make these chemistries or chemical processes inherently safer as well as environment friendly. Then you have a lot of products which generate different kinds of solid, liquid, or gaseous effluents. Each of those effluent stream is actually an opportunity for academics or for the industry to work on in a very focused manner and come out with some solutions. So if you will see that there is a whole bunch of problems out there which are actually an opportunity for chemists and chemical engineers to work on. So with that background, I'm going to come back to the questions, specific questions that you posed, Dr. Hasan. One, in terms of the industry academia collaboration, I see that both the industry and academia are kind of two very critical pieces of the puzzle, which one cannot do what the other does. And that's where the strengths are very complementary. That's what I personally believe. If you see academic setup, both in the entire ecosystem is designed in a way that you are constantly thinking from the very basics and fundamentals. Like on the other side, if you see industry, which is wants to or sees an environmental challenge and it wants to address that environmental challenge. Which looks as at a very superficial level, not superficial in the terms of that industry doesn't go deep into it, but there is a challenge that appears on the front, which is what the industry wants to solve, and then there is actually a deep down issue which like a chemical challenge or at a molecular level something needs to be dealt with, and that is what the academic and research people are good at, and only if that gets solved would this problem which manifests at the superficial level would get solved. The second big advantage I see that the academic setup has is the kind of infrastructure that you are sitting with, the kind of very expensive and high-end equipments, whether it is on the analytical front or on the experimental front, which not all chemical industries, especially the MSMEs, can afford. Right. So with that kind of a setup, you are actually sitting on a massive strength. The third is the big strength that academics sits on is the power that's available of the young and dynamic students, and which is that inquisitiveness. Because they come from a certain clean slate as compared to we in the industry who have got a fixed set of experience sometimes comes on the way in terms of what can be done and what cannot be done. And so that way the students are quite clean in terms of their background or in terms of their kind of canvas. And they could actually think slightly more out of the box as compared to sometimes that we can in the industry. And they could question certain things which the way it has not been questioned by the industry, which I believe is a very powerful thing. The fourth is the capability for experimentation. Sometimes as industry, we have limitations in terms of we are dealing with certain time frames, we are dealing with certain troubleshooting priorities, that there is a, consignment that has got rejected by the customer that needs to be addressed, quality needs to be addressed. There is a plant batch where, either quality specification or something is not appropriate, or the raw material quality that has come is not okay. And there is troubleshooting or a whole bunch of troubleshooting issues that we need to take care. And most of the times the process development and the R&D labs are tied up with that. While what happens in case of, that's where sometimes then these problems which needs some very fundamental thinking and addressing certain issues at a very core or a molecular level, those R&D work normally gets kind of lower priority. And that's where the academic and research institutes again could be a powerful tool for the industry, because you have a very clear focus. You are not getting distracted by the day-to-day troubleshooting stuff, and you've got a clear focus and a problem to be solved at a molecular level. So that's another big advantage, and that's where I feel that this is a very, I would say, two complementary strengths actually coming together and making an attempt to see how some of the cultural issues that usually come on the way of academic and industry getting collaborated or collaborating with each other. Some of those cultural and other issues, if those things could be resolved, I think it could be a very powerful tool. Another big area I believe that academicians can contribute, or academia can contribute, is MSMEs, who really don't have the infrastructure and the team or they even some of them don't even have their own R&D setup. That is one big place where academic and research institutes could handhold small and medium-sized companies, help them solve their problems. I remember a couple of years back, we had a bunch of small and medium-sized companies who formed a group together inside one of the industrial associations. I think it was Specialty Chemical Manufacturers Association. And they came down to meet a bunch of professors at IIT Bombay and see how the set of challenges that they are facing as MSMEs, if there is some way that IIT Bombay professors could solve. So I think that kind of interaction, that kind of, I really don't know what really happened after that and whether something fruitful came out of that collaboration, or whether really the collaboration it happen or not. But the point is that those kind of initiatives, if sustained for a long period of time, would see a lot of transformation happening in terms of these inherently unsafe and hazardous and polluting chemistries that we have currently, for which a greener and safer alternative does not really exist today. That's one big place where academic and research institutes can contribute. Coming to your second question of where India stands in terms of the SDG goals as compared to the world, I really don't have any kind of a metric or number or any kind of a data for that. But one thing definitely I want to add is that compared to the world, for two big reasons, it's much more kind of an intense challenge for us as compared to the other parts of the world. One, for the reason that we've got a massive set of population, which is we are hosting close to 1/6 of the world's population in a relatively smaller piece of land, and which directly corresponds to the limited amount of resources that's available for this 130 crore people that we have. So that's one of the key reasons why we need to save the quality of our air, water, and soil. Because we have a massive amount of population which is dependent on this. We can't allow our industry or any other kind of a setup, or even the common man in the society, go out and have unsustainable practices which would pollute our land, water, and soil resources. The second reason why I believe that it's very critical for us to solve these environmental challenges at a much more higher pace than the world, or why it's very critical for us, is because the world is looking at us as a chemical manufacturing hub, which means a lot of these large volume products across industry or different subsectors of chemical industry are coming to India for getting manufactured. And what comes along with it is proportional quantity of waste that's going to get generated. We are not allowed to export the waste that gets generated along with the product back to those countries. The waste is something that we have to keep in our own country, and that's the reason it's critical for us that we find out safer and environment friendly ways of doing these chemistries or handling these waste effluents, and we need it much more badly than any other part of the world. That's it. Thank you.
Okay. Thank you, Nitesh, for an excellent presentation about discussion about the strength and weaknesses in both academia and industry, and how we can synergize this activity to get much higher returns. And of course, your views about our need for strengthening the sustainability in a country like India as compared to other places for various reasons. So we have with us Dr. Sangeeta Srivastava, who is the Executive Director of Godavari Biorefineries Limited, and she has been associated with the company as managing and directing research activities connected with the renewables feedstock. And before that, she has held the position as Chemical Business Unit Head. And as you all know, she has Masters in Organic Chemistry and again PhD in Chemistry. And she holds several patents, more than 19 patents in her name. And many of them have been, I will say, commercialized through in various, both in India as well as abroad. So she has diverse expertise in industry. So as I will pick it up from what Nitesh has mentioned, MSMEs do play a crucial role in actually meeting our these objectives. So it takes MSMEs are a huge part of, especially in India, our ecosystem comprising our economy and other developments. So I would like to hear from Dr. Sangeeta, how can we ensure that these MSMEs are roped in our initiative towards sustainable development? And what role do you think other multinational companies or large companies can play in strengthening these activities in India? Dr. Sangeeta, please.
Thank you, Dr. Hassan. And Thank you, the organizer, especially Sugandha, for bringing all of us together here for a very appropriate topic discussion. And as the fellow panelists have already explained and covered the vast area of understanding of the sustainability goals and what is important for the current day, and when we have celebrated Earth Day yesterday, 22nd April. So this all becomes so important for us to sit back and see what has been happening. What I would like to bring it on, like maybe make a small presentation to what we do today, and then come back to your question, Dr. Hassan, if that is okay. Okay, Sugandha, can you ask someone to present, because I've already shared my presentation. Can you go to the slide number 1, please? Yeah. Okay, sorry, so next slide. Okay, so can you go to the next slide? Okay. So basically, I just thought of putting these few words, which has already been discussed a lot, as sustainable development goals of what? Why are we talking about this? I think from many years, the words has changed considerably from last 2 decades, especially when the industrial growth has taken place in a large speed. So we are very close to now even ending the poverty. So it is a good thing. It's a positive aspect that we have a lot of farm outputs and other process industry, which is able to do well to ending poverty, near to ending poverty. So we're still far away. And second is the human culture are like such that they have created havoc in the world, which we see it today, what's happening around us. So that something is created by the human, and inequity within and between the countries is growing. So we see the differences, what is happening in and around us, as well as the whole world, Europe, US, all the countries here. And with the expanding influence of technology, governance is getting more difficult. It's so difficult now to even control things, what's happening. And it's also easy to control. So it's a both way. So we can look at the way we are looking. So we are growing faster. We have technologies enhancing our capabilities, but there are challenges to tackle. So if we do not make an urgent and fundamental changes in course of directions, so today's issues will swiftly grow and will become uncontrollable. So this is what I thought of bringing on this table. And the next slide, please. Yeah. So for Godavari, I just would like to explain what we do today in Godavari. So sustainability has been the heart of what we do, or what we have been doing since our inception in 1939. Now word calls it sustainable goal, but we started our business as a principles which reflects, like we always talk about giving back to the society more than what you get from society. In this way, we like striking balance between financial success, environmental stewardship, and the social responsibilities. That's been the core of our company. Next slide. So we call ourselves as a progressive sustainability. These are the words which we have been using in the past. So, sorry. Sorry. Switched on. Yeah. So we have a legacy of progressive sustainability. Our company is built on the belief of our founder, which says, give back to society more than what you receive from it. So while we have grown and prospered, the belief continues. So in the last 80 years, we have been growing, and our guiding principle remains the same, and it is dedicated to the community where we work and live. Next slide, please. So this is what we have. We started in 1939. We're one of the leading manufacturers of sugar, ethanol, organic chemicals, renewable power, and biofertilizer. We can go to the next slide. So just wanted to put across what we do. So this is a slide where I would like to spend a little more time. So when I think my fellow panelists talked about that word is looking at sustainable goals, green carbons, carbon neutrality, and ESG. So to just explain that we start our production actually in the farms. So we produce sugarcane, and the farmers get the sugarcane to our factories, which is converted into sugar. And the waste which comes out of sugar, if you can, is like after we extract sugar. I'm sorry, I'm not able to put my cursor here because it's not my screen. So after extracting sugar, we have molasses as a byproduct, which is converted into ethanol. And we also generate biogas from the spent liquor, which is generated while ethanol fermentation. And this ethanol is used for making all various chemicals, right from acetaldehyde, or we do oxidation to acetaldehyde, acetic acid, and ethyl acetate. And also the waste, other waste which comes out is bagasse, which is a fiber which is from the sugarcane. And we consider this fiber as a valuable source of the next generation materials. We right now generate electricity using this bagasse, but our aim is to generate, we retain the fiber and convert into cellulosic materials, and also convert into 2G ethanol. We also have kind of wax which we extract, and which after extraction of the wax, the rest of the material goes as a biofertilizer. Something which is missing here is, which our panelists spoke about, how do we capture carbon dioxide. So this is the area which we are looking at, and we are trying to collaborate with how do we capture CO2, which comes out during our fermentation and also even our power generation. Can we go to the next slide, please? So just to sum up, like this is the way we look at ourselves. We have still not gone and done the ESG scoring, which is in the process right now, but we generate power. We're talking about power of integration, because right from sugarcane to production to the energy, we are completely integrated backwardly. I just lost the presentation. That's okay. So if you can share, it's fine. Otherwise, that's okay. So we talk about few of the principles of green chemistry which we use is like we use renewable raw materials. So that's the one principle, and we also recycle our streams. Like I think Nitesh was talking about, there are processes where the effluent generation is more than the production. So even ethanol production is one of the such kind of things. But in few years, a lot of work has been done, and we almost recycle 80% of our effluent back to the process for fermentation, and that way it helps us to get the power of integration, we can say. And we have innovative approaches where we have bagasse dryer, which kind of help us energy sustainability. So these are few areas where we look at sustainability as our main focus areas. Can you go to the next slide, please? Yeah. So basically what we talked about just now is like, maybe while the slide is changing, is the same thing which we talked about. We currently are producing almost 400 KLPD ethanol. Now, all of us are aware of Government of India has kind of given a lot of emphasis on biofuel production, which actually helps country for energy saving. And so we are part of that biofuel program. We supply our ethanol to OMCs. Now we are allowed to convert sugarcane syrup, juice, and all the other sugar, like kind of molasses, to ethanol production. And this ethanol is really helping us to grow, and it is also giving farmer a kind of sustainability which is circular in nature. So yeah, it also helps in GHG emission. And it is also, what we do is we talk to farmers, and we also talk about how do you grow your cane in a better way, which makes it is sustainable. Like, so we've gone ahead and taken Bonsucro, which helps us even convincing our customer that the ethanol carbon which is coming is completely sustainable. So sourcing of cane is important for even converting the whole product into the biomolecules, and convincing our customer that we retain our green carbon, and we are also using regenerative farming practices. Yeah, so these are the certifications which come only after you do kind of practices which are abiding by the sustainability goals. Go to the next. I think this is here. And that's it. So we do a little differently ourselves, is like what we talk about. Typically, people do farming as linear farming, where you use chemical and biofertilizer and pesticide. Our approach is encouraging the farmers to look at circular approach, where they do agroecological practices, they do kind of regenerative farming, and also intercropping of the different crops. Baga's typical approach is generating power, and for GVL, it is for cellulose and 2G ethanol kind of things, which we are looking at. Prismed, we will just use it for biofertilizer. We extract wax and then use it for biofertilizer. So this also increases the efficiency of biocomposting. And molasses is people do make ethanol. We convert ethanol into biochemicals. So a lot of companies today are looking at the products which are made from ethanol based, which are converting it. The green carbon is retained there. Spent wash, generally people do biomethanation. GBL works, I can say it is good or bad, but we do it incinerate and generate power from the spent wash. So this is what circular economy we look at, and we look at each stream which is coming out of our plant is kind of utilized. One thing which is left out is CO2, which we're working very closely with the institutes, academics, institutes to convert that CO2 into various value-added products. Go to the next. Yeah. So I think this is all, which I can just come back to the question which, sir, you asked about MSME. I think it's a very valid point, because a lot of things which are not MSMEs are not self-sufficient to get things done on their own. It's like the ETP, which is very expensive. So if you have to go for all ME, because this is what is kind of told by all pollution control board, that you should have zero discharge. So if we have to kind of incinerate everything, or you have to evaporate every water and recycle, it is a lot of investment. So common ETP plants and all the things which are being done by like MIDCs are great effort on that. But the companies like big companies who can support, ICC is doing some work on this field, where kind of getting them know what are the smaller technology. I think Nitesh has few technologies which can be used by smaller MSMEs for getting zero discharge or achieving zero discharge, or even recyclers. There are some streams which can be recycled and then be used. So that way, I think multinational and the bigger companies can help MSME to achieve their sustainable goals. So it's basically not an individual, it's a kind of a cluster approach can help us to achieve the sustainability goal. Yeah. So that's it. Do we have Dr. Hassan? Did we lose him? I think he's not there. Yeah. I hope I covered the question. Sugandha, you can.
Sugandha, Dr. Hassan, where is this calling?
I think it just dropped.
He just got disconnected probably.
Yeah.
Sugandha, are you there? Sugandha, please remind me of the process. Anybody else remaining now?
I think for all five of us have already covered, so you can have the second round of question.
Sir, 2 minutes. Subhanam is coming. There is some issue, network issue, so she will be coming in 2 minutes.
Sure.
Somebody, Madhvi Kate, is trying to unmute. Maybe the co-host can help her unmute if she needs to speak.
You can speak now, ma'am. I've made you the host.
Actually, Sugandha madam was trying to speak from here, but we are not able to unmute. So she'll be there.
Okay. Madam, what is exactly that the processing of the molasses? I hope that's not like a Kolhapur issue where molasses are polluting lots of river bodies, you know. But at Godavari, the process is well streamlined.
Yeah, we are fermenting, but what you're talking about, it is kind of hereditary of the technologies which were present during those days. So if you talk about 1940s, 50s, when there was no technology to consume molasses, and so that was the technology. So we are all inheriting what is being done in the past. So this
Molasses
is our-
in demand also now.
yeah, now it is.
Probably the people not adopting to it every places like, you know.
Molasses is not, it is on short supply, in short supply. With bioethanol program of Government of India, we made this very valuable product now.
Are you also thinking of scaling up blending of ethanol with?
Yeah, we already supplying to OMCs.
Okay. What percentage blending?
Today, government is, as on date, achieved around 8% blending.
They want to
Go for 20%.
increase to 20%. Yes. Some projects are coming up in Madhya Pradesh and Rajasthan. They want grain seed use and blending up to 20%.
Yeah, the grain is being allowed now. Let us see how it goes. Yeah, Sugandha, you want to? I think Sugandha joined from somewhere else.
Yeah, I have joined.
Yeah. So actually, we lost Dr. Harrison in between. Oh. So, yeah.
So very nice. The discussion is going on very well. I just wanted to ask.
Dr. Sugandha, we can't hear you.
Yeah, not very well. Yeah, you can increase your.
Hello.
Yeah, now it's better. Yeah, it's better. You can speak a little bit.
So I just wanted to ask another question to Mr. Chander. Could you tell me what are the competencies or skills which are required for the sustainability professionals in future?
Okay, thanks, Dr. Sugandha. I will just repeat the question in case some of you have not heard properly.
Please.
Yeah. So Dr. Sugandha asked, what kind of skills and competencies are required for the students who are on the call right now, the chemistry students, to support the sustainability journey that all the fellow panelists have also explained. So yeah, I'll share my thoughts, and others can also pitch in. So first of all, I think it's a very important question, because as we look at the sustainable development goals, they are set for 2030, and so it gives a nice 8-year horizon for all of you who are listening to this event to shape your career, because we now know from listening to all the speakers today and what you see in various media, now there is no doubt in anybody's mind that is global warming happening or not, is sustainability important or not. I think all that time has gone. Now we are looking with a clear deadline, and the amount of work that is happening by government, by industry, by academic institution is all come together and make it happen and achieve the goals in the next 8 years. And I'm sure there'll be another set of goals after that. So it's a wonderful era to be in, first of all, for all of you. Now, what are the skills you will need to capitalize on that and make a very successful career, irrespective of what you are doing? I think that's a very important question. So one is obviously your technical core skills, right, which you bring to the table. So all of you, might do your education and join, any of these institutes, whether it is academics or industry, or in R&D, product development, supply chain, etc., etc. I think all of these can help in this journey. So one is, you continue and develop a very strong technical foundation for whatever you do. Now, as you do that, I think a couple of things are very important. is to, around your core technical skill, try to build a management systems approach, how you implement that skill. So don't be very ad hoc. Try to always, like a typical management system, whether it is quality or environment, always it's a plan, do, check and act model. So whatever you do today, you execute, you review your progress, your work, your efficiency of what work you're doing, and next year make plan and improve it further. Because only when you continue to have that in continual improvement mindset is how we will achieve, these goals. So that's the first management systems approach. And secondly, whatever you do, each one of us are going to be, whatever we do, right, are going to be in a niche area. Sustainability is a very vast topic. Try to develop some breadth of perspective around what you do. Okay, so read on what your competitors are doing. Read what is happening in the startup, economy. If you're an established company, there are startups who are disrupting you. Try to get that breadth of perspective around your core technical foundation. That's the first piece. The two more pieces are, I would say, one is, developing on some very basic core competencies, and last is leadership competencies. Let me elaborate on the core competencies a little bit. Now, if you hear all the challenges that we have around food security, energy, net zero, they are huge, humongous challenges. And what it needs is collaboration, first of all. So it doesn't help in tomorrow's world to be a technical expert and just work by yourself. I think Nitesh and other colleagues inherently talk of a lot of collaboration, and collaboration needs a particular kind of mindset which you need to have. Second is be very aspirational. Don't be pessimistic, because there's always something not working out. There's always some exception to a rule, or there are some companies who will be laggards. Don't get bogged down by those negative stories. And we heard a lot during COVID, right?
Okay, thank you.
I'll just finish in 2 minutes. We heard that, not to be bogged down by negative. So be very, very aspirational. Only those who are aspirational are going to be leaders of tomorrow, and they will overcome all the challenges and continue on that path. The second one, the last one under core competency, I think is, it is not an age where you lead by authority. Okay, you need to lead by influence. And so it's an age where you can see, even as I said, startups are challenging the established companies. You see a lot of stories in society where somebody does a good thing and influences so many people. So we talk of influencers, right? Social media influencers. We don't talk of just the people who have the authority to lead. So I think that also gives a lot of opportunity for all of you young professionals to lead by your good work, and as you communicate your work and motivate others. Okay, because this is all about motivation and passion, and it doesn't come with authority. The last thing I would say is some kind of leadership competency, where think of social innovation, because sustainability is not just about reducing water usage, energy usage anymore, or waste generation. It is about creating impact in society, social entrepreneurship, social innovation that will pay off a lot in future. So think of that. And the last thing I would say is, it is not going to be perfect journey. There will be a lot of ups and downs, but what you should aim is progress over this perfection. Okay, so as a technical background, normally we always look for perfection. The reaction has to balance perfectly. Now that is good in the lab, but in this sustainability journey, it's always about progress. So if there is some improvement, that's great. Next year, under going back to that management system thinking, you work on it and come back with renewed vigor and just aim for progress. I think together, if all of us make progress, I'm sure we'll meet the SDGs and also have a green world for tomorrow. So I'll end there, and I just thought I'll share some of these softer aspects, going beyond your core competencies and technical competencies, which are, I think, required in tomorrow's world. Thank you.
And another thing, just to complement Mr. Chandak, what he added from the college curriculum point of view, I think life cycle assessment is an important skill set and competencies the colleges should onboard within their curriculum. Actually, for sustainability, unless and until you put a number to it and measure it, in many cases you cannot improve it. And today a well-known tool to do that is life cycle assessment as such, because what's sustainable yesterday is not going to be sustainable today, and what's today sustainable, it may not be sustainable. So how do you put a matrix, how do you measure, and how do you improve? So that's something which I would strongly recommend each of the colleges to have that in the curriculum. Over and above that, even be up to speed speed, like what Mr. Chandak talked about, the new developments. Like there are tools around measuring circularity, which is coming. Ellen MacArthur is putting together circularity measuring tools and metrics as such. So I think continuously onboarding that becomes equally important. Thanks.
Thank you, Dr. Menon. I'm sorry that I got disconnected in between due to some technical problem. So I'm sorry that I could not listen to you completely, some of the thoughts, but I'm very happy to hear that as Mr. Mahesh has indicated, how do we actually make that change in the society? So we go back to the society and show that what is the changes. So I think let me ask one more thing, because when he talked about it, maybe Dr. Menon also, or any of the panelists for that matter, can answer this. So I see that the chemical industry is perceived as, I look at actually the role of chemist or chemistry in sustainable development. Always the perception about the chemical industry, or when you see even the photograph, it is not very good. We show the symbol of an industry, something like something polluting to the environment, something like that. So we need to appraise actually to the society. We need to make the society that yes, what we make, there is always a cost benefit analysis that goes into that, and always we lead to a more benefit to the society than actually it is causing any harm or any this thing like that. So what the industry and the academy, or I will say that chemist community together, can make that change in the society, that the perception should be something like that, yes, we meet the aspirations of the common man. So can someone comment about it and say what can we do to do that?
So maybe I can start.
Yeah,
you know,
please,
one of the things we can definitely do is to start off with we ourselves as stakeholders. So all the sets of people who are already a part of chemical community, be it professors, be it students, be it us in the industry, and some of the chemical industry news and media channels that we have. Presenting that clear perspective out there. I'm sure there are more good things happening as compared to couple of few unfortunate accidents and incidents here and there about some reactor getting blast off, or some chemical company throwing some effluent out there into the river. These are actually few I would say instances where something has gone wrong, but unfortunately that captures the news more than the good stuff. If you ask the kind of ambitious goals that Bayer has taken on, as Mahesh shared, and I'm sure the same applies to SABIC and to Godavari. The kind of, if you go down to just asking them to talk about their initiatives, it can cover a whole page in the media, but that doesn't take the priority. What takes priority is some small incident that happened in some small company in Tarapur or at some other location. So I think we need to be much more aggressive ambassadors of the good stuff that we are doing, and how important our products are, that without us the kind of lifestyle and living that people have, they can't sustain. And the importance, so we are almost like air, we are there everywhere, but nobody understands our importance. So it's something like that. So I think it has to start with us who are stakeholders of this industry, advocating chemical industries and our intentions to long-term go green and be safe.
Right, and also adding to what Mr. Mehta spoke about, like taking help of the industry consortiums. We have FICCI, we have CII in India, and they have been doing a great job around these, and even going to colleges and universities and propagating the advantages of chemicals. For example, I strongly believe chemical industry is one of the few industries which not just can abate the CO2 emissions of our own sector, but also many other sectors. actually. Organizations like healthcare and others are getting immense benefit from this industry. There are no replacement for polymeric or chemical substances, may it be pharmaceutical, may it be insulation for in building and constructions or automotive applications. As such, there are huge benefits, which is actually making a big difference. And we are also, for example, collaborating. We actually, the chemical industry and value chain partners actually came together to form an organization called Alliance to End Plastic Waste when this plastic waste issue was really picking up, wherein we have all pumped in money together and we are actually sponsoring startup companies and organizations who can come up with solutions to prevent plastics from leaking into the environment. So one is the advocacy, as Mr. Mehta just pointed out, and over and above that, working with this consortium, maybe Alliance to End Plastic Waste, CII, and putting practical solutions on the ground to kind of mitigate the problems that we are seeing today, and showcasing that and making our society a part of this entire activity also is kind of helping a long way in doing just the plastic waste collection, the kind of infrastructure you are creating for the unorganized sectors, and in a methodical fashion, even raising them to the next level is actually making a big difference. So these are some additional stuff which the industry is doing, and they can do more as such to make a difference.
Yeah, just to add to what they have already, fellow panel members have already mentioned, like I teach one subject on green chemistry. So in my very first lecture, I asked the students, can you imagine a world free of chemicals? So just to talk about the good side of chemicals and the bad side of chemicals. And then at the end of it, they agree that without chemicals, we wouldn't have a lifestyle which is sustainable. Otherwise, we'll just go back to the Stone Age. And then we also talk about, like during the course, we talk about green chemistry principles and various case studies. So I think what I believe is if we can ignite these young minds to think in that way, I think that's going to be the greatest benefit to the society. Of course, these are our ambassadors of chemical industry who are going to go there, work, and then maybe they will have their own companies. And of course, just to add to what Ashok said, so it is just to put in front of them these problems which we are facing, including the plastic waste and all others, and then challenge these minds to come up with some innovative solutions. And of course, that is happening. In fact, the other day, I saw one LinkedIn post where one company has put some boards, and they asked to put the chewing gums, the waste chewing gums onto that. So that company would take out those waste chewing gums, and then they'll make some interesting products out of that. So something like that. So this is very simple thing like chewing gum. We don't even bother about that. It's so at times it's so bothersome. But then you can make something out of it. I think if you can convince these young minds to think in that direction, I think that's going to be a great help.
Okay, thank you, Prashad. Professor Prashad. Anybody else, Mahesh?
Yeah, just very quickly, 3 points. I think for us to define our purpose, as chemistry professionals, how we add value. So first is, I think we have to show the data. And there are many sectors, and I think Ashok alluded, right? Chemical or chemistry professionals can support many sectors. So just agriculture, if you take, nobody can argue with you if you say that over the last 40 years, though the agricultural land has increased by only 5% across the world, the agricultural output has grown by 60%. And this productivity or yield increase, is because of advancements in plant breeding, fertilization, irrigation, and crop protection, where, again, a lot of chemistry has gone into all these sectors. So I think we need to, going back to what I said earlier, the breadth of perspective we need to add as to, why we are existing as a chemical sector, what value we add. So that's first on data. Having said that, wherever we go, we do see some things which are not ideally happening. And there, apart from our, again, core technical expertise, a little bit of ethics becomes very important. When we see something wrong, we need to speak up. We need to, bring it to the attention of the management or whoever are the key stakeholders. And last but not the least, we have to position ourselves as solution provider, not the problem creator. Right. So again, being aspirational, finding out the solution. I think we can only help humanity come out of this crisis. A lot of it comes, is because of the chemistry behind many things that we do in various forms. So we need to, think that way.
Yeah, thank you.
Just wanted to add a few lines, just like
Yeah,
what
please.
the analyst has already expressed. So it's basically talking about how do we project ourselves as a chemical industry, which is adding value to the humankind. It's just like we are creating medicine, food, drinking water, safe drinking water. Apart from that, it's important for the academic institute to bring into the young mind that chemistry is the one which creates so comfort, or it creates whatever we are getting today, food, water, and medicine, and other all aspects. So we need to work on both the fronts. But a long time back, we had seen one ICC advertisement. I don't know, Nitesh, if you remember, ICC had made a very nice advertisement, the chemistry playing in the background with paint. I have not seen it. But after that, I didn't see any media coverage. I think it's important to project ourselves that we are there at every happiness or happy ending of the life. It's not always bad things. So it is important. Yeah, thank you.
Thank you. I think I would like to add one more point where Mahesh has talked about. I think we need to educate our users also for a judicious as well as, I will say, responsible use. If you say, as you rightly pointed out from agrochemical point of view, we have been able to increase the productivity to a substantial level to meet our demand and even to export in some cases. But I could also hear some of the voices that is raised about the pesticides and the pollution and other things. So the right thing is that because the farmers have the tendency to use irrespective of the dose that is recommended or something like that. So whenever they are in distress, so they will end up and finally end up in the products that is available. So what time it should be used and what dose to be used, and again to make it actually more greener alternative, these are all plays a major role in making the society aware as well as for, I will say, a responsible use of the ingredients so that it will cause a minimum damage. I believe Mahesh will also agree to this point, and let us start a campaign, or we ourselves will take charge of the ambassadors for a responsible use of chemicals for our better and greener environment. Mahesh, do you agree for it?
Absolutely, absolutely. And I just, not to take up time, I put my comments in the chat. And I think there's a whole field of product stewardship, whichever sector we belong, where, as chemistry graduates, we can promote responsible use of chemicals. So it's not indiscriminate use, but responsible use. So again, whether you say reduce, reuse, recycle, and so on, and circular economy, I think these are all important. So it's not just profit, right? We say triple bottom line. It's profit, planet, and people, and in the long term that we have to create the impact. Absolutely agree with you.
Great. It was really wonderful. We are running almost, actually we are on, about completing the time. So let me just ask if any of the audience, we have some stalwarts like Professor Savan. I could see that he was attending. So any of the audience would like to pose any questions, any significant questions, or make any comments, it's welcome. 1 or 2 minutes, probably we can still continue. Otherwise, we will wrap up. Is there any questions in chat box or any audience? Yep. If there are no more questions, I believe we had a wonderful time. And I must thank all the panel members. They are esteemed panel members with a lot of knowledge in diverse areas. It was really an eye-opening experience for me. And I could listen to all of you except a little in between time. I am very sorry for, I am apologetic about it. My Wi-Fi was not working properly in between, but it was really wonderful to listen to all of you. And I think at this juncture, what I feel is that we need a concerted effort, including all stakeholders, as Nitesh also pointed out. We have strength in all respective fields, like in academia or industry. But at the end of the day, what the common man they see is what is the final output, what we generate out of it. So we need to integrate our activities, synergize, and get benefit out of this. And need to clearly demonstrate to the public, yes, things are happening, the changes are happening, and we need to come out with something like a disruptive technology that will change the world the way now it is living in a more greener and healthier way. I think so. For that, all stakeholders must work together, either as an ambassador or maybe now you know, each one of you know your strength and where you can catch it up. I think there is no better forum than this to appraise the people that we need to come together, the chemistry community together. Not only the chemistry, I will say the scientists, technologists, administrators, even the policy makers, they do play a major role in devising policies that are conducive for the sustainable development of the country as well as the nation, the globe asset. So let us take a pledge today that we will work towards fulfilling the goals at least by 2030. And I would like to see that India stands among the top in achieving these goals. And I'm pretty sure that people like Dr. Menon, Nidesh, then Prashant, Mahesh, and Sangeeta, all of you are here. You will spread this message across the nation and you will take it in high spirit for making this to realize. Thank you very much for joining in this forum. Thank you once again, and I hope to see you all again. And I will hand over the forum to the organizers. Thank you.
Thank you.
Thank you. Thank you. Thank you.
Thank you, panelists, for your wonderful discussion. I think we will definitely take it further with your valuable suggestions. Now we will have a small break and we will be ending our 2 days national conference with valedictory function. So thank you one and all.
Thank you so much, ma'am. Thank you.
Thank you.
Thank you. Thank you. Bye. Take care.
Thank you.
So we'll continue here, right?
No, we can leave, right? We can.
For 10 minutes. 4 o'clock. Thank you so much.
Shiba, at 5 o'clock, we'll join back.
So 4 o'clock.
Sorry, at 4 o'clock, we'll join, right? I'll be here. Hello.
सर आपको कुछ बोलना है? बस मैं हेलो कर देता हूँ। हाँ सर, आपको वीडियो चालू करो। हाँ सर।
गुड आफ्टरनून बख्शी साहब।
सर है बख्शी सर। सर आ गए।
Good afternoon, Professor Bakshi sir. Namaste.
Good afternoon, madam. How are you?
Namaste, sir. How are you, sir? I'm fine, fine. Thank you. Good afternoon, Dr. Hassan. Hassan, sir.
Good afternoon, madam.
Good afternoon. Good afternoon.
Good afternoon, sir. Bakshi sir.
Ma'am, am I audible?
Yeah, yeah.
Thank you. Should I start, Jonty?
Yes, yes, Ananya, you can start.
Okay. A very good evening to one and all present here. Now we move on to the valedictory function of a national conference here. It is rightly said by Billy Sunday that if you are a stranger to prayer, you are a stranger to the greatest source of power known to human beings. So as per our Somaya tradition, let's seek the blessings of the Almighty and start with the campus prayer. I would now request Jonty to play the prayer.
Give me 2 minutes. There is some issue, I guess.
Is there any technical issue, Ananya?
Yes, ma'am.
Yes,
Yes,
ma'am. Just 2 minutes, I'll try to fix it.
पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ ईशावास्यमिदं सर्वं यत्किञ्चं जगत्यां जगत् तेन दत्तेन भुञ्जिता मा कृतकस्य सिद्धनं मूकं करोति वाचालं पङ्गुं लङ्घयते गिरिं यत्कृपातमहं वन्दे परमानन्दमाधवम् ॐ प्रणो देवी सरस्वती वाजेभिर्वाजिनीवती दीनामविद्रवतु ॐ चोदयत्री श्रुतानां चेतन्ती सुमतीनां यज्ञं ददे सरस्वती ॐ असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतं गमय ॐ सहना भवतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै सर्वेत्र सुखिनः सन्तु सर्वे सन्तु निरामया सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखमाप्नुयात् ॐ शान्तिः शान्तिः शान्तिः.
We are so sorry for the technical glitch, but thank you to all the teachers and students out there for singing it manually. Thank you so much. Let's move forward now. The very pillar of any institution is the principal who has control over all the activities in and around the institution. So we amongst us have a very eminent and dynamic personality who is none other than our beloved principal, Dr. Pradnya Prabhu ma'am. I would request her to deliver the welcome address. Over to you, ma'am.
Thank you, Ananya. Very good afternoon and welcome you all to this valedictory function of this National Conference on Chemistry for Sustainable Development, sponsored by BRNS. We are really fortunate to have today Professor A.K. Bakshi once again. So welcome, hearty welcome. Founding Vice Chancellor, PDM University, Haryana with us today as a chief guest for this function. A man of virtue, recipient of several prestigious awards, a great researcher, renowned academician, and recognized as one of the best teachers in chemistry in India. He has been a strong pillar to support the transformation of teachers in pedagogical skills. Sir, you are truly an icon to serve as a role model for each and every teacher of chemistry and maybe of all other subjects. I also welcome the co-convener of this conference, Dr. P.A. Hassan, head of Nanotherapeutics and Biosensor Section, BARC. Welcome to the chairperson for the panel discussion, Dr. A.D. Sawant, former Vice Chancellor, University of Rajasthan, Jaipur, and Dr. Prasanna Galsasi, Professor MSU, Baroda, and all the panel members who participated and guided the audience. Welcome to all the participants and thank you for making this conference successful. This conference has really opened the new avenues for research and also ignited the minds of the participants. There are challenges of sustainability like energy storage, carbon dioxide and biomass conversion to sustainable solvents and catalysts and so on. Keynote address by Professor G.D. Yadav was a mesmerizing talk and also a pathfinder and eye-opener for a new generation as well as for all of us. We were very fortunate to have a galaxy of academicians and scientists who delivered lectures on various topics on the theme of the conference. My compliments to the Department of Chemistry, the faculty and student for organizing this conference. Once again, very warm welcome to each one of you and thank you.
Thank you so much, ma'am. We have a very renowned personality amongst us, Dr. P.A. Hassan sir. He is the head of Nanotherapeutics and Biosensor Section, BARC, and a professor in Homi Bhabha National Institute. He is a visiting researcher at the University of Louis Pasteur, Strasbourg, France in 1995, and pursued his postdoctoral research at the Department of Chemical Engineering, University of Delaware, USA in 2002 to 2002. He has visited advanced neutron scattering facilities like National Center for Neutron Research, NIST, Maryland, USA, and Institut Law Langevin, Grenoble, France. He has co-authored more than 160 papers in peer-reviewed journals, contributed to 6 book chapters, transferred 2 technologies, and filed 1 patent. He has worked extensively in the area of surfactant assemblies, magnetic nanoparticles, and novel drug delivery systems. His current research interests include self-assembled materials, biopolymers, biodiagnostics, and nanodrug delivery systems. He is also an elected fellow of the National Academy of Sciences, India. We all welcome you, sir, and I now request you to give the concluding remarks.
Thank you very much for your kind introduction. It is a little bit exaggerated, I believe. Let me wish you a very good afternoon to one and all. And at the outset, let me mention that it is a proud privilege for me to make the concluding remarks in this forum. Because there Professor Bakshi and many other luminaries are present in front of this. And let me begin with a compliment to the team at the Somaiya College for aptly organizing this conference. And the theme chosen for this meeting was, as you all know, the role of chemistry in sustainable development, both academic and industrial perspectives. And we had a good number of eminent speakers, luminaries, comprising both academia and industry, who have deliberated during the last 2 days extensively about how chemistry can contribute, or how chemistry has been at the forefront in meeting the sustainable development goals. And I am very privileged to say that Somaiya College has taken a key initiative in this. And of course, there are various other organizations which has contributed for successful implementation of this program. But I am very happy to see that we have the entire gamut of speakers in a broad spectrum of areas that will deal with the role of chemistry in sustainable development. As Pratnya Madam has rightly pointed out, there was a rich amount of talk that is included, which started with Professor G.D. Yadav's keynote address, in which he has clearly mentioned about the role of chemistry in developing new materials and technologies for sustainable development. Especially, Dr. Yadav has mentioned about the technologies that is developed for hydrogen, which is perceived, hydrogen economy, which is perceived as a new and emerging fuel, as an alternative fuels, and the need for looking for new alternative energy materials for energy, for conversion materials, for bio-based fuels as an alternative for the depleting fossil fuels, and our trust for developing materials for mitigating the climate change or many other problems that we face today as far as the sustainability is concerned. We also, I will not go into the details of all the speakers. We know that we are eagerly waiting to hear from Professor, the Honorable Vice Chancellor, Professor Bakshi, the founding Vice Chancellor. So I will just mention some of the main topics that has been covered during the conference. Professor B.M. Reddy from Department of Chemistry, BITS Pilani Hyderabad campus. He has mentioned about the design of novel nano catalyst, oxide-based catalyst for energy and environmental applications. And he has also talked about the carbon dioxide, like how to discuss about various options to address the carbon dioxide emission in preventing the global warming and other challenges. Then we also had Dr. Sadhana Railu from NIRI Nagpur, and she has clearly brought out about the development of deploying various enabling technologies for near neutral or net zero carbon emission. Then Professor B.M. Banage from Department of Chemical Technology, the Institute of Chemical Technology, he has talked about the synthetic pathways that can lead to new biomass derived platform molecule for in synthetic catalysis as well as for various organic synthesis. Then Dr. Tyagi, A.K. Tyagi from Chemistry Group BRC, he has talked about new materials for energy technology such as lithium and beyond lithium, sodium ion batteries and its implications in material science. Dr. Nitin Lebasetuar from NIRI again Nagpur, he has also talked about the steps involved in reduction of the footprint of energy, including the energy generation, energy use, efficiency and management, etc. Then this was also followed by the talk by Dr. Naik Ganesh Naik, who is the director of chemistry program and professor of chemistry at a college of in USA. He has discussed about enhancing the students' interest in sustainability, the role of academy in complementing the sustainable development goals have been discussed in detail, and he has suggested a roadmap how the chemistry community and the academic can get involved in such activities. Then today morning we had talks by various scientists, including by Dr. Goswami from BRC, Dibagar Goswami. He talked about the use of ionic liquids as green solvents for sustainable future. That is their role in developing new material, plastic sustainability by Mr. Swapendre, and many other short presentation by the students. In a nutshell, I would like to say that the conference has deliberated upon various innovative designs and changes in chemical processes that can eliminate hazards as well as help scientists and technologists to achieve the sustainable development goals. So I must also mention that in India, we do have, from this, I must also mention that the chemistry community is, this has clearly demonstrated the chemistry community's major role. I will say the chemistry community plays a lion's share in attaining the sustainability as indicated by the United Nations, whether it is for mitigating the climate change or developing new materials for different or finding alternate or renewable energy sources, or for providing affordable healthcare. We had a lot of discussion about the involvement of pharmaceuticals and pharma companies in providing affordable healthcare to the common man and how chemistry has played a lead role in it, or whether it is meeting the water crisis, another important area where chemistry has contributed, not only in water crisis or environmental pollution and so on. So if you look at in any of these areas where sustainability or the chemical industry is involved, chemist has a major role to play ultimately, and it often gives a new dimensions of the new opportunity rather than as a challenge for the chemical industry. I must say that this provides a new opportunity for the community of academicians, industrialists, and technologists to work together and develop new solutions as dictated by the United Nations mission for attaining the sustainable developments for the entire benefit of the entire mankind. And what I would like to stress at this juncture is that what we need is a concerted effort by all stakeholders, including the policy makers. Again, very much important. Professor Bakshi is here. I can clearly say that. So we need to involve a concerted ecosystem involving all policymakers, academic institutions, and more importantly, the R&D sector, whether it is industry or academia, which involves a major chunk of scientists and engineers, in aligning and strengthening our activities with a focus to achieve the sustainable development goal set by the United Nations. You know, we are aspiring to reach a near zero carbon emission by 2030, and our efforts must be stressed towards reaching that outcome. And I must also stress that the outcome what we anticipate is not something which we can see in a short period of time. So you know the changes we can will be often incremental, because we cannot see a change in climate change or even a change in the energy material what we use, the conventional or the renewable and non-renewable energy sources, the fossil fuels what we are using. It cannot be transformed in a single day or two. So what we will foresee is an incremental change, but we need to look for disruptive technologies that may revolutionize the way we utilize the resources today in our planet. So until and unless we move to such a drastic change through bold decisions, as Dr. Yadav was, Professor G.D. Yadav was yesterday pointed out, we may see that these are very drastic changes. We may not be able to make such changes very fast, but it is important to make such bold decisions and action plan. We need to take bold decisions, and not only the bold decision, but also to devise appropriate action plans to unless we do such thing, we will find it difficult to achieve such a disruptive change with the way we use our resources. Having said that, I have no doubt that about the capability of the young generation what we have, and I am sure that they will live up to the expectations of our society, and they will come up with the innovative and new solution, unique solution to meet this big change. For example, we can also let us look at the recent epidemic condition which we encountered during the last 2 years. The unprecedented epidemic has made a disruptive change the way we deal with our daily lives. For example, we can see that, but the plus point I could see here is that the pandemic has shaken the entire world, irrespective of its development status or the economy, whether it is the developed countries like the US or UK, or in the developing countries like India. We all felt the pain of the pandemic, but the plus point is that we learned a lesson from that. We were able to manage it in an efficient way through timely intervention of the policymakers, our healthcare workers, or our resilience. All this put together gave us a strength to tackle such type of challenges. And I will suggest that this collective action could be taken as a litmus test to sustain or withstand any challenge that come in our way. So by this way, I believe that by a collective action, so we as a community together, the academy, the industry, the government, the policymakers, if all of us put together, we should heed the lesson learned from the wake-up call that we had last 2 years because of the pandemic situation, and formulate the policies and take appropriate corrective action. It is possible to build a healthier, resilient, and sustainable world that will make everyone to lead a healthy and happy life. And with this, I would like to thank everyone for making this juncture of organizing a national conference on sustainable development. I am pretty sure that the message that we gain during this conference, as well as during the panel discussion, will go a long way in meeting the sustainable development goals. So I thank you very much, madam. With these concluding remarks, I hand over this mic to the organizers. Thank you.
Thank you so much, sir, for your presence. We are very much honored to have a dynamic and charming personality amongst us who is none other than Professor A.K. Bakshi sir. He is the founder vice chancellor of PDM University, Bahadurgarh, Haryana. I would now like to call upon Dr. Rohit Singh Chauhan sir, Dean, Research and Consultancy, to introduce sir. Over to you, Rohit sir.
Thank you. On this evening, the task of introducing our keynote speaker is a matter of great privilege and a pride. I know this one is a difficult, but thought he is a man of virtue, distinction, and simplicity. I feel elated to introduce him to everyone on this occasion. Professor A.K. Bakshi is a founding vice chancellor of PDM University, Bahadurgarh, Haryana. He has been executive director of Tertiary Education Commission, Mauritius, during the year from 2013 to 2015. He was selected for the prestigious positions through an international selections. Prior to joining the TEC, he has been a vice chancellor of UP Rajasri Tandon Open University, Allahabad, for more than 2 years. Professor Bakshi has held the prestigious Sir Shankar Lal Chair of Chemistry in the University of Delhi for more than 2 decades. And he was also a head Department of Chemistry, University of Delhi, during the period of 2010 to 11. He has also been a visiting professor at GGSIP, the Institute of Lifelong Learning, as well as Center for Professional Development in Higher Education of University of Delhi. He is presently a chairman of National Resource Center of Chemistry of the MHRD, Guru Angad Dev Teaching Learning Center of the MHRD, and Center of E-Learning. The 3 centers located at SGTB Khalsa College, University of Delhi. He has also been a member of a standing committee of the National Commissions on Education through ICT of the Government of India. He was the chairman of National Science Digital Library project of the CSIR in both chemistry and polymer science. He was also the chairman of the Content Advisory Committee for the Chemistry for Sakshat portal of MHRD, Government of India. A double gold medalist, PhD of Delhi University. Dr. Bakshi did his postdoctoral training at the University of Erlangen-Nuremberg, Germany, with Professor J. Loddick. He was also done the postdoc under the guidance of Professor K. Fukui and Professor T. Yambe. He has been a visiting scientist at TFR and ISC Bangalore in 1997 and 1992. He is the author and co-author of more than 180 research and co-author 51 ebooks, books as an editor, chairman, convener of the working group, and 63 e-modules as an author, co-author for the PG chemistry course and ARPIT programs of MHRD. Many students have obtained their PhD, MPhil under his guidance. He has had a research project from CSIR, UGC, DAE, DST, and his other interests include the innovation in science educations, ICT in higher educations, e-learning, and MOOC. And most importantly, he has been a member of National Writing Team for Chemistry, Class 11th and 12th, books of NCERT. He has been recipient of the several awards and the academic honors. These include, among others, his Excellence Education Award 2021, International Public Figure Award 2020, Acharya Chanakya Shikshavid Samman 2020, World Education Award 2017, Haryana Ratan, a special award for the excellence in digital content of educations, Dr. R.D. Desai Award for Indian Chemical Society, P.K. Bose Memorial, and so on. List is quite long, and due to the time constraint, I'm not able to cover all. Hope sir will pardon to me. In addition to this, Professor Bakshi was facilitated 2 times in September 2009 and December 2011 for the distinctive and outstanding contributions to education, including the e-transformations of University of Delhi by the former President of India, Dr. APJ Abdul Kalam. Professor Bakshi was elected as the President of the Section of Chemical Science of the Indian Science Congress Association for the year of 2011 to 12. Professor Bakshi has been a member of editorial boards of the Indian Journal Chemistry Section A from 1999 to 2001 and the Journal of Scientific and Industrial Research published by CSIR and the chief editor of the UGC-sponsored journal, Chemistry Education Review. He has also been a member of various professional and academic bodies and committees of MHRD, UGC, NAC, DST, CBSC, NCRT, and the various university and college. Last but not least, Professor Bakshi has also the distinctions of being one of the first person from the universities in India to have been selected as the member scientist of 3rd Indian research expeditions to Antarctica in 1984. A popular saying in the Sanskrit is well suited to him. Vidvatam cha nipratam cha navtulyam kadachan swadese pujate raja vidwan sarvatra pujate. A scholarship and the kingship can never be equal to each other. A king is honored only his own country, while a scholar is honored everywhere. With this word, I would like to invite and hand over this mic to Professor Bakshi. Thank you so much.
Thank you very much, Dr. Rohit, for your very kind words of introduction. It's indeed a great honor and a privilege to have this opportunity to share some of my thoughts at this very important conference on chemistry for sustainable development being organized by KJ Somaiya College of Science and Commerce in collaboration with the chemistry division of the BARC. I would like to express my gratitude to Professor Pradanya Prabhu for her kind invitation to me to be a part of this event. Thanks a lot, madam. And it was indeed a pleasure listening to the concluding remarks by Professor P.A. Hassan. He covered everything in very details, and it was really thought-provoking. You know, this is basically a valedictory function, and we are coming close to the end of this conference. So while I was thinking as to what should I say, because I have not attended most of the sessions, but then I thought, let me make a very small presentation on what my views are about sustainable development in India. So please excuse me if these are repetitive, but that is what my perception is, and that is what I would like to present. So please allow me to share my screen. Is my screen visible and am I audible? Thank you.
Yes,
Thank you
sir.
very much.
Yes, yes, sir.
So this is what I think my talk would be focusing on towards sustainable development, a roadmap. You know, first question is, what is sustainable development and what are sustainable development goals? Mahatma Gandhi once remarked, one must care about the world will not see. So that is basically what we want. We have to take care of our planet. Yesterday, as you know, was Earth Day. And one of the goals of the Earth Day is that we should have a mission to protect and hand over this planet to the next generation. There are many definitions of sustainable development which are very common, meeting the needs of the present generation without compromising the ability of future generations to meet their own needs. Our sustainability is the possibility that human and other forms of life on Earth will flourish forever. Or another definition, as you can see, is enough for all forever. So these are different, meanings given to sustainable development through different definitions. Now, the first question comes, why do we bother about sustainable development? In the world, there is a population explosion. If you look at this slide, in 1950s, we had world population 2.7 billion, which has now come down to almost 7.8 billion. And by 2050, it will become 9.7 billion. So this is one issue of worry, because all this will lead to the fast depletion of resources, including food, minerals, and other natural resources. There is also going to be a problem of water scarcity. There is a Food Agricultural Organization report that by 2025, 1.8 billion people will be facing acute water scarcity. There is also a problem of environmental degradation. There is also an issue of climate change, rising sea levels, increase in atmospheric temperature. So all these are the issues of concern which call for the need to sustainable development. Keeping these things in mind, as we all know, United Nations gave 17 Sustainable Development Goals. But please note, no roadmap was given by them. And these goals have to be achieved by 2030. Why no roadmap was given? Because world is full of diversity. And the nature of the problems varies from region to region. So what could be a solution in one region may not be applicable to others. But one thing is clear, that sustainable development goals have the potential to significantly improve the quality of life and increase the well-being of the people. So there is no doubt about that. So SDGs have to be viewed from that perspective. One may say that these 17 goals with almost 169 targets address the global challenges we face, including poverty, inequality, climate change, environmental degradation, peace, etc. And it's very rightly mentioned that SDGs are considered a roadmap to humanity. Now, if you look at these 17 goals, they can be divided into 3 categories: economic, environmental, and social. And that is what we say are the 3 pillars of sustainability. But one thing one has to keep it in mind, that these are the 3 pillars, but if you really want to obtain sustainable development, these 3 have to work together. When we talk about economic sustainability, it means building and developing economies of the countries without straining the resources. Then you can see that environmental protection means maintaining the quality of natural resources and wherever possible, reversing their degradation. And social well-being means ensuring the social prosperity of the people. When I talk about 3 goals, I take it that if you do it one, it will affect the other. So you have to take care of all the 3 together. So that is something which is very, very important in this sustainable development. You have to work on economic front, social front, and environmental front. Now, having said this was just a very elementary thing which I said, but I just wanted to recapitulate. This conference is focusing on the role of chemistry in sustainable development goals. If you look at these sustainable development goals, those goals which are relevant to chemistry are these 8, mainly. You can see hunger, well-being, clean water, industry innovation, responsible consumption, all these things, these are relevant to chemistry, including energy and climate action. So chemistry can help us our chemistry can play a very important role in meeting these goals. I'm not going to discuss what chemistry can do, but what I could think is that, for example, if you want zero hunger goal, then chemists can help in the protection of plants from pest infections. They can help in food production. They can help in active packaging to prevent, as you can see, food spoilage. So chemical research can help here. Then good health and well-being is another goal where also chemistry can help. You try to get an insight into how human health is impacted by diseases, etc. Then medical diagnosis and drug development, and then solutions for reducing pollution. So here again, chemistry becomes relevant. And if you look at the next goal, clean water and sanitation, as you can see, here chemical research can help by, devising new methods of water purification, lower cost of desalination process, or you remove heavy metals from impure water. And then in regard to affordable and clean energy, chemical research should be focusing main on newer materials for renewable energy, advancing, cleaner fuel technologies, and improving manufacturing efficiency in chemical industries. So these are just the broad areas where chemical research should focus in order to achieve these goals. In regard to industry, innovation, and infrastructure, chemical research can help in upgrading infrastructure in chemical industries, then manufacturing novel, innovative, advanced materials. And these days, there is a lot of focus on tailoring of the materials. Once you have an understanding of structure property relationship, you can design materials according to your needs. And then encouraging chemical research to enhance innovation. And in regard to responsible consumption and production, this is also one of the goals. You need to focus on recycling materials, how you can do that. Bio-based feedstocks, second generation biofuels, you need to develop them. Then innovation in waste management system. So in all of them, chemistry is playing a role. And lastly, another important is climate action. Here, advancement in atmospheric chemistry can be a big help. Then you can develop advanced materials for renewable energy, improve treatments for disease and high yielding seeds, and fertilizers for increased food production, etc. So I fully agree that chemistry has a very important role to play in sustainable development, but mainly in respect of these 7 to 8 goals. And for doing research in all these, I personally feel chemistry education can play a very important role. People should be aware of where their research should be directed. There is a need of globally competent but locally relevant research. One should not be oblivious of the fact that problems of sustainability vary from region to region. In which region, what is the preferred chemical research, that one should be told. So my feeling is that we need to focus more on chemistry education, which builds the foundation, because chemistry education is ultimately the foundation of chemistry research. If today we are not able to do research well in chemistry, it could be because of our chemistry education. For example, other day somebody was asking me that why is it that since 1930, no Indian scientist working in India has been able to get a Nobel Prize. C.V. Raman got the Nobel Prize in 1930. After that, it is almost 90 years. And no Indian chemist has ever got a Nobel Prize. Why? After all, what's wrong? Always there are some peaks of excellence here and there. But whether they are because of the system or in spite of the system, that's a big question mark. So this is a food for thought. And one should not forget that chemistry knowledge is growing very, very fast. Because doubling time of growth of chemistry knowledge has shrunk considerably. There was a time when human knowledge was doubling in 150 years. And now this time has come down to 73 days. So what I mean to say is, what in any discipline, what we know is merely a drop, and what we do not know is an ocean. Look at this. Chemists produce new substances. So there is an exponential growth in the number of substances. In the year 1800, we had some hundreds of chemical substances. Now it has grown, and by the end of this century, it is expected to reach 5 billion. So you can very well imagine how fast the knowledge is growing. Number of elements in the periodic table has reached up to 118. Many new and modern instruments have come. Many new ideas, concepts, theories are emerging on the chemistry scene. So until and unless all these are made a part of chemistry education, we cannot produce researchers who can do state-of-the-art research, which is the need of the hour. Look at this. Now, so many sub-disciplines of chemistry have come. When we were students, we were talking physical, organic, inorganic, analytical, etc. But now the list is growing day by day. And in all these, green chemistry, as you all know, plays a very important role. How green chemistry works, what are the various principles of green chemistry, how to apply them, all this should become a part of chemistry education program. That is what I mean, because then those people who are well versed with these principles, they will be better equipped to do research relevant to the sustainability development goals. That's my point. Therefore, last point which I want to say is that there is going to be an important role of education for sustainable development. Sustainable development, if I may say so, requires human ingenuity. People are the most important resource. So quality education should form the basis of sustainable development. This is my feeling. Our future relies on human ingenuity. And how we will get genius people coming out of our education system? Through our education, through encouraging people to think, not what to think, but how to think. So it ultimately comes down to the basic level of our enhancing the quality of education, because our education system still focuses on, rote learning, scoring high marks, etc., and examination. Our education system need to focus on encouraging thinking, innovation, and creativity. If there is a crisis in India, it is a crisis of creativity in Indian education system. We need to overcome that. That is my feeling. So education for sustainable development will promote the development of the knowledge, skills, understanding, values, and actions required to create a sustainable world which ensures environmental protection and conservation, promote, as you can see, social equity, and encourage economic sustainability. The simplest language is you live what you learn. That is what is required. And in this, there is a sustainability development goal 4. That's basically the quality education. And this is already being given a lot of importance. It ensures inclusive and equitable quality of education and promote lifelong learning opportunities for all. And, it is said that education for sustainable development is recognized as an integral part of SDG 4. It is one of the targets. But it is a key enabler of all SDGs. Everything you can achieve through education. That is the point. And technology is going to play very important. For example, look at lifelong learning opportunities. So much is happening in the education scenario. You must have seen during even the last few months or during the corona time, technology has played such an important role. There was a time, we still have, for example, about 1,000 universities, 50,000 colleges. Our gross enrollment ratio is 26.3%. And now the government's target is gross enrollment ratio of 50% by 2035. So how will you, within the next few years, reach that level? You can't open new campuses, you can't open new colleges or universities or infrastructure you can't have. So it is all through technology. Online education is becoming popular. E-learning MOOCs are becoming very popular. Already autonomous colleges have been given the power to award online degrees. So you can see how the things are changing. So education can play a very important role. And these are the 10 targets of this Sustainability Development Goal 4, which is the quality education. These are the 10 targets. And you look at the goal target 4.7, that is sustainable development. So it is included in that. So what can be achieved through education may not be possible to achieve through others. Others have a role, but education is like a mass movement. It will change the masses. Because ultimately what we are trying to achieve is for humanity. So we have to involve all people in the humanity in this endeavor. Perhaps we should also keep it in mind that before sustainability development goals, there were Millennium Development Goals also, which were to be achieved by 2015, 2000 to 2015. Millennium Development Goals, which were also given by United Nations. These are the 8 goals. And the success which we have achieved in respect of these Millennium Development Goals has been mainly due to education. Education has been a key factor in achieving Millennium Development Goals. And this is the success which we have achieved. Share of the poor people has been reduced by 50%. In respect of universal primary education, 90% of the children now go to primary schools. In respect of gender equality, equal number of girls and boys have started schooling. In respect of child mortality, 17,000 fewer children died each day other than 1990. Then you can look at the improving maternal health. Maternal mortality fell by 45%. Look at and ensure environmental stability. 2.3 billion people gained access to clean drinking water. So all this has been possible through education only. And sustainability development goals are the followers of Millennium Development Goals. Look at this. Millennium Development Goals are the foundation, and on which now are the Sustainability Development Goals. And there also, education is going to play a very important role. It is being felt that there is a need to integrate sustainable development with both school and higher education. Let children from school level onwards understand what is sustainable development, what things they have to keep it in mind. Please remember, Earth can support billions of more people if people make sound choices around resources, production, and consumption. People of all ages and from all walks of life need to start thinking and acting more responsibly towards our environment. Right information and education can change people's views and behaviors and encourage them to adopt sustainable development lifestyles. This is the need. Change of mindset is required. Let me tell you, I honestly admit that still many of the chemistry teachers in the country may not be aware of what are these sustainability development goals. How many of them will be knowing? Not many. So it should be made a part of the education system. It can bring about the desired transformation. It can also break the cycle of poverty, malnutrition, disease that affects the people so many all over the world. Students need to be trained, making them more socially responsible, critical, and sensitive towards sustaining issues, sustainability issues. Education system, I mean, teaching, learning, and research need to be aligned with sustainability development goals. They should be part of the curriculum. I hope all of you remember that in 2004, environmental studies paper was made compulsory for all people in the universities. Something similar should be done. There should be a paper on sustainable development in India, something like that. So that everybody learns, everybody is involved. And then things will start changing. ESD and United Nations SDGs go hand in hand. Have you noticed the fact that the new education policy 2020 of MHRD and the National Health Policy 2017 of the Ministry of Health and Family Welfare, if you examine them, they are aligned with the sustainability development goals. They try to achieve them. So all their provisions are basically aimed at that. Even many of the flagship policies and the programs of the government of India, such as Swachh Bharat Mission, Beti Bachao, Beti Padhao, Pradhan Mantri Awas Yojana, Pradhan Mantri Jan Dhan Yojana, Deen Dayal Upadhyay Gram Jyoti Yojana, and Pradhan Mantri Ujjwala Yojana, they have substantially contributed to India's progress in this regard. Because India is a signatory to that United Nations, those goals. So in our higher education system, the problem is, there is a serious problem that our curriculum and course outlines are rigidly followed. We need to change. We need to have a multidisciplinary approach. Then pedagogy of teaching is also very tightly specified. Integrated approach is missing. Even as a chemistry professor, when I teach physical chemistry, maybe I'm not touching organic or inorganic. No. Science is a systematic study of reality. Different branches of science, physics, chemistry, biology, botany, they are a part of that reality. This is a man-made compartmentalization. So we need to integrate approach. Interdisciplinary approach is the need of only then people will appreciate. Otherwise, everybody, if I say that I have nothing to do with organic chemistry or I have nothing to do with physical chemistry, that's not the way things will work. Teachers themselves are not aware of the concept of sustainability development goals. SDGs research is missing. Teaching is missing. We have experts in universities and colleges, but their expertise has to be used in this way so that there is a mass awareness. Everybody who comes out of the education system is well aware of their responsibilities as to how they can contribute to the sustainable development. People generally do research in their own areas, although we are talking about chemistry research in respect of SDGs. But how many people work in those fields? There are so many fields which may have nothing to do with SDGs. So we need to integrate sustainability into curriculum. And the best way is try to achieve sustainability development goals in your own community. Other day, I got a report from one of the universities. Within the university campus, they have achieved sustainability development goals to the extent possible, because they know how they can do within their own campus. So that is something we do, and the best practices which they follow, those should be, exchanged with other institutes and collaborated. So that's basically what I feel could be the roadmap. Please remember, sustainable development for all countries is only truly possible through comprehensive cross-sector efforts that begin with education. That's basically the gist of the entire talk which I'm giving. Thank you very much. It was a pleasure talking to you, and this is my email, this is my mobile number. We should remain in touch, and all the best. And once again, Madam Pradanya Prabhuji, for giving me this opportunity, and also pleasure to know Professor Hassan also today. And thank you, sir. Thank you very much. All the best.
Thank you so much, sir, for your enlightening session. I, on behalf of KJ Somaiya College, thank you for showing your presence amongst us and gracing our conference. So now we move on. No department runs smoothly without the guidance of a strong and powerful head. So here I call upon our head of the chemistry department, Mrs. Madhvi Kate ma'am, to propose the vote of thanks.
Respected Chief Guest of Valedictory Function, Professor A.K. Bakshi, Founding Vice Chancellor, PDM University, Haryana, Principal Dr. Pradnya Prabhu Madam, other dignitaries, my colleagues, and dear participants. A very good evening. A very good evening to one and all. After smooth and successful completion of our 2 days national conference on chemistry for sustainable development, it is really a pleasant task to propose a vote of thanks. At the outset, I express my heartfelt thanks and gratitude to Professor A.K. Bakshi sir for guiding and gracing today's valedictory function as chief guest and addressing the participants. We are privileged to have listened to you before also, sir, and it was very inspiring and informative to listen to you, sir, again. The theme of the conference is Chemistry for Sustainable Development, Academia and Industry Perspective. I think industry perspective was very much emphasized, and you made that academia perspective very much clear, sir. So thank you very much for that. During our 2 days conference, we had very informative and enriching sessions by Professor G.D. Yadav sir, Professor B.M. Reddy sir, Dr. Sadhana Rayalu madam, Professor B.M. Bhange sir, Professor A.K. Tyagi sir, Dr. Nitin Lapshetwar sir, Dr. Dibakar Goswami sir, Mr. Sapan Ray sir. My heartfelt thanks to all the resource persons for their very enriching sessions. My thanks goes to Dr. A.D. Sawant sir and Dr. Prasanna Ghalsasi sir for chairing the sessions of short presentations, and all the panel members for panel discussion. Because of the full support of our management and our principal, Dr. Pradnya Prabhu Madam, it is possible to conduct such activities. Hence, my heartfelt thanks to Somaiya management and to you, madam. The entire conference is conceived and executed by my colleague, co-convener of this conference, Dr. Sugandha Shetty, and Dr. P.A. Hassan, head Nanotherapeutics and Biosensitizers section, Chemistry Division, BARC. So a very big thank you to both of them. My thanks to all the organizing committee members of our chemistry department, technical team, and lastly but not the least, all the participants. I hope this conference must have sensitized young minds about the importance of sustainable development. Because small acts, when multiplied by millions of people, can transform the world, and hopefully the sustainability revolution will be third major social and economic revolution. So thank you all once again. Thank you. So over to you, Ananya.
Yes, ma'am. Thank you so much. We now conclude the session here.
Okay, thank you everyone. It was really a pleasure to meet you all here, and I am signing off. Thank you.
Thank you, sir.
Thank you, sir. Thank you.
Thank you, Professor Bakshi, for joining. Thank you so much. And your kind words.
Thank you very much, madam. Thank you.
Thank you, sir. Thank you, sir. Thank you. So nice to see you online. Let us hope to see you offline as well soon. Maybe when we have some function in Mumbai.
Sure, sure. Thank you very much.
Thank you, sir.
You are in, I think, BARC Chemistry Division.
Yes, sir. Chemistry.
One of my students is there, Rajesh Vatsa, you know?
Yeah. Of course, very much I know.
I taught him.
Oh, very nice, very nice. He is actually our head of DAE's Public Awareness Division.
Okay.
So now he sits at our headquarters, that is at near DTU of India.
Say my hello to him.
Yeah, sure. I will.
Thank
you. Very much in our division, and I was also associated in the same division.